Good morning, everyone. Welcome to the Axelar Interop Summit. We invite you to find your seats as our program will begin shortly. For those of you that are going to be attending the hacker stage, it is next door, so it's behind us, and you can go through the door and grab your silent disco headphones. They'll be located at the entrance to the hacker stage. This stage in this room is the gateway stage. So if you're in here, this is a gateway stage, and we'll be kicking off at 10 a.m. Thank you. They're separate PAs. So she's making a separate one for them to come here. Good morning, everyone. Welcome to the Axelar Interop Summit. You are in the gateway stage. If you are supposed to be in the hacker stage, you need to go behind you and go across over to that stage. In there, you'll grab your headphones for the silent disco, but you are in the gateway stage in here. And if you would, please take your seats. We'll begin shortly. Thank you. Ladies and gentlemen, please welcome Galen Moore.
All right. Welcome, everybody, to day one of the Interop Summit. We've got a lot of work and play to get through over these next 2 days. But before we start, I want to begin with a little survey of the crowd. How many of you here in the audience hold a Cosmos chain address? Cosmos chain address, raise your hands. Very good. Okay, look around. Everybody see your Cosmos people. Check out your Cosmos people. All right. Put your hands down. How many in the audience here hold a Bitcoin address? Hey. Watch it. We're all Satoshi, okay? How many hold a Bitcoin address? Raise your hands. Don't be shy. Good. These are all your Bitcoin people in the audience here. Okay. How many hold an Ethereum address here in the crowd? Okay, very good. Okay, all the Ethereum people, look around. Greet your neighbor. This is the only place at ethdenver Biddle Week where you all can talk to each other, okay? This is a very exciting place to be, in fact, because today and tomorrow at this conference, we're going to work together on building permissionless on-ramps that can replace the permissioned database on-ramps, the FTXs, the Celsiuses, the Voyager Digitals, that were the on-ramps in the past bull market. Replacing those with permissionless open blockchains that convey the benefits of an open blockchain. Freedom from censorship, self-sovereign ownership of data, global access. Convey those benefits to users on any blockchain holding any token. There are people in this building today who have built products, have shipped them, that users, developers, can get hands-on with today. That's pretty exciting. But before you get hands-on with them, there's a few little pieces of information I need to impart. The first is that this room we're in here today, right now, is the gateway stage. The gateway stage is where you're going to see 30,000-foot vision, the far sight of projects like ZK Sync, SWI, Uniswap, and others. The feed from this stage is going to be streamed live over YouTube. You can find links and information to that on the Interop Summit Twitter. Interop_Summit is the Twitter handle. Second thing you need to know is that the hacker stage is just out that door behind me there. Through the left, through the networking area, and through the door over there, you'll find the hacker stage. Now that's where you'll be able to open up your laptops, put on your headphones, and get real with projects that are building in the Interchain. Projects like Compound, MetaMask, and Starkware. Okay, third thing you need to know. If you meet somebody in that networking area, and you start an interesting conversation, and you will, the Luster Pearl right across 26th Street is our overflow space. In there you'll find refreshments, room to chill out, a live stream of the gateway stage, and a press room in the upstairs for interviews. Finally, tomorrow morning, bright and early, the Biddle Breakfast. Do not miss it. We're going to have investors and grant programs here ready to deploy capital and eat breakfast with you. So, without further ado, it is my profound honor and pleasure to introduce Axelar's head of developer relations, a veteran of Google and Chainlink, ladies and gentlemen, Stephen Fluin.
Well, good morning, everyone. I see a lot of people in the back standing up. We have lots of seating in the front here. You're welcome to come join, hang out. So the purpose of this session is really to help everyone start to think interchain. Think about the connections between the blockchains. Think about the differences and the ways that we can take advantage of them. And part of the way that I want to start this off is by telling a little bit of a story about a young crypto Steven. This was about a year and a half, 2 years ago, where I'd been building smart contracts for a while, and I started, hey, I want to actually go to production. I want to go to mainnet with these smart contracts. And so I looked around at all the chains that were around, and I decided, hey, I think I'm going to ship Polygon. I'm going to ship all of my smart contracts on Polygon. I'm going to actually ship some dApps. It's going to be really exciting and really fun. And so in order to make this transition as a developer from moving from testnets over to mainnet, you actually need currency. You actually have to buy the currency and the tokens to do those smart contract deployments. And I thought, this is going to be really easy. I'm just going to go to an exchange, buy some Matic, which is the token of Polygon, and then I'll be able to deploy my smart contracts. So I went to Coinbase. Maybe this was a dumb decision. Maybe you're all laughing at me. But it's a pretty well-known name. And I went to Coinbase, and I bought $10 of Matic, and it says Polygon. This is the current UI. It was the same UI then a couple years ago. And I thought, OK, I'm going to be buying the right token. I'm doing the right thing. I'm going to be able to deploy my smart contracts. I initiate the withdrawal from Coinbase. It ends up in my wallet on the wrong chain. If you've ever bought Matic on Coinbase, you'll later discover, not at the beginning, but after you get into a little bit, that you're not actually getting Matic on the Polygon chain. You're getting Matic on Ethereum, which is how the Polygon chain originated, right? So I actually got the wrong token. And this was actually a big problem for me because when I asked other developer friends, like, oh, just bridge it over. It's very easy. And I'm like, OK. So I pulled up the bridge. OK, you need Ethereum gas in order to bridge Matic to the Matic chain. And so now I'm like 3 layers deep where I'm like, OK, now I have to buy an additional token, withdraw that additional token, pay the additional fees, execute transactions on Ethereum, which are very expensive. Right? This would eat up a lot of that $10 of Matic that I bought in order just to deploy a smart contract. And the reason I tell you this story is because in some ways, the way that we make developers think about all these different chains is fundamentally flawed. We need to get to a world where we, as the creators of these systems, are thinking interchain and trying to design abstractions and make sure that this becomes a much easier process for everyone out there so that the next great innovator that comes along doesn't get stuck with the wrong token on the wrong chain. And this is actually a problem that's getting worse from some perspectives. There's this thing called the paradox of choice, where the more chains that come out, the more time that passes, our ecosystem gets more and more complex. Right? The complexity is increasing. The number of options and choices is increasing, which sounds like a really good thing. But when you keep expanding and expanding, what you're actually doing is you're making it more difficult for new entrants. And so as we look to the future of blockchain that I think a lot of us see, we have to continue thinking about what does this experience feel like for new people? And how do we make sure that as we're adding more choice, more capabilities, more features, we're not making it more and more difficult for new entrants, which is going to scare people away. And I'm really excited about the Interop Summit. And one of my favorite parts about the Interop Summit is actually the second word here, summit. I prefer summits to conferences because when I think of a conference, I think of a place that everyone's going to sit in the audience and you're going to absorb information. You're just going to sit there, maybe you'll take notes on a phone or a laptop, and maybe you'll share that when you get back. But a summit is a place where people can actually come together. It's a place where people can come together and actually create together, co-create this future. And so that's what I'm really, really hopeful that we're all going to be able to take a chance to do today and tomorrow. So as Galen mentioned, my name is Stephen Fluin. I'm head of developer relations at Axelar. The way that I think about developer relations is that I have two parts to my mission. The first part is making you successful. So whatever success means to you, maybe that is you want to go win a hackathon. Maybe that is I want to go get funding for my startup. Maybe I want to take my dApp and go to mainnet. Whatever that is, I want to figure that out and make sure that we are giving you the tools, the education, in order to achieve that. And the second part of that is really empathizing with you. I want to actually know what it's like sitting out there in the audience, being a developer, being a newcomer to the space, and make sure that we're using that empathy and that understanding of what it's like for them to make sure that we're building the right tools, that we're telling the stories in the right way. Everything about this industry is still in flux. We're still figuring everything out. And I think if we figure it out together, we're going to be doing a much better job. So today's talk, we're going to go through this in 3 sections. First, I want to talk about the future being interchain, and I want to give you several principles on which I believe that's going to be the case. Then, I want to talk about how we can all come together to build better dApps. And lastly, I'm going to kind of ask everyone here and figure out how we can build more meaningful abstractions to make this process easier for everyone. So let's kick things off. I believe that the future is interchain. And I've heard a couple of questions in conversations yesterday about interchain. Yes, that is a term that has come originally, I think, from the Cosmos ecosystem, but that is not how I'm using it. When I say interchain, I mean all of the connections between blockchains and how they make things meaningful for you as developers, whether that's EVM, Cosmos, Solana, any chain, right? Interchain is us thinking about how these things can come together rather than being separate. So principle number 1, the number of chains is increasing. Again, think back to the young little crypto Steven, and I thought something. I thought that, oh, we're going to get rid of all these chains. We're only going to need one blockchain eventually. One blockchain, they're going to have all the features, and it's going to solve all the problems for us. If you look at the data, if you look at the developer choices that everyone's making out there, I was completely wrong. The number of chains continues to increase. And I think one of the big reasons behind this is that our needs in blockchain are based around decentralization. And so those decentralization needs are driving decentralized innovation. Innovation is not coming from one company because everyone has different needs. And this is something I'm going to explore a little bit further as well. So there's this website, Chainlist. Has anybody used Chainlist before? Okay, a bunch of people. So it's just a list of chains, basically. It's in the name, it's pretty simple. There are 455 mainnet chains listed on Chainlist right now. So if you think back 3, 4, 5 years ago, maybe it was safe to just say, I'm going to build on Ethereum. But that choice is not as safe today, right? You need to be thinking, you need to be considering what are the chains that are out there, what are the chains that are right for you. And I say that there's 455 chains on here, but that's actually wrong. That's only the EVM chains. That's only the Ethereum-based chains. And again, I'm even more wrong because that's only the, we're completely ignoring things like Solana, Cosmos, all the other chain stacks that are coming out. And beyond that, this is a list that's created by people, right? I'm sure it's open and people can contribute and things like that. But we are a decentralized ecosystem. Not all of the chains that exist are even on that list. And so with all this decentralization, with all these different tech stacks, there is no master list of all the blockchains out there. And so we have to continue thinking and continue exploring and pushing the boundaries of how we can find new connections. All right, principle number 2. The number of dApps is increasing. Hopefully this isn't surprising to anyone in the crowd here, but I want to tell a little bit of a story about Microsoft. So a long time ago, the Microsoft product managers were looking at Microsoft Word. And they said, wow, we've got a lot of features. A lot of people are saying that Microsoft Word is becoming more and more and more complex. And so they did a bunch of surveys, they did a bunch of UX research, and they discovered that the average user uses 40 features of Microsoft Office. And they thought, okay, this is great. We'll cut the rest of the features, and we'll hit the majority of users. But that wasn't actually what they discovered. So while the average user only used 40 features, they all used different 40 features. And so anytime you start cutting out any feature from the platform, you start losing users. And so this is really, really a good analogy, I think, for the blockchains that are out there. There is no one blockchain that can have all of the features that every developer needs. There's trade-offs that we have to make between speed, scalability, cost, all those sorts of things. And so when we're building Interchain, we're thinking Interchain, you're not going to have one chain that solves all those needs. And so if we spend more time trying to understand the specific chains and the specific use cases that we're supporting, we're going to be much more successful. To build on this even further, the number of dApps is just increasing, right? Every user has different needs: privacy, cost, security. And not only do the users have different needs, but the developers have different needs, right? We talk about things like upgradable contracts. That is a need that is driven by developers who are not going to get things right on the first try, but fundamentally go against some of the principles of decentralization. And so how do you balance these things? So the more dApps that are out there, the more chains we're going to need, and the more we're going to need to think interchain. So principle number 3, decentralization is increasing. This is a chart from DeFi Llama talking about total value locked. And if you look at this chart over time, what you'll see is that centralization is yielding always, 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 and continuously to decentralization. I'm sure 5 years from now, this list is going to be very, very different. We're going to see a bunch of new chains on there. We're going to see a bunch of different players that are driving the ecosystem forward. So if you, as a creator or a dApp developer in the space, want to change the world, you can't just go to a single chain anymore. You have to be everywhere. You have to be interchain. All right. The second section I want to talk through a little bit here is about building better dApps. So I want to start with a little bit of a precedent, because we've had standards for a long time. We've had things on the internet that have made it very, very successful. And 2 that I'll call out in particular: HTTP, the hypertext transfer protocol that we use for basically every web page out there, and SMTP, the simple mail transfer protocol. These 2 technologies have underpinned, from my perspective, a lot of the growth of the internet and the fact that we're all in here. Does anyone here not have an email address? Like, I know we're on Telegram, I know we're on WhatsApp, but everyone here has an email address. And that was only possible because of standards like SMTP, right? And we've actually been very lucky. We have built together collaboratively across all the countries of the world, all the ecosystems of the world, a unified internet, where because we have these standards, because we have these protocols, users can use whatever client you want, right? You can go get a Gmail address. You can go run your own mail server. You can run your own web server. You can use whatever. You can use Chrome, Opera, although there's decentralization questions there, but we can explore that later. And the idea that users can connect to whoever they want to, right? Other people, other applications. And this is the magic of the internet. This is what has allowed even blockchain to come to the forefront, is that we're all innovating together in the same sphere. And blockchain in many ways has this, right? Blockchains are decentralized. You can use any client, you can use any node, right? Like if you look at the Ethereum blockchain, there's intentionally multiple projects trying to build nodes for validators, right? Because that decentralization powers the network. It drives us to better innovation and better quality and better decentralization. And as a person that exists on a chain, I can connect to any dApp, right? I don't need permission. And this is magical, but there's a problem here if you contrast that with what we've got with the internet. Within blockchain, we have 455 plus internets where we can't actually communicate between all of these different blockchains. We have these standards, but we don't have standards between them. We don't have these interchain standards. And so it really ends up being up to the dApp developers to take this on, because dApp developers are the ones that have the power to unify. And I would even say that they have the responsibility to unify as we think about the number of chains continuing to increase and the needs, the various needs of all their users continuing to expand. When I think about a developer learning this space, it starts with 2 stages. It starts with this first concept of unlocking, where you'll hear about blockchain, you'll get excited, you'll discover your favorite L1, and you'll say, I'm going to learn that tech stack, I'm going to go learn Solidity so I can deploy on XYZ chain. And that's a magical moment. It's an important moment where you start getting used to this idea of thinking in a decentralized way. But then later comes scaling. And scaling involves a lot of different decisions that you have to make as a company, as an individual, as a team. What am I going to do about gas costs? What are the fundamental economics of my dApp? How am I going to pay for this? How am I going to make money as a company that I can continue to invest my time and energy to making this work? Who's going to help me with audits? How am I going to make sure that I'm secure so that I'm not another one of these stories that ends up on Wrecked that I actually have a guilty pleasure of reading all the time? How do I worry about performance, right? Is the block time on some given chain good enough for me? What about reliability? What's the uptime of this chain? All right, our transactions reliably processed. And all that comes down to generally a chain choice. But I would say that misses out on this third step, which is connecting. And I think even worse than missing out on that third step of connecting across different blockchains and across different ecosystems is the fact that it's a separate step at all. If I get my way and if we're all successful here today in thinking interchain, I want to see us unify this idea of connecting different blockchains. And the idea of being interchain should actually be a fundamental architecture choice that you make very, very early on. Because that is how you're going to get to users. This is how you're going to get to success. Being interchain is fundamental to the long-term success of your dApps, really not an afterthought. And so everyone here, this is why I want you thinking interchain. The last section here is about meaningful abstractions. Because when I think about Axelar, and part of the reason that I ended up at Axelar is this vision, this kind of long-term pie-in-the-sky idea of a world where you as a user, you as a developer, don't have to worry as much about which chain. Right? I want that question to kind of disappear through meaningful abstractions. Right? There's some abstractions out there right now. One of my favorites is IBC, which I'll just poke a little bit of fun at IBC, which is if you pull up the documentation of IBC, which is this Cosmos standard for inter-blockchain communication, it's like a 85-minute read, the first page of 4 sets of documentation on how to do this IBC communication, which is we don't have the right abstractions yet. And so this is something we need to continue fixing so that we can get to that long-term vision of not caring which chain things are on. And I want to give a few examples of some of these meaningful abstractions that we could have and that we kind of need at some point. And the first one is really the availability of tokens across chains. Right? DEXs are very, very popular. They kind of underpin DeFi. They underpin a lot of the transactions that are going on in these blockchains. But a lot of them are fundamentally limited. They're limited to the specific assets on the specific chain. And so when you're talking about launching a new DEX on one of these 455 blockchains, if you launch a DEX with no liquidity, you're not going to be successful. And if we had better more meaningful abstractions around how you can access all of those tokens, those DEXs could actually become successful with their new ideas, with their new trade-offs. The second example of this abstraction that I think we need to get to is the interactivity of dApps. There's some really, really useful dApps out there. One that comes to mind a lot for me, and I talk to a lot of people about, is OpenSea. Right? I have NFTs. I want to sell and market those NFTs using a centralized or a semi-centralized marketplace like OpenSea, where developers know, users know to go there to look for things. They know to go there to sell things, buy things. Right? That marketplace has value by everybody being in the same spot. But OpenSea is not actually available on all the chains that they might want. Right? But if we had more meaningful abstractions on how things could move across chains, OpenSea could then be a front end to all of the blockchains and all of the NFTs in the world. And that would be better for users. And the last one is that if you look back at HTTP and SMTP, both of those standards are built on a common set of identifiers, right? We call this the DNS system. And DNS, by being centralized, allows us to connect across all of these different applications that exist across the internet. And so that no matter what tech stack you're using, we all are able to find each other and work together. And that's actually been very, very powerful. I think it's a big part of why those systems have worked. But we don't yet have these universal identifiers, right? We have all these very specific identifiers, right? How many people here have an ENS name, right? Wow, almost everyone. That was fantastic. So you all have a fantastic identifier on the Ethereum blockchains, right? Like ENS is Ethereum, but it's used for resolution on other blockchains. Sometimes it's a little questionable there. But you probably don't have a Cosmos identifier. What is the identifier if someone on Solana wants to send an asset to you or interact with one of your contracts? Right? We don't have those sorts of things, and that's a critical piece of infrastructure that we need in order to solve this problem of thinking interchain. So one of these things that I talk about is the idea of a chain stack. So I define a chain stack as a set of technology that underpins a set of blockchains. So EVM I consider a chain stack that powers those 455 blockchains that I talk about. But there's also these chain stacks developing in other spaces. And so we have EVM to EVM. Okay? That's where a lot of developers are. But we need to start thinking about how to include the rest of the world and the other chain stacks so that we have abstractions that are meaningful so that we can build better contracts. We also need to unite. We don't even use shared terminology. one of the things that I do is I try and go to a non-crypto conference every year, just a conference with developers talking about building for web, building servers, all those sorts of things. And one of the things I did at the last conference is I set up a list of 10 questions around blockchain. And I just went to them and I said, hey, I'm going to ask 10 questions. And we barely got past question 2 because most developers out there don't even know that you can build software on blockchain. They don't know that there's a virtual environment that you can build here. So there's a lack of awareness. But there's also a lack of trust. When Web 2 developers hear Web 3, they have very negative connotations. I hear words like scam. I hear words like evil. Because we create terms like Web 3 to divide ourselves, when maybe Web 3 could be more of an evolution. Maybe we could find a way to welcome Web 2 into what we're doing. Maybe we could find a way to welcome them into the ideas of privacy, transparency, immutability, decentralization. Right? How could we think about a future where we're able to actually give, instead of trying to get all those Web 2 developers to come over and solve our problems, our blockchain and ecosystem problems, how do we figure out how to take blockchain technology and use it to solve the problems that they have? I've been involved with a startup that built an app for language learning for a while, and I think about that team of 20 developers a lot. How can we bring blockchain to them and make it meaningful for them rather than trying to pull them over, give up all the skills and knowledge that they know about their industry, about their customers? How can we solve problems for them so that we can unite and actually take advantage of all that mental capital, all those ideas they have? And some of this is going to come from standards, but I've been in a bunch of calls around, for example, NFT standards. And NFT standards sound like a really good idea, right? We're going to come up with a standard, and now we're going to be able to move NFTs between chain stacks, between blockchains. But the first question that comes up in those meetings is, why? What do people actually want to do with this? Because without that actual use case, without the understanding of the actual experience that a user wants with an interchain or a cross-chain NFT, you're going to build the wrong standard. You're not going to have the right sorts of capabilities. And so as we unite, I really think that we need to go back to some of these first principles and focus on the user, focus on the problems that they're trying to solve, focus on the developer. What needs do they have, and how can we solve those for them? So I'm going to summarize briefly here. I think that the Interop Summit is such an important, magical moment. Look around you. You have some of the leaders of people that are thinking about this interoperable future, that are thinking about this interchain future. Make really strong connections here. And one of the things I'll say is sometimes in crypto, we get into a little bit of a religion battle, where it's like my chain versus your chain. But there's a concept that originally comes from improv, but it's becoming bigger and bigger in business as well, which is this concept of yes and. Which is instead of immediately rejecting an idea that someone gives you and saying, no, it's not going to work, that's not my blockchain, that's not my tech stack, I don't care. Accept what they're saying, say yes, and try and build on it. Try and take the things that you know and improve and help their ideas. Because when we're all working together, instead of all working against each other, we're going to succeed. Obviously, I think everyone here wants to think Interchain now after hearing this. And so really, when you're thinking about scaling, when you're thinking about, hey, I need to turn this app into a production app, when I want to actually build a business, make sure that you're including this concept of Interchain as a core fundamental part of that. Because if you just add it on later, you're going to be technologically worse than if you'd thought about it up front. And I really do believe that here, in this room, with the people watching in the live stream and the other remote locations, because I know this room's packed, we're all going to build the future together. Thank you so much.
All right. Thanks, Stephen. That was great. You know, for myself, I remember about the second project I worked on was a team that had been working in crypto since like 2013. And one of the founders said to me, you know, having users, which they were fortunate to have on this project, is addictive. It's not something we think about all the time, but I think it's tremendously exciting and even intoxicating to be in a space where the use cases are yet to be defined and where the technology is so new, where we're almost at a kind of a research stage of the technology, and still have users, developers, building, interacting. This is a tremendous opportunity and a tremendous moment in the Web3 space. And it's with that in mind that I'm thinking to our next panel, where, you know, Many of you have had probably thoughts over the past 3 months, 6 months, 9 months. Why are we here? After FTX, after the bear market ended, the bull market ended and the bear market crash began. What are we doing here? Why Web3? Well, why Web3 is the subject matter of the next upcoming panel. A panel moderated by Tracy Wong from CoinDesk, with Marek Olszewski from Cello, with Stani Kolichov from Aave, with Austin Federa from the Solana Foundation, and with Maria Shen from Electric Capital. Please, everybody, put your hands together and welcome this panel to the stage.
All right, good morning, or GM, and thank you all for being here. I am Tracy Wong. I'm the Deputy Managing Editor at CoinDesk, and today we have a lovely panel today, and we are going to be talking about back to basics, what we're all doing here in Web3. And so just to kind of set the stage, I think we can all agree that 2022 was not a great year for crypto. We've had prices go down, but also many, many blow-ups throughout the year. And I really want to kind of ask everybody just first to kind of introduce yourself, but kind of talk about why you got into Web3, what you were hoping to achieve, either personally or with your companies, and if you could kind of tell everybody how you think that's going so far, kind of like a self-report card. And why don't we start with Maria all the way down at the end and then move to Stani.
Sure. Hey, everyone. My name is Maria. I'm one of the investment partners at Electric Capital. We're an early-stage VC firm that focuses only on crypto. I got into crypto in earnest, I would say, in 2015 when Ethereum launched. I'd heard about Bitcoin, and this idea of kind of like internet money was interesting, but I think how it finally clicked for me was this idea that you can actually write arbitrary code and write arbitrary programs on top of money. And that to me seemed extremely powerful. At the time, I was working on my own company in the supply chain space. And one of the biggest issues that my customers were having was around cross-border business payments. And so I started exploring Ethereum through the lens of thinking about enabling an easier way for people to do escrow online. So if you wanted to actually send a large sum of money to someone that you didn't necessarily trust, Ethereum or just blockchain in general was great at that, where you could trustlessly transfer money and transfer funds. So that seemed like a no-brainer to me. After digging in, it didn't take me very long to realize that crypto and blockchain was frankly just not ready for something like that, not ready for the manufacturers that I was talking to or suppliers or any of the small businesses. Because as soon as money kind of became, as soon as you had crypto, it was easy to do all of these things, but a lot of the infrastructure was not ready and the usability was just not there for any sort of mainstream adoption. But I ended up getting into crypto in 2018, mainly because it felt like, again, infrastructure was going to get built, but the tech was real. This ability to actually create rules and arbitrary markets on top of money was really obvious to me that it was going to be extremely powerful. So joined crypto and Electric full time in 2018, right when crypto prices were tanking. I would say that self-scorecard, I think, the reason why I entered the space is I just firmly believe that crypto is going to enable a parallel and new type of financial rails that we haven't seen before. And not only that, but things that we hadn't even imagined could be financialized will be financialized. And that's going to fundamentally shift the way that we interact with the internet, the way that we interact with each other. I think we're still very early, but the amount of progress that I've seen since I've joined crypto full-time in 2018 until now is frankly inspiring. It's amazing how quickly things have progressed. So I would say, I don't know about myself, but I think the space in general is amazing for how much it's progressed since 2018.
Merrick?
Hey everyone, I'm Marek Olszewski. I'm one of the co-founders of Celo. Celo, if you haven't heard of it, it's an EVM-compatible chain with a focus on payments and also increasingly on refi. And my, journey into crypto started, in 2013 when at a music festival I met Brian Armstrong and he sent me some Bitcoin using Coinbase. And he sent it to my email address. I just remember thinking that the experience was really quite lovely. Instantly got excited about crypto. Was also interested in kind of its use cases in payments. And I think in the back of my head, I was thinking a little bit about how could we recreate that experience where you can send crypto to an email address or to a phone number the way that Brian did to me, but do it in a decentralized way. And that ultimately became an effort that led to the creation of a wallet. We tried to create a global Venmo-like wallet where you could send money to phone numbers in a fully decentralized way. We tried to build that on Ethereum in 2017 and realized that it was too difficult to create something that was easy enough for everyone to use back then on Ethereum. And so that took us down the path of building Celo. Which again is EVM compatible, but it also has a lot of the features baked in that allow for this really easy to use sending of stable value to phone numbers in a fully decentralized way. And so Celo has the ability to pay for gas with tokens. So if you send a stable coin to someone, you can pay for that transaction fee in that stable coin. The recipient can then send that on to someone else because they don't need a gas currency. They can just use that stable coin. And then there's a decentralized phone verification as well that validators run, which allows people to effectively verify their phone number and map their phone number in a privacy-preserving way to a wallet address, which then lets people send value to phone numbers, to anyone in your contact list. So if you're curious to see how this works, definitely recommend checking out Valora. It's a really easy-to-use wallet now. On top of Celo, we were finally able to build it, and it's finally really, really easy to use. So that took us down the path. In terms of how we're doing, it's an interesting question. We started with mobile payments, but because we are EVM compatible, there's a lot of other activities happening on Celo. DeFi has been taking off, mobile DeFi in particular. Uniswap launched on Celo last summer. Curve launched in the fall. And so there's this really exciting DeFi ecosystem that's now growing on Celo. Payments are also quite big and exciting on Celo, but mostly in emerging markets. We have a lot of users in Latin America, throughout parts of Africa, who are using stable coins on top of Celo to pay for things and cashing in and out easily using something called Fiat Connect. That's been going really well. And then finally, there's this burgeoning refi ecosystem now starting in Celo. Celo was the first chain to offset its carbon. Literally a week after the network launched, there was an on-chain governance proposal. And the first thing that people voted on was to offset the carbon that the network was creating. And a lot of networks have followed since. But I think because we were the first, it's attracted a lot of refi protocols. And that's been really interesting to see. So yeah, I think things are interesting. We're not as big, certainly, as some of the other big EVM-compatible chains, but a lot of activity is happening right now, and it's just been really great to watch.
All right. Thanks, Merrick. Austin?
Hey, I'm Austin Federa. I'm the head of strategy at the Solana Foundation. Solana is a new Layer 1 blockchain. It's not EVM compatible. It runs on its own runtime system, but it's incredibly fast in terms of transaction throughput and finality, which is something we're seeing more and more focus on in new kinds of applications. And it also runs in one global state. It doesn't rely on sharding for scalability. Everything runs in one giant composable ecosystem, which is pretty cool and exciting. I originally got into crypto. I mean, it was one of those things where it's like I saw Bitcoin come up and I said, this is innovative and exciting and new, but pretty boring, the same way treasury notes were very innovative but also pretty boring. And so I didn't really get back into the space until 2017 when I was working for a fintech company and put in charge of a project to build something we would now call a DeFi protocol. Company went bankrupt a few months later, but that really, when you have to sit down and learn something for work, that's one of the times when you really have to explore what's possible there. And so the idea of building smart contract platforms is something that really hooked me then and been in the space ever since. And I think for the last part of your question, the thing for me that is so exciting about this technology is less on the financial side. It's far more on the implications for how you structure groups of people, societies, collective decision-making process. I think one of the least used but most impactful uses of this technology over the long term is to change people's relationships to things like governments and businesses and corporations and start changing that power dynamic back to something that feels more stable.
Stani?
I'm Stani. I'm the founder and CEO of Aave, and we're a team that built the Aave protocol, and simply a protocol where you can supply cryptographic assets and earn yield, and then use those assets as well as a collateral to draw liquidity and borrow. The protocol itself is governed by the Aave DAO. Means that we as the builders, we can't go and change the code. But effectively, it's deployed on Ethereum, Polygon, Avalanche, and layer 2s such as Arbitrum and Optimism. So interesting part about Aave is that it also has like a cross-chain governance. So you can actually create a proposal on for example, on Polygon, and then vote on it on layer 2, and at some point even do optimistic voting where you can have less transaction fees. Our team also built the Lens protocol, which is more of social media protocol, which allows you to create a profile of your online presence, which is secured by the blockchain, and establish connections with your peers, and post content that you can also turn into collectibles as well. What got me into Web3 space? So I grew up over the internet, as many of you else here as well. So for me, being able to have access to information globally, being able to connect with peers with the same ideas that you have, and communicate was a very big thing. And I personally remember when I was growing up during my teen years, I was playing a lot of Counter-Strike. And the more better bandwidth you got, like the more exciting things became in gaming and also online. And I kind of feel the same thing happening now in Web3, where we're getting more and more scalability and interoperability, and things become more exciting. And now today, if we look at the internet, there's roughly 5 billion users out there, almost equal amount of social media users that basically have access to the internet. But what's important for me, like what got me in my university years into blockchain, was that I kind of felt that, especially with decentralized finance, well, back a few years ago, it wasn't like a term that was coined yet. But what was interesting there is that you had this ability to access to finance across globally. And the cool part about DeFi is that it really doesn't look into your background or your finances. It really, the idea of decentralized finance is to really offer you exactly the same thing as to someone else across the other part of the world. And that access to finance was something which was very valuable for me growing up during the internet, and remembering times when it was so scary to put a credit card into online payments without looking for reviews. So that's why DeFi has been a big part of what we've been building, and also being able to have access of ownership of your own online presence. What we're doing with Lens Protocol, meaning that you can own your profile and the follower graph that you have. And I think that's the part of our kind of like a whole ethos of being able to decentralize and make the ownership of the internet kind of like getting it back to the users is our mission. Yeah, that's my excitement.
Right. Thanks. So I'm hearing video games and music festivals got everyone into Web3. So now let's. I have some questions for all of our panelists that are a little bit spicier, and let's start with Stani. And so you are basically a DeFi OG, and one of the biggest narratives last year was kind of the failure of all of these centralized lenders. We've seen the implosion of Celsius, BlockFi, the whole gamut. And a lot of DeFi maxis touted this as kind of a failure of centralization. DeFi is the future. But there's also a view out there that maybe decentralization is not a one-size-fits-all solution, and it introduces new risks. And DeFi protocols have seen, hacks, exploits, market manipulation. So it's kind of like a pick your own poison type of scenario. Do you want to be rugged by, Celsius or the North Koreans? And so do you kind of have a defense for DeFi that is a little bit stronger, that goes beyond, it's less bad than CeFi?
Yeah, I like to look into it in a way that, the idea of DeFi is also to make like finance unruggable. And by that, what I mean is that, when you're using centralized service providers to do financial transactions, you have different kinds of risks involved. That's the custody risk, for example. You don't have, the transparency that decentralized finance provides, and you have different kinds of execution risks. But when you're moving towards into financial applications that are completely open source and built publicly, meaning that anyone can look into the code bases and actually contribute, you will have a different kind of an output. And when we look at the code bases that we've built over the years, our team is a substantial contributor to what's basically being deployed on the Aave ecosystem. But at the same time, there is a lot of contributions coming outside of the team, and especially from the community and white hackers that are looking into the DeFi protocols and trying to figure out, how to find and exploit and get a bounty, and make these protocols more resilient. So in one ways, there is a big risk transfer for sure. So, you're reducing the custodial risk, you're reducing different kinds of risk of calculating what's the actual risk involved on whatever financial transaction you're entering, and you're introducing new kind of risks that you are putting code into the public that might, that might have flaws, for example, or other type of execution risks might be involved. But when you actually start doing that, what you notice is that you can actually build better financial software when you build in a public way and in an open manner. And I think a good stress test was definitely last year. So many of the centralized lending providers, they definitely didn't end up being well, and mainly it's because there was a lack of transparency and lack of risk management. But you can't really question their abilities to manage risk when you can't really see inside of the black box, where I see decentralized finance being more of like an aquarium where anyone can contribute and actually discuss the potential risks involved. And just looking at last year, the reason why DeFi was so resilient was mostly because there's actually years of development and improvements of the concept that we use in decentralized finance, including liquidations, how these protocols should work, the risk mechanisms, and there's more and more tools available. And I personally think it's like there's no really like a kind of like a difference between like CeFi and DeFi, which of these technologies will go further. I think that's just like if you build better finance, better, faster, stronger finance, which for me is decentralized finance because of it allows with the transparency to quantify the risks more better. I think that's where we're going towards. And effectively, the ethos of building decentralized finance is about building public goods. So you want to put something into the public that becomes an infrastructure, and even you can go as far as thinking of like finance as a human right, and bringing that accessibility. Yeah.
Thanks, Donnie. Okay, next question is for Maria. So venture capitalists have been really into AI recently. It seems to have replaced crypto as the new hot sector. And so you're the only VC on the stage. Curious to hear your thoughts on, whether or not this whole crypto Web3 VC phase was a fluke, and how crypto can maintain its momentum now that everybody seems to be head over heels with AI.
Well, I mean, Electric Capital, we're crypto focused. We also entered the market during a bear market, right? So this is not anything new, I guess, to us. I would take I think AI is also transformative. In my mind, there are actually very few technologies as transformative as crypto, but I'm biased. But I tend to take a longer term view where it's not really kind of like what's the flavor of the hour. When I look at crypto, one of the things that we focus on is the number of open source developers in crypto. And we think that's a better indicator than price, certainly, at looking at what are the fundamentals driving this technology. Bitcoin started as open source, Ethereum is open source. A lot of the most important things in crypto are open source. And so in looking at the number of open source developers, it took from 2009, when Bitcoin was created, to 2015, when Ethereum launched, for crypto to have 1,000 monthly active developers in open source. It's a pretty, it basically took us 7 years to get to 1,000 monthly active developers. It's a sizable number, but it's small. But if you look at what's happened since 2015, from 2015 to now, we now have more than 22,000 monthly active developers. I think that's the type of growth that's really inspiring. Again, when I joined crypto in 2018, we didn't really have stable coins past Tether, right? We didn't have decentralized finance. That was not a term that was coined. We certainly didn't have a lot of the things that we see now. And I think if you look at the speed of the growth of the industry, again, driven by the developers in here, it's very clear that crypto is here to stay. There are also lots of other technologies, and AI is one of those things. But again, I think if you take a long form view, there are going to be few things as much that'll shift our society as crypto.
Thanks, Maria. So Austin, one of the biggest headlines last year was the collapse of FTX, and Solana was an ecosystem that was hit especially hard with the price of Sol falling under $10. Some have called it Solana's $80 Ethereum moment. The token price has since rebounded, but how is Solana moving past FTX? And the question is on the second part is, how is Solana kind of dealing with the emergence of new layer ones, given it was kind of the hot new blockchain the past 2 years?
Yeah, one of the great things about being a open protocol that anyone can build on permissionlessly is that anyone can build on it permissionlessly. That's also the worst thing about being an open protocol anyone can build on. So you look at sort of the role of an organization like FTX. FTX invested more money in Aptos and more money in Polygon than they invested in Solana, but SBF was the person who first put Solana on the map because the engineering team over there looked at Solana and said, this is the blockchain we can build a central limit order book on. And so the initial vision there was to build something that would compete with their centralized exchange and eventually, stop being a centralized exchange and move entirely to a central limit order book built on chain. That code is still around. That code has actually still been forked and taken over and now is open book. And eventually that organization, they changed what they were trying to do from build DeFi to replace CeFi to whatever they were doing in Washington. But the process there really, they were involved in the Solana network as investors for about a year. but it just happened to be at a place where there were a few very famous moments that really helped put Solana on the map. But what we see now is even after the collapse of FTX, there are more validators than there were before FTX's collapse, and the community is actually a lot stronger, has been forking out a lot of the projects and code that FTX had been working on in that space. So I think the $80 ETH moment is a good analogy there, because it really showed that the network is much bigger than any investor that was involved in it. Moving forwards now in terms of what we see today, I think we're seeing a lot of different applications of blockchain technology to serve different types of problems. So Solana is still the highest throughput layer 1 out there. That is a place that it has a differentiator at this point. I think as you see new networks coming up, there are some interesting things they're doing to optimize for different types of transactions. Solana was originally envisioned as a network that was going to be the best place for DeFi. It turns out if you build a really fast layer 1 with cheap transactions and fast finality, a bunch of NFT degens also show up and decide they want to mint a bunch of NFT projects on the chain. So I think the main thing to look at for any sort of layer 1 or layer 2 ecosystem is what's the developer adoption look like. And the Electric Capital report is a great sample of how strong the developer community is on Solana and how committed they are. And I will say that report also goes through the end of December. So it covers the period of time after the FTX collapse as well to show that there really are strong staying power for developers on the network.
All right, thanks, Austin. So Merrick, there is a cynical view out there that the past cycle was mostly driven by, retail speculation and easy credit, and some of the products that we saw that had the greatest adoption or kind of popularity were things like dog coins, monkey NFTs, and DeFi food farms. And you talked very high-mindedly about payments and all of these other applications, and I'm curious. What do you think? What do you think it will take for people to kind of adopt these? It seems like more utilitarian use cases for crypto, as opposed to kind of these very speculative things that we saw last cycle.
Yeah, great question. And who doesn't like a fun NFT? I think the last cycle, has been really interesting. I think a lot of new and exciting things did come out of it, right? I think, as Maria mentioned, DeFi wasn't really a word before. I think, we now have a completely new form of art, which I think is, just incredible. But one of the incredible things about crypto is that it really allows you to innovate in ways that weren't possible before. And it allows for, I think, a lot more use cases to emerge, some of which have very real-world, tangible use cases today. I think we talked about payments as one of those. Payments were described in the Bitcoin white paper as something that I think a lot, Satoshi was clearly very excited about. I hypothesize that payments are taking longer to develop than some of these other use cases, primarily because it's harder to bootstrap network effects. You need two parties, not just one party, to be crypto savvy in order for it to work, right? And that requires much more critical mass to really take off. But it's really, I would say, starting to happen. I think ease of use has always been a really important factor, and that's one reason why we invested so heavily in making it possible to send value to phone numbers, to allow people not to worry about public key derived addresses, to make it easier for people to pay for gas with tokens that they actually want to make payments with. There's a project in the ecosystem that has these self-custodial wallets where you can tap to pay, and the chip inside the card actually has the private key, and it beams the transaction up through NFC to the chip, and then the chip signs it. And so you have the same ergonomics as Visa, but it's fully decentralized, fully settled on crypto rails. So I think a lot of this ease of use technology is progressing. And we're seeing now whole communities in Brazil, in Nigeria, where people are transacting day to day. They're buying their groceries on Celo with stablecoins built on Celo. And I think this reality is increasingly happening more. The other real-world use case that I think is really exciting is carbon offset credits. They've existed for a while. They have had their problems. And it turns out that crypto actually can help with transparency, with double spend issues. And so we're seeing actually quite a lot of interesting carbon offset credit related projects on Celo as well that are also taking off. And it's just really, really interesting to see.
All right, thanks. Okay, so we have just over a minute left. Given this is the Interop Summit, I wanted to just go down the line. Briefly, one sentence, kind of your vision for multi-chain future, your thoughts on interoperability. Let's start with Maria and go down this way.
Super quickly, from the developer report, we've been doing it since 2019. One of the obvious trends is that there are these clusters of ecosystems that's emerging that are interoperable, both from an end consumer point of view, but actually from a developer point of view as well. And so I think it's becoming very clear that we're going to have clusters of interoperable chains, and I think that's very clear that it's going to be part of our future.
All right, thank you. Eric?
Yeah, I'm excited for multi-chain future. I think we're already in a multi-chain, world. I think the reality is that block space is still a scarce resource, and I think that's only going to continue, right? I think the appetite that the world will have for more and more Web3 block space will continue. And a lot of the really exciting horizontal scaling solutions today require really good interoperability, and so expect I think a lot more exciting stuff happening in this space.
I would say we're kind of functionally nowhere on interoperability at this point. Like, interoperability is when you have this thing that's happening in Web 2 where a company uses GCP and Amazon Web Services and Azure, and they roll their own thing, and it's totally seamless and invisible to the user. I think when we get anything in crypto that is that seamless of an experience where the users then have to really know all the cross-chain piping that goes on beneath the scene, we'll finally be in a place where there's actually interoperability. We have compatibility now, and compatibility is awesome, and it's such a huge advantage compared to where we were 2 or 3 years ago, but I really wouldn't say we're anywhere in true interoperability yet.
Yeah, I think interestingly, our protocol has really like interoperability features, especially regarding the governance, which I mentioned earlier, and I think that's something that we continue also expanding towards. And then I would say in terms of Lens protocol, we're trying to also like figure out like what could be the solution for Lens to become also cross-chain and kind of like a Web3 social layer. So that's been very educative part now, especially because we see a lot of different technologies. There's obviously EVM that's it's replicated, and that's the compatibility, but then you have some of the networks are more built on Rust type of solution. So I think we're very far away where we should be, but I'm excited to see like how people come up with new things and solutions and what people are going to build even during this week.
All right, let's give our panelists a round of applause. Thank you.
Okay. 22,000 developers. A lot of people talk about 1 million users, the next million, the next 100 million users, but let's talk about the next 100,000 developers. I think to get them in, we're going to have more, the next conference, we're going to have more video games and more live music at the next Interop. But what I want less of people talking about FTX. So I made this box. Any panelist from now on who mentions FTX has to drop a 20 in this box. Okay, I'm going to be back there in the green room with this box. If you say FTX, you got to put the money in the box. All right? Okay. So, one thing people aren't going to stop doing, they're not going to stop bridging. People will not stop bridging even though the experience is painful, and I know this because I've made tutorials about how to do it. Right? So the next panel is going to talk about why are people bridging? Why is there this demand for interoperability among users in Web3? So, please welcome Tarun Chitra moderating a panel. Tarun Chitra from Gauntlet, moderating a panel that includes Hasib Qureshi from Dragonfly, Tasha Che from Tasha Labs, and Will Nelly from Galaxy. Please put your hands together, people. Thank you.
Okay.
Cool. Well, I know this is a meaty topic, so I'll try to have our intros be a little short, and I'll introduce everyone. So we got Hasib, who is a Dragonfly, and you can see on the chopping block with me.
Head hype man at Dragonfly.
Head hype man, right? Will is at Galaxy, and I think has spent a lot of time in the Axelar ecosystem, and hopefully we'll have some great insights there. And of course, Tasha, famed online macro expert, and someone with a different lens than the 2.5 investors on stage. So, I guess the first question is, bridges come in a lot of different shapes and sizes. They have different security models. They have different technologies being used. Different people will fight online about what qualifies as a bridge, what doesn't qualify as a bridge, what is centralized used as a derogative term, what's centralized used as a positive term. People talking about circles, bridge. And so a natural question that might be a place to start is, what are the defining characteristics to each of you of what is necessary to be a bridge, and what's sort of the minimum viable bridge in your mind?
Yeah, I can start. So I think when the concept of bridging first became palpable to people, in the early days, bridging was a very abstract concept, right? When Polkadot and Cosmos, which were the first two, Cosmos before Polkadot, were the first two real plays to try to build interoperability protocols, the ideas around bridging was very abstract. There's this idea that maybe someday there are going to be multiple chains and they're going to matter and they're going to want to talk to each other and move assets. But at that time, there just wasn't that much going on other than on Bitcoin and Ethereum. And it's become very clear in the last few years that, okay, there's lots of chains. There's a lot of dynamic stuff happening on those chains. And you need some way to move assets from one chain to another, as well as to move messages from one chain to another, to allow yourself to compose applications such that an application that's on chain A can actually call a contract on chain B. The way that you think of an RPC call on the internet, you want to get to a world where someday blockchains are kind of, at least to some degree, transparent to each other. They don't have to worry about, this is on another chain, therefore I can't use this. So bridging, it first started with just moving assets. And as over time, as the complexity of what is an asset has increased, right now we don't just have tokens, we also have NFTs, we also have other kinds of, sort of non-compliant things that you might want to own, or rebasing tokens, or all sorts of really other complicated assets. But then there's also messaging, which is how can you bridge a message from one chain to another and allow not just a message, but also a response to be retrieved reliably. Those are the, having some pieces of each of those components is enough to call yourself a bridge, but the standards of what you need to be a bridge has only increased over time as complexity across chains has grown.
Yeah, so for me, anything that fundamentally moves information across from one blockchain or sort of domain to another counts as a bridge. You could even go back to WBTC and call that one of the early bridges. That said, that not every bridge kind of meets the criteria that I would be comfortable with as a user or as an investor, writ large, right? So there's some sort of spectrum at the end of the day when it comes to moving information across chains, which you have got security on one side and latency on the other, right? You could either go the highly federated, extremely low latency route. This is the wormholes. This is a couple other ones. On the other side, you've got the optimistic model, which is the sort of optics bridge, which became Nomad, which also kind of spun out Hyperlane, and the Hyperlane moved. So on either one of those sides, you've got this fundamental trade-off between security and latency. The longer you wait, the more security you're going to get, the more comfort you're going to get in the confirmations on the other chain. So the layer 0 and Wormhole are kind of on this low latency, highly federated, relatively what some might call centralized, sort of side of the spectrum, but they'll pass you messages really fast. Whereas a Nomad, you have to wait X minutes. I don't know. There have been different definitions of how many minutes, based on certain optimizations you can do in the fraud proof. But that's 30 minutes or 10 minutes or 15 minutes for the state to finalize. So on either side of those, there's trade-offs that I think I, as an investor, and Galaxy broadly have been not comfortable with in different ways. There's a kind of somewhere in the middle is this kind of consensus-based approach that Axelar takes, which is fundamentally, you get some consensus over messages on an origin chain, and you come to a distributed consensus over what can be passed to the destination chain. That's felt like a nice middle ground that balances the kind of properties of both sides. Hyperlane, notably, which spun out of optics, but then kind of changed their model a little bit, kind of notably fits in that bucket. You've got the token bridges, obviously, which are fully kind of, like multi-sigs in some cases, right, and fully federated, controlled by the protocol. So that's how I kind of see the space. Different people are going to be comfortable with different, kind of properties, and obviously people have gotten comfortable with the layer 0 and some of the more centralized wormhole, some of the more centralized approaches.
To me, it's very straightforward. A good bridge needs to be 3 things: safe, cheap, and fast. So everybody wants these 3 things, but everybody's priority is different. So for example, if you are moving billions of funds across chains, safety probably would be the top priority. If you're a small retail and you are just moving like $10, $20, then the thing needs to be cheap. If you are a high-frequency trader, then the speed will be your highest priority. So all of the solutions, bridging solutions in the world today, none of them are all the 3, right? But I think all of them potentially have a path to at least excel in one of the 3, depending on what type of clientele that they are going after. If they're going after institutional users, then probably safety is the #1 thing. If they're going, other types of use cases, then maybe they prioritize other features. But the bottom line is, whether it's centralized, decentralized, I think that is a debate more for the diehard crypto nerds. But for the majority of users, safe, cheap, and fast, that's all they ask. And I think that's actually a reviewed preference. You can actually see it in people's behavior because, at the end of the day, like, what is the most widely used bridging solution today? Now, we can talk about all the innovative bridges or cross-chain messaging solutions out there, but seriously, mostly widely used solutions is still centralized exchanges. You move your money to centralized exchange, and you send it to another ecosystem or another blockchain. So why is that? To me, it's very simple because the centralized solution is still fulfills the safe, cheap, and fast criteria the best. And right now, in the future, it's probably not the case. But my point is, whoever that fulfills these 3 criteria, they will get attraction.
Cool. Yeah, I guess in the vein of the safety question, 2022 could not exactly be called a successful year. It probably was a brutal, macabre year for bridges. There obviously were a number of notable hacks, some that were in the news this week, I suppose, in terms of fund recovery. But if we take a look on the glass half full side, there have been a number of security and operational lessons learned for operating, constructing, and even for users for using bridges. So which sort of hacks stood out to you the most? And sort of maybe this could be termed "What's your favorite bridge hack?" But I don't know. I don't know if you want to be like known as having a favorite. But which one stood out to you the most, and what lessons do you think were learned from that particular hack?
Well, the Ronin bridge hack was definitely a classic. That was a chef's kiss level, bridge hack. So
is that a technical term now?
That is
Chef's
a
kiss
technical
level
that's right,
break.
that's
We
right.
have like a thermometer, and that's like the top.
It was delicious to watch. Well, so what happened with the Ronin bridge hack? So it turned out that Ronin is the layer 2, or not layer 2, sorry, the sidechain that Axie Infinity runs on. And of course, as Tasha was mentioning, most of the bridges that people actually use are not particularly decentralized. They don't have some fancy, beautiful mechanism underlying it. For a lot of them, they're just multisigs. They're just multisigs, and the people on the multisig might be more or less trustworthy. They might be doing more stuff behind the scenes. And in the case of Axie Infinity, they had huge sums of money that were bridged from Ethereum mainnet over into Ronin. And for the Ronin sidechain, basically what they were doing for their multisig, they nominally had 9 people on the multisig. And it was like 4 of 9, I think, or 3 of 9, something like that. Sorry, 5 of 9. It was 5 of 9. But actually, I think it was like 5 or 6. No, 4. 4 of the 4 of the signers were one person. Yes, that's right. There was some. Yeah, so it was basically you had to compromise one party in order to get 5 of the 9 keys on the multisig, which is what happened. Now, it turned out the attacker was North Korea, so you can be slightly more forgiving, but still it's pretty bad to have basically it shows that a lot of crypto, there's a lot of security theater. Right? There's a lot of, hey, we've got this multisig, and we've got this thing, and we've got this automatic blah, blah, blah mechanism. And in reality, when shit goes bad, you realize, like, oh, wow, it was just like basically one server that got popped, and that took all the money. And when you realize that that's the real mechanism, there's the mechanism in the blog post, then there's the real mechanism, it goes to show why thinking through bridge security is really, really important. And I think people have started to become more sensitive to, hey, this thing is really at bottom just kind of a multisig, and I sort of have to trust you that you're doing your jobs.
I mean, to follow up on that as well, when you're talking about the kind of limitations of this relevant security models, like the spectrum I laid out, in the previous question, like it does, if we look at the Nomad hack. Nomad is theoretically the most secure bridge because it's a one of n kind of approach where if somebody submits a fraud proof, then that challenge gets passed through, and that transaction gets canceled. So as long as somebody's watching, that one of n is the most secure. But when it actually comes down to it, the security lives within the audit, within the approach to security taken by the developers, within their carefulness in writing the code. That was obviously, I think, other people in the audience will know better, but I think it was a state root issue with the the Nomad hack. And, some like Axelar, for example, I think they got 27 audits or something like that for their protocol, right? So there's this whole security spectrum. We can talk about it. We can talk about the fundamental designs, but it seems like the hacks are telling us that the security, a lot of the actual implementation of security with respect to bridges is coming from, the practices of the underlying, of the underlying developers and the underlying, people maintaining the bridges. The CISOs, for example, at Galaxy, our CISO would say the exact same thing. When it comes to being a qualified custodian for custodying people's assets, it has very little to do with the actual way you're maintaining the keys, whether you're using some MPC or some multisig. It has everything to do with the processes you're putting in place to manage the keys, the processes you're putting in place around information, around who can, who can touch keys. And so I think that is a kind of realization around security of bridges that came to fruition in 2020 that CISOs have known since the year 2000 or 1990, right? In different industries.
Well, there's an old trope in crypto that people love to say, which is that code is trustless, which is obviously bullshit. Right? It's not true that code is trustless. Not just because there's some code that has multisigs or whatever that you do have to. There's some trust embedded in the code, and we learned of a multisig wallet that actually or the Oasis vaults for which the code was not trustless and it was not obvious the way in which the code was not trustless. But either you have to trust the people, or you have to trust the code is correct. And a lot of times the answer is that the code is not correct, especially when the code is very complex. And one of the principal things that we just have to take as part of the lumps of building in blockchain is that we're building complex things. And complexity is the #1 enemy to security, which means that it's just going to take time until a lot of these complex bridges are going to be fully robust and secure relative to a lot of their centralized counterparts.
Yeah, so I totally agree. And I think this problem is, in a sense, nothing new. It's every time there is new financial technology that gets high growth, it always this type of thing happens. You look at 100 to 150 years ago, there used to be a lot of bank heists in the United States and around the world when the banking sector was growing very fast. Nowadays, like when was the last time you heard someone rob the bank? It's almost unheard of today, right? Bonnie and Clyde, that movie would not have been made in 2023, right? Because over the years, the industry has matured and best practices have been established because of the mistakes that made before and the experiences that are gathered before. So I think over time, there will be similar, like as the industry mature, like people will have checklist of things to, what are the best practices, principles to follow in the industry. And also there will be new, beyond technical innovations, there will be new financial innovations coming out to solving this type of problem. The counterpart example in the 20th century is deposit insurance, right? So FDIC was established exactly because there were so many bank robberies and bank thefts and people lost money depositing in banks. So then, the society collectively came up with the scheme to ensure on a sector level, not individual bank level, at a sector level, to provide some kind of public good, in a sense, to at least to safeguard provide some safeguard level to this kind of incidences. Now, would there be a counterpart in the cross-chain world? I think so. I think it will happen, but it would not happen in exactly the same way as the example I just gave, because there's no government here, right? There is no social planner, so to speak. But would there be any kind of a decentralized, crowdsourced public good solution that provides some kind of insurance scheme against incidences like this? I think it may. At some point, we will start to see that.
Right now, it's Binance. That's the the fact
or
that
jump,
sure.
or jump.
Or jump. That's right. That's right.
But another trend for bridges, sort of in this vein, is sort of what you might call fractionalizing bridges or specializing them, in the sense that people have observed that 95% of bridge usage is token transfers, and there's barely any atomic execution demand. If you look on, say, Nomad right before it got hacked, even when there was a ton of extractable value for atomic transactions, there really was not that much relative to just raw token inbound and outbound. So, there's sort of this natural question that, hey, by minimizing the surface area of what you do across a bridge, you also can improve its security and speed, and sort of possibly its UX. So do you think that, the future involves these kind of special purpose bridges for particular use cases, or do you think sort of the world will be, we do need the full general purpose, Turing machine bridge, so to speak? Maybe Tasha, if you want to.
Yeah, so I think it depends on the stage of the industry, right? So as any industry matures, you will see the applications get more and more specialized. At the beginning, you probably you don't see as much specialization. It's the same thing if you look at the Web 2 internet. At the beginning, the Web 2 platforms are all like general purpose platforms. You go on like yahoo.com, you see news, you see finances, you see chat rooms, you see everything. And then as the industry develops, you get like the niches get more and more fine-tuned. And also there's the other thing is, especially related to the topic, we are talking about security, right? This is a very technically complex system. So when there's no specialization, it's very hard to do everything very well. So I think this is definitely a direction that the industry will go towards the specialization. But the thing is, the speed of this happens depends on where the market is, where the demand is, right? So right now, like Taru mentioned, 95% of use cases are token transfers because that's the only use case there is. And last year, despite the so much hype created about the cross-chain messaging, we haven't seen much of that, at least in the wild, being widely adopted right now. I think it's just because of the maturity of the industry and the diversity of the use cases out there right now. It's just because the bridging, it's like a service sector, it's a auxiliary sector to support the underlying blockchain ecosystems, right? So unless the blockchain ecosystems themselves, unless the economy and the business models of the projects and applications themselves are diversified to a sufficient extent, and those diversified use cases have sufficient demand. Unless that happens, you are not going to see diversified use cases of bridges. So this goes, it dances with how the blockchain ecosystems develop. And right now, it's obviously not a time and occasion since we're in a bear market. Liquidity is thin, and there are a lot of new innovations out there, right? People are building new things, but the speed of adoption of those new things are very slow right now. So I don't see the diversified, specialized use cases for bridges to happen in the near future. That's why, but just because there's not enough demand to support those in the near term. But I think medium term, definitely a direction of the industry.
There's a couple, I'll keep it short, but I think there's a couple of factors we're watching that will have some influence one way or the other about the saturation of token bridges. One is account abstraction. I think with account abstraction, you can do some interesting things, specifically paying gas using we've always seen that Interop is going to be built into wallets, probably. That the right approach for wallets is there's a bunch of different venues, which are every blockchain is a different venue, and there's different venues that are good for executing specific sorts of transactions. So you might want to do an exchange on one type of venue, whether that's like a SEI or some L2 or some application-specific, DYDX on Cosmos. That you've got, other venues for other applications, and we feel that it doesn't really make sense to chase your ETH or chase your USDC with ETH to pay for gas on another chain using the same currency. That it'd be ideal if you could abstract that whole process out behind a wallet, and account abstraction factors into that, right? So the idea that you could pay gas on another chain using assets on one chain inherently is going to, I think, require a generalized message passing bridge because you need to make that cross-chain sort of call for logic. Another thing we're watching is broadly the sort of clusterization or rollout or application specification of different venues. So you might have a lending rollup. Obviously, Compound tried that a couple years ago, but then an exchange rollup, stuff like that. So I don't think we're going to probably live in a world of full composability between all chains or between all applications on a single chain. Speaks to the Cosmos thesis, for a long time, but I think it's coming to Ethereum as well. And the kind of bridge configurations you need under that is interesting and probably trends away from pure token bridging, but certainly token bridging is going to have a place in that future as well.
So I'd challenge the premise of the question in that I actually don't think, if you look at bridges today, so the question sort of implied that bridges today are very generalized and when are we going to see specialized bridges? There are some generalized bridges like Axelar, like Layer 0, like Wormhole, but the reality is that that's a very small minority of all the bridge activity. Right? If you look at where is most of the stuff being bridged today, the answer is that it's mostly getting bridged through the Binance bridge, through the Ronin bridge, through the Avalanche bridge, which are all basically sort of state-sponsored bridges by the chain that wants activity to flow across that particular corridor. Now the question is, like, why is that? Why is it that the overwhelming majority of all the volume going through bridges today is going through these like single corridor bridges? And the answer, one, is that right now there's actually not a lot of sort of interchain activity. Right? It's very hub and spoke, which is that most people have their assets on Ethereum, sort of the overwhelming majority of TVL is, and occasionally it might go to Avalanche and it might come back. It might go to Binance Smart Chain, it might come back. Right? And as long as that's the behavior that most people are going to be engaging in, and it's mostly moving assets, right? It's not cross-chain messaging. Most of these bridges, I mean, the generalized bridges are still quite young. They still have a lot to prove in terms of security, in terms of robustness. And the network effects that you might presumably have, which is that you can use the same bridge to transfer from chain A to chain B and then to chain C, most people don't need that right now because there's not a lot of stuff to do between Binance Smart Chain and Avalanche. Right? It's not a used corridor. So I think it's a matter of market maturity, whether or not one market maturity and also protocol maturity is that as these generalized protocols mature, I think they will see more adoption and they will see more people start to use them. And especially as those corridors that are not just ETH to X start maturing, that's when you're going to see these generalized use cases start to become more attractive. But right now, to the extent that they have any network effects, they're still very weak when the primary thing you want to do is just move assets back and forth from Ethereum.
Yeah, and with that, I think we're almost out of time. We didn't get to my favorite topic, which is cross-chain MEV, but the little shill is all my ethdenver talk will be about that. And the last final thing, one-word question, is a very tough one, which is what's your favorite bridge right now?
I'll go with Axelar. Hey, I know where butter's my bread.
I'll have to go with Axelar and a shout out to Hyperlane as well.
Well, Axelar, because I'm at the Axelar conference.
We were all paid to speak here, by the way. Full disclosure.
I offend the host, right? So.
Second favorite bridge.
Second favorite.
Succinct.
Succinct. I have no second favorites. I just have one favorite. Yeah, exactly. Somebody else send me a check and I'll include a second favorite.
All right. Well, thanks everyone. Hopefully we answered the question of why cross-chain will be huge, but I'm not totally sure we got that.
That was the next question you missed. You unfortunately got cut off.
But yeah, thanks everyone.
All right, that was a great panel. Okay, 15-minute break. Get yourself a snack. Go over, check out the Luster Pearl. We'll be back here at 11:45 with Jim Chang from Catalyst talking about the trust spectrum in interoperability. Thanks very much, everybody.
Ladies and gentlemen, please welcome back to the stage, Galen Moore.
All right. Is this a blockchain conference? Because we are on time. Next up, Jim Chang from Catalyst is going to make an excellent presentation. If those of you who haven't read Jim's analysis on cross-chain trust, you're going to like this one a lot. Please give it up. Warm round of applause for Jim Chang and the trust spectrum of interoperability.
Hello. Hey, what's up, everyone? Happy to be here today. Hope everyone's having a good conference so far, good Denver. Hopefully it's not freezing everyone's asses off just yet. Thanks for the Axelar team for having me out here and telling you guys what is something that I'm personally really excited about talking about, which is basically the trust spectrum of the interoperability problem. And I'm going to be talking about that, kind of the spectrum in which we see a lot of different solutions, thinking about trust and the trade-offs inherent for connecting two disparate domains together in a cross-chain communication protocol. As well as I'm going to share a little bit about what I personally think is the end state for the entire space. And so excited to kind of unveil that for you guys today. And so a little bit before that, I just want to give a quick introduction of who I am and why it matters that I'm here today and telling you guys about about the interoperability spectrum. But my name's Jim. I've been in crypto for about 5 years. Most recently was at Aave leading experiments there. Now I'm building a new cross-chain project called Catalyst, which we'll be announcing at ethdenver on Saturday. So a little bit of alpha for you guys. But we'll be kind of keeping a little bit mum and telling you guys a little bit more of a broader vision that we guys have at Catalyst, which is just thinking about the interoperability problem really deeply. And so interoperability is hard. I think most people in the space who are here today know that it's hard. There's a lot of different factors that we have to think about at play when we think about connecting two inherently distrustful domains together, whether it's asset bridging or whether it's passing arbitrary messages. And so exploits is something that we've seen, and I don't want to rehash. I'm sure many folks at this conference have been talking about that already. Incompatibility, as you think about different virtual machines, different languages, different schemas that exist on different domains, like Ethereum versus Cosmos, for example. And it's complex. You know, a lot of this technology is being built as we speak. A lot of new kind of foundations are still being developed in R&D labs. And so definitely a very emergent space that I'm personally very excited about and have been excited about for the past few years. And so cross-chain is hard. And I think the number one thing that people think about when they want to solve cross-chain is very much how do you make cross-chain safe? I think the panelists before were kind of thinking about what does it mean to have cross-chain be inherently safe? And it turns out everyone wants to do that, but it's a spectrum. It's a spectrum of how you're actually able to accomplish that. And with that spectrum, you kind of have a trade-off. And so this is something that I wrote in a piece last month of what I think that interoperability spectrum is. But basically on one side, you have humans. You know, you're trusting humans and reputation and the entities and legal structures that we have in the meat space in order to allow for that safety. But the second part, on the other end of the spectrum, you have machines. You trust code. You trust kind of the trustlessness of code in order to actually enable inherent security properties between two distrustful domains. And so you can see that there's kind of a spectrum that lies between those two polar ends. And so with that spectrum comes a trade-off. And so when you want to say, I want to have safety, you're also inherently thinking about what does it mean for this trade-off that you have. So on one end of the spectrum, if you're trusting humans, you're inherently being more extensible, as some of my colleagues have said. Or how I like to frame it, you're having quicker time to market. and in a world in which you have all sorts of different domains with different virtual machines and schemas, it's actually much easier to rely on humans in order to expand into these new domains, and therefore they are extensible. On the other hand of the spectrum, you're solving for pure trustless security when you're trusting machines. And that is something that other kind of solutions have tried to solve for. But what comes with that is a research into more kind of nascent technologies as it pertains to ZK snarks and other kind of nascent developing R&D primitives in order to provide that trustlessness. And so, again, kind of the trade-off is you could be here now, trusting humans into all sorts of domains, or you could be here in 5 years, trusting no one, and it's really great, but 5 years away. And so that's something that is something that many companies and many projects in their space really have to deal with when they're thinking about the interoperability problem. And so when you see in this spectrum, you can kind of categorize the two solutions into two different buckets. And so inherently, what every solution is trying to do is verifying messages. When you're passing one message from a domain and you're saying it to another one, you want to make sure that it's correct. Because if it's not correct, you're going to have a problem, as we've seen with a few other projects in the past. And so how do you actually verify that is two different buckets. One bucket is off-chain verification. So you're basically running a phone node, or you're having a committee of people running a phone node in order to verify the validity of one transaction in an origin chain. And you're submitting that transaction knowing that it's correct on a destination chain. The other end of the spectrum on a different bucket is on-chain verification, where instead of relying on off-chain actors, you basically have the destination chain have mechanisms in place in order to actually verify the validity of a transaction on your origin chain. And so we call that on-chain verification. And so if you plot all the different projects in the space along the spectrum, you can kind of see that a lot of them are falling kind of in that middle bucket, right? They're saying, I'm not fully trusting, one entity in order to have a very extensible design, but I'm not fully trusting kind of the code primitives or the cryptographic primitives that we have in place in order to enable that, because that just takes too long, and I can't be in different domains very quickly. And so that's kind of the spectrum and the trade-off that we see for all these interoperability projects. And so kind of double-clicking into what each of these different spectrums are very quickly, I'm sure many folks are quite familiar with kind of this implementation, which is a multi-signature. And so instead of trusting one entity in order to verify a message, such like CCTP and Circle, you're actually trusting a committee. And this is what I like to call the OG approach to bridging. Because essentially what you have is a committee of folks that have a N of M, a kind of threshold signature scheme in order to validate a transaction is correct. And so instead of saying, oh yes, like one person needs to just run a full node and see that this transaction is valid, it's going to be a committee of 5, 15, 25. We've seen various number of implementations. And there needs to be some sort of threshold, whether it's a majority or whether it's even a 2/3 of people voting on the validity of a state and actually passing that through into a message. So this is something that is quite frankly a very, very quick time-to-market solution that we've seen a lot of implementations kind of deploy. Kind of more recently, that's been really popular in the past year, is more of a coordination approach. And so this is something that is known to be, at least for now, an optimistic verification. And so instead of relying on a committee of folks signing, you're essentially breaking the job of bridging the two different jobs. And so you have a relayer that is passing a message optimistically, basically, but you have another actor called a watcher that's essentially monitoring these optimistically passed messages and ensuring the validity of them. Not saying that the relayers don't also kind of have some validity assumptions or validity kind of mechanisms in place as well. But essentially, there's a challenge period that is happening. And so it could be 1 hour, 4 hours, 1 day, what have you. But within that period, the watchers are going to be looking at all the relayed packets and ensuring they're valid. And so this is something that has a little bit more trustlessness in it because it's an honest minority one-of-n trust assumption. So you just trust that there's at least one good watcher acting and looking into the relayed packets. But again, it's a little bit less extensible than what we've seen with the multi-signature approach. The next approach that is, again, more trustless is native verification. And so essentially what this means is instead of having any sort of off-chain actor, you actually have two chains that are interacting in this cross-chain transaction flow, verifying one another. And so how that actually happens is with these chains running like clients of each other, which kind of at a high level kind of view of it essentially means that each chain is participating in the consensus of another chain. And so they're able to see when the actual native verification mechanism of the origin chain is completed, and therefore they know with certainty that it is a valid transaction that could be executed upon on the destination chain. And so this is something that we call a trust minimize approach, because you're essentially trusting only the inherent chains that are involved in this process. You're not inheriting more trust assumptions from an off-chain actor. But it's still not, I would say, the holy grail or the most trusted solution in this space, because there is an assumption in place called an honest majority trust assumption, which basically means that you are trusting that all the nodes of the participating parties are actually being truthful. And so there is an instance in which a native verification mechanism could be exploited, in which the origin chain's validators are actually signing a side block or a uncle block that isn't actually being passed into the kind of main chain from a fork choice rule perspective, and therefore they're kind of attacking the destination chain, but kind of lying and obfuscating the fact that even though they all signed for a valid transaction, it's not actually the real transaction on the origin chain, and therefore the destination chain can act upon it, and that might actually economically hurt them. And so teams have come out and said that this is not necessarily the best solution either. And so I think what is very nascent in the space is the idea of using snarks, which is a combination of external and native verification. And so instead of having kind of the very inextensible design of the previous case of light clients verifying one another, which is really difficult when you look at n number of chains and all these chains need to run like all sorts of different light clients. You actually rely on an off-chain actor, in this case a ZK snark prover, in order to actually perform those transactions. And so in this flow, there is a off-chain verification from an entity running a phone node on the origin chain. They're actually generating a snark against that verification, sending that to the destination chain, and there they can actually verify that the snark is valid on chain. And again, this is something that is more scalable, but still relies on the honest majority trust assumption that we talked about in the previous case. Because again, you're still relying on the inherent proof of consensus and the honest kind of majority assumptions of the origin destination chains that are interacting with one another. And so the absolute holy grail of trustlessness is rollups or canonical bridges. And they're the most secure because they do something called proof of execution, where you actually have a proof of a state transition. And so in this case, validators of the L1 actually verify the validity of the new state root of the rollups. And so if you think about something like an Arbitrum, where they're posting kind of the state of the transactions in which they're compressing onto L1, Ethereum is actually verifying the validity of the data availability as well as the fault proofs in order to actually have kind of verification of that what happened on Optimism actually took place. And so this is something that we call an honest full node, a single honest full node assumption, which basically in the case of Ethereum, you're just assuming that there's one honest full node on Ethereum, which is a pretty easy trust assumption to make. And so this is the most trustless of all, but as you can probably tell, this is only pertinent for a rollup to L1 experience. And so this only works for Optimism to Ethereum, or another rollup onto a Cosmos settlement layer, for example. But it would not work in terms of extensibility, and it would not work in terms of going to time to market as you want to expand in different places. And so this does not work for something like an Avalanche to a Polygon because they're not rollups of each other. And so I kind of walk through the different solutions in space, and you're seeing that as we move slowly on the right-hand side of the spectrum, you're sacrificing a lot of extensibility, and you're sacrificing a lot of time to market, and you're kind of relying on a mechanism that is either not extensible or takes a very long time in order to actually expand to different domains. And so that's kind of, I think, up until this point, the inherent trade-off that every interoperability protocol has made. But I'm here to present you guys today something that I don't think I've seen many people talk about, which is bringing modularity actually into the interoperability thesis. And so folks are kind of familiar with the modular blockchain thesis. I'm presenting the modular interop thesis. And so essentially what we're doing is we're breaking apart the idea of what a cross-chain interoperability protocol does into three different pieces. And so you can see here its application, which is kind of inheriting application-specific standards from the level, something like queries, cross-chain, or cross-chain accounts using account abstraction. You have kind of verification, which is the ability to actually verify the transactions, kind of what we've been talking about. And we have transport as well, which is, you kind of think of it as a very base layer. It's actually what is the base specification from like a byte code level of actually passing messages. And so what is the benefit of this is if you look at kind of the modular blockchain stack, it was actually able to overcome kind of the inherent trade-offs of blockchains, where in one hand, you either had very centralized nodes that were really fast, or on the other hand, you had very decentralized nodes that was very slow, right? Like kind of like a Solana versus Ethereum example. But when you add in the modular blockchain thesis and you have rollups, you suddenly have a composite system like Ethereum plus their L2s, which are not only fast, but also decentralized. And so the same thing is happening with the modular interop thesis, and I'm kind of listing some new modular protocols and how they're thinking about it from the interoperability perspective on the screen, where they're actually able to overcome the inherent kind of trade-offs that interoperability protocols have made. And so how is that possible? And so essentially, when you look at the spectrum that I've kind of listed out and the trade-offs that every kind of solution has made, right? On one hand, you have quick extensibility, but it is less secure because you're relying on some sort of off-chain verification. And on the other hand, you have machines which are not extensible, but are very trustless in that regard. You can essentially modularize this entire stack and swap out pieces of it in order to allow for kind of the solving of this interoperability trade-off and interoperability spectrum that I was talking about. And so some projects doing this are Axelar, kind of comes to mind, but as well as other solutions like Polymer, Earlybird, Layer 0, and Hyperlane. And essentially what they're able to do is swap out their verification layer for all sorts of other mechanisms in order to actually overcome this trade-off. I can talk more about that in a second. But just quickly going back one slide, what is kind of the benefit of modularity? I kind of talked about kind of the best benefits, which is you're actually destroying or you're kind of regarding moot the trade-offs that I was talking about previously that every other monolithic solution has kind of provided. But there's there's an array of other benefits that we see for kind of the ability to modularize the interoperability stack. And so one of them is developer choice. You're able to actually provide kind of different authentication mechanisms based on the use case. Talking more about that in a second. Future proofing, because you're modularizing, you can start swapping out different components that are more optimized or more technologies that are currently in R&D, but will kind of evolve and mature and eventually be hardened in the future that you can develop, something like a ZK snark. And you can also mix and match kind of a combination of verification mechanisms in order for maximum flexibility and security. And so I was kind of alluding to what does it actually mean in order to be a modular stack. And so I think the most concrete way in which I can show you guys what a modular kind of interoperability stack looks like is with examples. And so I think the most popular way in which interoperability protocols are able to modularize themselves is actually by swapping out the verification layer. And so if we go back previously again, you could see that it's the app layer, the verification layer, and then the transport layer that kind of contribute to the three different jobs that an interoperability protocol does. And what essentially we're double clicking into is actually the verification and various implementations that other interoperability protocols are deploying in order to be modular on the verification sense. And so on the first piece, you have something that we call app configured. And so this is something that Router Protocol and Layer 0 are doing. Essentially, they're giving kind of the choice up to application developers in order to assess what the verification needs to be. And so in this case for Router, what they're doing is, they have their own app chain in which they have validation of messages, but you can actually augment those validators with an app-specified off-chain validator as well. And so that's something that's a heightened amount of security for the Router use case. And in the Layer 0 use case, I think that famously what they're trying to say is every application is able to actually pick their own Oracle relayer pairwise connection. And so different applications can trust different oracles and relayers in kind of their permissionless vision. And so that's kind of a configurable way to do verification. I think the most popular way that we're seeing kind of modular interoperability stacks actually looking into modularizing the verification layer is with bespoke solutions. And so this is something where Axelar is coming in, where I know they've been having discussions on how do you actually allow for various verification mechanisms, but also kind of keep the overlying system very similar. And this is something that Seller, Hyperlane, and Earlybird are also doing. And so what this looks like concretely is essentially they're offering different modules within their interoperability solution, and they have different choices of what developers can want to use. And so they can have a choice in which, for certain use cases, you can have a multi-signature wallet, something that is very extensible and very quick to adopt. So something that is ideally low value, so Web3 social or NFT use cases kind of come to mind. Kind of the middle area is using optimistic verification, and so something that probably is less, more important than an NFT use case from a value perspective, and doesn't necessarily need as much latency or as much finality or quickness to transaction completion in order to do so. And so, this is something that is probably like a low financial transaction. And then lastly, they're able to slide in ZK snarks as well as some form of, this kind of hybrid off-chain, on-chain verification for kind of more trustlessness into the stack. And so this is something that is more kind of suitable for large kind of financial transactions. And so that's kind of the most popular kind of adoption I've seen of a modular verification stack for interoperability protocols. And then lastly, we have something that I call outsourced, where these interoperability protocols aren't even using their own verification layer. And so famously, that's being done by Hop v2 and Connect's Amarok, where essentially they're a liquidity layer that relies on the verification of canonical bridges. And so they can facilitate L2 to L2 swaps just using the canonical bridges. They don't have their own verification layer, which I think is kind of the future. I'm at time, but thank you guys for allowing me to explain something I'm very passionate about. If you have any questions, you can find me after this talk, or you can follow me on Twitter. Thank you.
All right. So exciting to talk about infrastructure and then at the same time be talking about user experience. One of the things that we have the sort of, I think of it as kind of a luxury, but in a way it's a little bit, as I was saying earlier, intoxicating. It's a little bit of an addiction. And especially having smart analysts like Jim in a space that are looking at the space, categorizing it, and thinking about kind of how can we think about what the future might hold at this infrastructure level when we think about what's happening cross-chain. So very delighted to have him here and present. And I'm also super excited to announce this next panel. I'm going to be moderating it. My name's Galen. I run content at Axelar. Colton Conley from Prime Protocol is going to be on the panel. Fig from Squid is going to be on the panel. If you haven't done a cross-chain swap, go to 0xSquid. What is it? Squidrouter.com. That's right. New URL. And do a cross-chain swap today. It is fun. If you've bridged, this is something totally new. Thomas France from Signy Capital. Ledger co-founder Thomas France from Signy Capital. Will all be joining us to talk about mass adoption in one click and why Interchain UX matters. Please welcome the panel with a warm round of applause. All right. Thanks, guys, and welcome. So for this one, I think we'll open it up for questions from the audience. If anybody says something and it sparks a question for any of you, just raise your hand. I'll acknowledge you. You can put your hand down. Somebody will bring you a mic. Just remember to please speak into the mic when you ask your question, all right? So let's get started with introductions, please. If you could just each kind of, and I'll start with you, Colton.
Sure.
Tell us about Prime Protocol. Tell us what you do and what interoperability means.
So Prime Protocol is the first natively cross-chain prime brokerage. What that means is we're doing cross-chain lending across a ton of different EVM chains that Axelar supports. And so this means that you'll be able to deposit your tokens on ETH, for example, take out a loan on Arbitrum, maybe take out a borrow on Avalanche, and then you can bridge those anywhere and maybe recollateralize the position on Moonbeam. And the cool thing about Prime Protocol is we're completely cross-margined. So all of your positions that you have on ETH count towards your global account. All the positions that you have on Arbitrum, Polygon, Avalanche, Moonbase, any other chain that we support, it's all one borrowing experience for DeFi. And so that's really what interoperability means for us, is abstracting away having to basically have a separate account on each chain and have one global account that you use for all of DeFi.
I think it's really interesting. It's like people think of UX as like the things you click, right? The things you tap.
Right.
But this is like the UX. Imagine like if you had to, your banker couldn't handle, Right, your broker couldn't handle assets in different categories for you.
Yeah, exactly.
Different broker for each.
Yeah, it's like saying that for your Tesla stock you have to go get margin from Goldman Sachs, but for your JP Morgan stock, only JP Morgan's going to bank that. So you've got to basically use a ton of different banks, a ton of different lines of credit, and what that ends up doing is siloing all of your different positions. So you have higher liquidation risk. The UX is way worse, which is the topic of this panel.
Awesome. Thomas, please go ahead.
Yeah, Thomas. So I'm now with Signy. Before that, was like the co-founder of Ledger, so this little hardware wallet that you may have used in your life. So it started really as a Bitcoin wallet, then to like let's say multi-wallet, like with different silos that you were saying, like different assets in different chains, and with like the rise of like Tendermint, Cosmos, and Axelar, the ability to make a thing of all these assets and a model way that leads to like a lot of innovation, a lot of cool new products that are rising. And with Signy now, it's a fund that is investing not just in blockchain and what we'll call like the future of trust. So combination of blockchain, AI, privacy, kind of building blocks to build like better, more trustworthy technology. And blockchain is obviously as a trust machine, like a big part of what we invest in. Interoperability as well, and Axelar, we're big fans from the day one and investors in this ecosystem.
Excellent. Fig, go ahead, please. Tell us about Squid.
Thanks. Hey guys, my name's Fig. I'm one of the co-founders of Squid, and Squid is the cross-chain swap layer on Axelar, so it allows you to swap any token on one chain for any token on another chain in one click. And you can extend that as well. So if you want to buy an NFT in Matic on Polygon, if you have USDC on your wallet on Avalanche, you can still buy the NFT in one click. And we do all the optimal routing in the background. So we only use Axelar in the as our infrastructure layer, and Axelar does the cross-chain execution. Squid builds routes on top, and we find the optimal route through existing DEXs like Uniswap and Curve and a bunch of partners in the space.
Cool. All right. Well, let me kick this off with a question, and I guess I'll put it to you maybe first, Fig. I'm not going to say the F word, but a lot of centralized services have been the on-ramp for people coming in when there's moments of enthusiasm and kind of exuberance in our space. You see, centralized exchanges, centralized lenders, really kind of being the first place people often go. And I'm guilty of it myself. People say, "How should I get some crypto?" I say, "Well, go to Coinbase." Right?
Yeah.
So what advantages do those what are they doing that enables them to be those on-ramps? And what do we need to do differently?
Yeah, I was thinking back to when I first bought crypto, and I think for me it was the fees, actually. You can send money to Binance with no fee, or a lot of centralized exchanges, and then you can buy with very deep liquidity. So that was the first thing. Which we have a lot of catching up to do, and the DEX space is improving with concentrated liquidity, which we've got a bunch of integrations with. We're looking also at direct integrations with fiat on-ramps as well, so we can maybe take a part of that flow. But another thing is the integration. So you can do all that you need if you want to get crypto. They receive fiat money. They swap it to crypto. You can hold your crypto. They do the whole thing in one package. I think that integration is really important for UX and something which DeFi hasn't really worked out yet. Everything's extremely modular, and you can't do in a single interface yet.
Do you think that's even possible? Can we think of doing that? Like fiat, for example. That seems like a daunting bar to pass, right? That's sort of what does DeFi even mean in that context, right?
Yeah, totally. I think what this could look like is if a wallet integrates both Squid and a fiat on-ramp, and we compose them together. And then even just in your wallet interface, you can send fiat to it, swap it into crypto in one click. Squid also takes a highly integrated approach where we combine all the DEXs into one application. So no matter what chain you're interacting with, it's still just one interface, and we can keep extending that to wherever the natural endpoint is.
Colton, how does that play in lending? Like, where do you feel like?
So I guess one example of something that we're pursuing is you can essentially have a credit card where you can spend from your Prime account, and so this will be an integration with basically an off-ramp provider. And what that'll allow is let's say you have a ton of collateral, you don't want to exit any of those positions, but you want to go literally use this at a point of sale with a card in your Apple Wallet or a physical card. We would partner with the provider, and you'd be able to spend from your USDC balance on ETH, either from your deposit, or you could choose to borrow as you make that tap. And it's all backed by your existing positions. So I think there's definitely a lot of opportunities for using DeFi as the rails that you're building these consumer-facing apps for. And I think on the flip side, for deposits, ultimately, I think in 5 to 10 years, a lot of the people who are depositing into Prime won't know that they're depositing into Prime because they're using a consumer-facing app where they're telling them, here's the yield you can get. The retail user ultimately doesn't care about the chain that they're on as long as the app is only using secure chains. And so they deposit into the app. They're told, hey, you're going to get 4%, you're going to get 5% on your cash. And this is done by lending through a DeFi protocol. The user's like, great. And then the app routes all of that to Prime in the background. And then if the user wants to be able to take out a loan based on that position, short a token or do anything, Prime is what's going on in the background that the app is interacting with. And the user is interfacing with maybe a centralized counterparty that's doing the on and off ramp. So I think that there are going to be a lot of these kinds of applications that pick up traction. And we've already seen that happen. I think the big issue was a lot of these very prominent CeFi platforms were blatant Ponzi's, like Celsius, where the user funds were not being deposited into a DeFi protocol, and they were being given that yield.
Right.
They were being used to gamble, and then they were being promised the yields that wasn't being generated by the actual DeFi protocol.
It's not that databases are bad, right? It's that humans do irresponsible things potentially. Right. Actually, Thomas, this is a great point maybe to kind of bring you in here because you've said you're investing in the future of trust, and I'm curious kind of to know more about how you think about that, and especially sort of how do you convey that trust in the user experience?
And coming back to the centralized exchange and why they got that much of traction, I guess it's also because like they solve a problem for people who want to get in crypto, and I guess that's like the main reason why they get like so much like top of the funnel in a way that like your journey into crypto, you generally start like by saying like, okay, this looks good for whatever reason, whether it be the tech, whether it be the speculative aspect, whether it be the art, the NFT, then you need to find a way to get in. And like the good centralized exchanges are a good way to kind of, start your journey and get an initial exposure. And then you start to understand like what it's about to kind of own these assets, that you potentially need to own your own keys, and then that you need to interact with a protocol directly. So your journey starts with like the centralized exchange, and people stay there because of lack of education or lack of understanding of what you can actually do afterwards. And I guess that's really a good thing around like the good sex, the good centralized exchange, to say that you can it can be safe in some way, but yeah, you can like at least get in, and like it's your first start of the journey in the crypto world. So there are some like you cannot fully decentralize and make trustless like the kind of fiat on ramp. But there's some ways like where you can minimize the time where the centralized exchange have like custody of your funds, like the folks from Cato. There's like a bunch of different on-ramps, off-ramps that you can use that are still not as good in a way that there's still some fees, but at least you have like a balance between the fees you pay and the counterparty risk that you cannot have. So I guess that's really what made them like so big and prevalent. But as you got more education, as you got like more occasion of using like decentralized protocols, there are like better in some ways. Like it's better to use like like a decentralized exchange or like an aggregator than like an actual centralized exchange. So like when the product is actually better, or you can do stuff that you cannot do with centralized exchange, like people will naturally use it.
I mean, I guess that's the question I'm still trying to get at, right? How, like for most people, okay, I trust my bank, and even that's probably questionable, right? Like, there are many examples. Wells Fargo, for example, right? But whatever, I trust Wells Fargo, I trust Bank of America, I trust these names, right? Not to do things like Celsius did, right? But how do you let the user kind of understand, like, the user who doesn't necessarily understand things at the code level, who can't verify, Right? How do you sort of convey that this isn't, hey, we won't mess around with your funds. This is, we can't mess around with your funds. What's the path you think for people to convey these benefits to the user, not just in a way that they're actually delivering the benefit, but in a way that the user understands the benefit?
Yeah, no, it's a tough one. It's a very big question, and I think it needs to be fairly like it will be slow. It will evolve like step by step, where you need to start trying with this protocol and start like with like a certain amount of funds that are locked in to make sure that that things are safe and that the user kind of understand what they are doing. So I think there's a lot around like education and like being thoughtful that again, like when you've got like some crazy yield and crazy promises, it's most likely that there's a problem somewhere.
Yeah. Right.
I mean, I actually think there's a pretty easy solution to this, and that's just that there are going to be third parties that pop up that can look on chain, and they're doing the developer work for you, and then they put up dashboards that are monitoring the contracts, and they can tell you, hey, the funds are actually there. Here's how much is in the contracts. We can see the code. We verified how it works. There's not some upgrade path for everything to be stolen from you. And I think that as the industry matures, we're going to see more and more of those services pop up, and users are going to be interested in using those to make sure that their funds are safe.
Who is the user who really like demands these days, you think, like instant settlement? I mean, other than like the utter degenerate crypto trader, like who is the user that really demands like instant finality, bearer asset, right? I mean, I'm thinking, like, I think about like stuff like the nickel market ruction in, what was it, last year or the year before, right? Where the nickel market that just busted apart in the UK. And I mean, they had to like halt the market, walk back trades, right? You had people on like one side of that trade who were very not happy about the money that they thought that they had earned that day, and then it turned out that they didn't. I don't know, like what if you think about like the user persona today, and maybe go back to you, Fig, on this as you're thinking about sort of Squid and the cross-chain users and the cross-chain swaps that you do. What's that persona look like? Can you describe those people? Who's using and why?
Yeah. Oh, what are the uses of crypto? That's a good question. We can build the infrastructure, but I don't know what it's useful for. I mean, the users today is sending money and swapping assets. I think that's one of the best proven use cases. But I've started to think of it as a future of e-commerce as well, that you're going to be able to accept payments in fiat or crypto, or the other way around, you can pay in fiat or crypto. So I think it could extend to any commerce really, as a form of payment, form of holding assets. I think the
fiat pegged probably, right? Like a sort of a dollar pegged or some other fiat pegged.
No, well, yeah, you could use stable coins. Yeah, for sure. But any crypto that you're holding, you want to be able to use it without having to do all these steps to get through.
You got in because you were curious and you're interested. Now you want to be able to. Yeah, that's.
Yeah.
Right. That's the oldest, I think, use case. It's like, hey, we can let you buy something on Amazon with this.
Yeah, exactly. Yeah. I think you have all the other use cases like NFTs and games and physical embodiments of, NFT embodiments of physical things, like real estate. But I think just getting the payments layer solid first is something, and then I think in terms of the trust of how people are going to start to adopt this is. There's a proxy relationship where you trust the person below you. Like we might have the nerds start the degens, and then we have more formal institutional traders, and then we have like on top of that we have maybe retail facing, and then it keeps building up, and then hopefully that is all falling back down to a private key at the end of the day, and
and something verifiable.
Yeah.
Colton, on the more sort of, risk-oriented side or finance-oriented side, what do you think about the users of a Prime protocol type of product?
Well, I think one of the huge benefits of DeFi is the fact that all of the risks are transparent, and you'll be able to know like what are the risk parameters, when am I getting liquidated. You're not getting some arbitrary capital call because somebody got scared, and I think this also, because you have to have consistent risk limits, it leads to higher collateralization ratios, which some people don't like. But ultimately, that's what caused the last blow up, was everybody got over-levered and got a bit too greedy. And so I think that the benefits of what Prime Protocol is offering is a way to make sure that your counterparty is somebody not only who you can trust, but who has taken appropriate levels of risk, so that if the liquidation needs to go through, you're going to recover all of the funds and you're going to get your deposit back.
Right.
And I think that's just DeFi in general, and why you haven't seen any big losses on any of the major lending protocols in DeFi, was because the nature of it, at least with collateralized lending, forces you to be both over-collateralized and transparent, which wasn't happening with any of the centralized lenders, and almost all of them blew up. So I think that's a huge advantage of what we're doing.
Thomas, I'm curious about your perspective as an investor from your portfolio and the projects you're talking to. What are people thinking? How are people thinking about their users? Is it important for them to be thinking about their users? Maybe they should be focused more on the sort of core technology and the pipes, if you will.
Well, of course, you always need to think about your users, and in the case of blockchain, it's users that want to have certainty on what's going to happen, and transparency on what's going to happen, and transparency and the assurance that there's not somebody that is going to roll back something, and so you can build trust on the fact that it's all. It's all open, it's all auditable. People want to make the extra step of understanding how it works and or can rely on some trust of some other third parties that kind of use it and give more signals to build that trust. And as far as so for the users, really anybody who want to have this certainty that the settlement is going to happen, and you're not going to have an outside party that is going to say, okay, I'm going to make a margin call, I'm going to roll back, and having that uncertainty. And as for the portfolio companies, how they think about the user, I think it's always the same thing. If you think of your user and understand what they want, how they interact with your product, and kind of building from that, it's there's a lot of easy lessons and easy advice. It's really to be with your users, build with them, understand how they interact, iterate fast, iterate, and see where traction comes, and that's the best way to build some initial great market fit and solving actual problem for a user. So yeah, definitely there's a clear pattern about listening, working with your end users, and success for sure.
Nice. I'm curious from the audience, how many people have done a swap? How many people have traded crypto in the audience? Here, raise your hand. Have you ever just traded back and forth? Not just I bought crypto, but I traded. Okay, all right, a few traders here. Well, how about a cross-chain swap? Who's done a cross-chain swap? Okay. Hey, most of the people who have done swaps here have done cross-chain swaps. That's awesome.
There were some people who didn't do a swap who did cross-chain swaps.
Wait a minute. Go back. Roll the tape. All right. Well, okay. So what about let's see. What about depositing? Say. Okay. What about a cross-chain swap over decentralized infrastructure? Come on. Okay.
From fiat to crypto.
Yeah. Right. That's right. That's from one chain to another. Yeah. What about deposited on a crypto protocol in order to earn yield? Who has done that? Who has done made a deposit into a crypto protocol in order to earn yield? Okay. Good. About half. How about borrowed over a crypto protocol for whatever insane purpose? A smaller number, but still pretty good. Yeah. Cool. All right. Well, look, I don't want you to be shy. If you have any questions, just raise your hand. I'll call on you. Okay, over there on the side. Gentleman that way on the side. He'll come over to you with the mic. Don't forget, speak into the mic, please.
Yeah, for users, we're talking about users of the past, right? How we grew up, how we got involved in crypto, but how do we see the users of the future onboarding? That's what I'm really interested to see your perspectives on. How we abstract away stuff the same way that the vendors or the social media companies of today have abstracted things away for users to make it easier for them to easily onboard and leverage those systems. How do we see that next generation of onboarding looking like?
Yeah, what does user onboarding in the today's sense and also in the Web3 sense look like compared to user onboarding of yore?
Yeah. So, what we've realized with our launch has been that Squid is actually an onboarding tool in a lot of ways. So a lot of our partners will implement our widget, which is this little component which allows you to swap from any chain, and that allows users from any blockchain to swap into this application. And so we just need to extend that to essentially allowing fiat, and that will be partnerships through fiat on ramps, where you can make it in one flow. And so you can imagine like an onboarding widget where you want to get this product, say it's a lending product, and you can pay using crypto, which is in any of your wallets, or you can select wire transfer or fiat, credit card. So I'm thinking that you can actually onboard directly into the application in a lot of cases. The question that's in my mind still is how a user gets a wallet, because they have to sign up to a relevant wallet, and I think that's not yet solved. Whether we're not going to probably have wallets per application.
Private key management problems like that remain. No doubt.
Yeah.
Anybody else, or what's the user of today?
Yeah, I think it's important to think about like mass adoption, but like that's like a few years away, and we need to think about like wider adoption and making sure you can like bring in like more users by like improving like some of the on-ramps, improving like the general infrastructure. And so when I think about mass adoption, it's always about it's mooning, it's mass adoption, everybody's incoming tomorrow, but for what? Like I don't think like all the use cases are clear to have like 1 billion new users coming today. So it really needs to go like in steps, like having like some tools that are like better for like wider audiences, meaning like better on ramps, the ability to have on-ramps directly when like pull some money like directly into smart contracts, or improving like some of the wallet experience for people to interact with like some use cases that make sense today, like whether it be DeFi or NFTs or digital ownership or whatever. So it's I would think like nothing too far away, and be very pragmatic in the steps to kind of improve the current infrastructure, bring in some more users, and be more pragmatic in that step in that option.
Nice.
I think at least my perspective on this is there are two kinds of users that you're onboarding. They're coming from two different places. The first are people who just don't have access to mature financial infrastructure in their countries or economies. And so crypto is what allows them to be able to transact with other people, or basically allow the unbanked to earn yield on their assets. And I think those people are going to be onboarded in a different way and maybe use things actually a bit more crypto natively than a lot of the people coming from developed countries, where what they're more interested in is they want to make money and they want to be able to move money easier. Yeah. And so I think you have to solve the UX problem of how do we get over all of the key management issues that crypto currently has to onboard a lot of those users from developed countries. But a lot of those solutions are going to be regulated and KYC'd and maybe not available to people in developing countries who are going to use things a bit more directly through wallets.
The leapfrogging effect has its effect, right, on what the user is like. Well, this has been great conversation. I want to thank all three of you for coming. Everybody, please give a warm round of applause for the panel.
Thank you.
Thanks, Ian.
Thanks, Galen.
All right. So that was a lot of fun for me personally. Anyway, I hope you guys had fun too. Glad we got to get a little Q&A going. I hope we can do more of that through the next couple days. Next up is something that I think you are definitely going to want to be in the room for, especially if you were intrigued by Jim Chang's presentation on modular interoperability. You know that Interop Summit is hosted by Axelar, and perhaps you know that Sergey Gorbenov is the founder or co-founder of Axelar. He's going to give a presentation that's going to give some insight into the way Axelar sees the future development of interoperability. So please give it up for Sergey.
Awesome. Hello, everyone. Great to see many of you here. There are some seats at the front if you guys want to come and sit down. So first of all, I want to thank you all for coming here. I don't know if many of you know, but we originally tried to organize this event in Miami at about the same time, in February, and we thought, people will have a great time, go to somewhere warm. We had a few amazing speakers lined up, the venue was booked, and then you know what happened? Well, none of you signed up, okay? So it's actually great to see all of you here in Denver, building in the bare winter with a lot of other folks, so I'm excited for this. Awesome. So before we talk about Axelar, I want to take just a quick step back and tell you a little bit about why we're here and what are we really trying to do, right? I think many people have made the analogies that blockchains are really cities, right? They're powered by unique technologies, they're open, they're permissionless, and they need to be robust, right? So whether or not you're talking about a natural disaster or kind of government or electricity going down, the cities need to continue functioning. So the question is, how do you build a business across all of these cities at the same time? So if you're building an NFT store or you're building a stable coin, you want to be able to give users a very simple way to access your business and interact with it in a consistent and uniform way. And so until recently, we only had two options. Right? The first option is what we call the trust option, and I think we've talked about it throughout today. Right? It's not that hard to take a centralized database and build it across decentralized cities. Okay? You put a server, you put an application server in the middle, and that's it. But we've seen a systematic failure of a lot of these centralized protocols. And the second option is what I call the suffering option. Okay? What does it mean? Well, as a developer, right, you can go and take your application and you can put it across all of these different chains. You can clone it, right, like Uniswap's been doing it or USDC has been doing it. But then you leave it up to the users to figure out how to use the application, right? And it's up to the users to get a wallet, get some gas, and we talked about it today, figure out how to bridge their tokens back and forth. And it's really, really bad experience for the users at the end of the day. And we cannot continue scaling that way. And so today, there is a better way, right? And the better way is to build Interchain native applications. So these applications are architected from the ground up in a different way. They're relying on different technologies and have different properties underneath the hood. So these Interchain native applications can span the whole of Web3. So meaning that whether or not you're using this application in one city or the other, you would have a consistent and uniform environment and consistent user experience that you can offer to your users. They can be powered by decentralized interoperability protocols, right? We have an array of protocols that have been built. They're all can be robust. They can all stand the test of time and all kinds of nuclear and other types of disasters that you can think about. They allow your applications to compose, right, from one another. So sending smart contract calls, transferring tokens, messages back and forth. And at the end of the day, they enable very, very simple user experiences. And this is what we want. So if you haven't played with any of these Interchain native applications, I think you just heard a panel by kind of a Squid and a few other folks. And I think it actually gives you a sense of what does Interchain native mean, right? So to give you a sense a little bit of how this actually works under the hood, so Squid actually does not build a new DEX or anything else, but it allows you to swap an arbitrary token from one chain to an arbitrary token on another chain with one click. Right? The way that it actually does it is by, in an interesting way, composing existing DEXs and routing liquidity across them. Right? So things like USDC. So no new wrapped assets have been created in this process. Very simple UX, very simple to interact with. And you don't have to think about multiple chains as you're using this application. So go and play with it if you don't know what Interchain native means. And the second point about Squid is that because it's Interchain native and it's been redesigned from the ground up, the security properties that it has are actually really, really strong, meaning that it does not assume a lot of security from the underlying bridge other than in some ephemeral state while you're doing your transaction. So, and you could only do it if you actually redesign your application, you don't have wrapped assets or anything else like that. And so this is the end game of Interchain native, right? It's the having simple UX, having simple composability across the applications. This is exactly what we're here for. And so from the very, very beginning, this has been Axelar's goal. I think if you look at our earlier presentations and everything, this has always been the mission. How do we enable users to interact with any asset, on any application, on any chain with one click? And the way to do this, and the way we've been doing this from the beginning, is to focus on developers. So Axelar's mission from the day one has been to empower developers to build applications that can span the whole of Web3. So if you look at our earlier white paper in the beginning, you can actually see that its title is Connecting Applications with Blockchain Ecosystems. We don't focus about bridging. We don't talk about how does chain A talk to chain B, but we really talk about what does the stack needs to look like, what do the architectures need to look like, so you can enable the experiences that we're talking about here today. This has been our goal, and this will always be our goal, is to think about how to help developers to build these interchain native applications. And so this is what we have done, right? On the high level, Axelar network consists of 3 different layers. So the core layer, there is the network itself. It provides you connectivity. It provides you routing. It provides you message translation. And I'll talk about these things in a little bit. On top of it sits what we call as a service layer, right? So things like relayers, things like gas services, things like monitoring services, all the pieces of infrastructure that are needed to actually enable those developer experiences that we talked about earlier. And at the very top of it, very simple SDKs and APIs that we expose to developer to actually consume the rest of the stack. And so today, the Axelar network, it's been live for a little over a year. We're connecting over 30 different ecosystems and 30 different chains. Packets can go in and out between any of them, processed over 1.8 billion in cross-chain volume, and working with a lot of leading partners like Circle, Osmosis, Ledger, and so on and so forth. So I'm very, very excited to where we got here today with the Axelar network. So I don't want to go a little bit too technical, but let me give you a little bit of a preview of what are some of the key features of the Axelar network. And the first one is a basic property to be able to connect chains in a very efficient way. Right? So at the core networking layer, there are multiple interoperability protocols that are supported. You can use IBC if you have IBC support. You can use a protocol like CGP that we developed to connect with EVM chains. All of those protocols are available at the network layer, and it depends on the chain that you're interacting with. You can use one or the other. The core property of the network is that automatically, every time you establish a connection, you get many-to-many routing properties, right? So the traffic from your connection can be routed to any of the other ecosystems and can be sent there. You can do things like asset transfers. You can do message transfers. And really, you can think about anything else to transfer across these protocols. So they're completely generic. So one of the very exciting properties that I like about the network is what I call as a cross-chain translation. And we have actually done this recently by having a stack that now can fully interoperate between Cosmos and EVM chains. So previously, we were able to transfer like tokens, and you can send assets back and forth with one another. We've done more. We've extended it so that Cosmos chains are now fully interoperable with EVM chains using things like general message passing. So you can encode your transaction in a Cosmos stack. You can send it through Axelar. We'll help you decode it and rephrase it and figure out the right encoding that it needs to happen to post it on the EVM chain and vice versa. So in some sense now, the Cosmos stack, I think, is becoming more and more glued together with the EVM stack. And I think, as time goes by, these are going to be indistinguishable ecosystems, I believe. So it is live on the testnet. It is staged for the mainnet over the coming weeks. So I'm really, really excited about this property. Now, how do actually developers consume all of this? And it's actually very simple, right? So you download the SDK, and then you can leverage any of the protocols that we have, like general message passing for token transfers, and compose your applications. You can issue interchain tokens. You can transfer NFTs, and so on and so forth. And so all the complexity of interoperability that I talked about earlier throughout all the stacks is actually hidden away by very, very simple abstractions and APIs, right? This is literally the API that you need to know of if you want to send a message from an EVM chain to another EVM chain. So 3 parameters: destination chain, contract, payload. You send it, you're done. And that's what we want. We want developers to be able to use very, very simple interfaces and abstractions. Now, we do have a challenge. The ecosystem keeps growing, right? So today we have many more layer 1s. We have many layer 2s, layer 3s. We're talking about data availability layers. And so every time you have a new layer, you introduce in a system that is going to need to talk with other systems in probably asynchronous way. You're going to need to send messages between them. You're going to need to compose them with one another. And so this is kind of growing really, really fast. The deployments are getting complicated, right? As developers are building across multiple stacks, they spend a lot of their time thinking about how to deploy their application logic. And so the interoperability infrastructure doesn't really keep up with all of these things. So can we do better? Can we actually address all of these issues and keep up with the demand for interoperability? And so to solve this, we are introducing to you a new layer in the stack, which is the Axelar virtual machine. Let me tell you a little bit what that means. The Axelar virtual machine is a Turing-complete layer that we add in the interoperability stack that allows you to code at the interoperability layer itself. Okay? So it's powered by a combination of Cosmos and technology plus some consensus logic and various gadgets that we've been building over the years, and they're composed together, in an interesting way, and we can talk about it more in the technical sessions. And what that means is that anybody can program at the interoperability layer. Right? You can instantiate new connections. You can optimize the speed of transport. So maybe for some transactions, you want to take a risk and finalize them in 5 seconds. For some transactions, you need to wait for longer and finalize them in 20 seconds, 30 seconds. So you can do all of that. You can customize all those protocols. And so the VM at the interoperability layer allows us to code Interchain 10 times faster. That's my claim. Okay? Now, you might be thinking, well, where does 10 actually come from? Right? Is that a real number? And I claim that it is real. So I'm actually going to prove that it's 10 times faster. And the way to do this is by combining zero-knowledge proofs with artificial intelligence. Okay, so let's go through the proof quickly. I'm kidding. We're not going to go through the proof. This is one of those things that I like doing once in a while. Kind of throwing my professor hat on, getting some formulas, and it drives our marketing team nuts. So it's good to have fun. Awesome. But there are 2 points I actually want to make here. Is that because it's a programmable layer, that means that the parameter 10 really depends up to you as a developer. If you're a good developer, you can code 100 times faster. You can make connections and scale Interchain. If you're just starting out, it can be 1x or 2x. So that's one point. The second point, though, if you are a builder in this room, if you are in particular raising capital, you really should figure out how to combine the words zero-knowledge proofs and artificial intelligence in your deck. Okay? Funding guaranteed, I can tell you from every investor in the room. Awesome. So moving on, I want to introduce you to a couple of kind of exciting projects that we're going to be launching with the Axelar virtual machine. The first one is specifically to help us scale the Interchain by adding more connections through the stack. So what does it mean? You'll be able to use the virtual machine to code a connection to the Axelar network. You can customize its security. You can extend it as much as you like. You can use any technology that you can think of, right? Zero-knowledge proofs are available. Great. You can instantiate it. Light clients proofs are available. Great. You can plug them in. The core property, though, is that by plugging in with the Axelar network in the virtual machine, you get to amplify your work. And that's why it's called an amplifier. So what do I mean by this? A lot of these kind of technologies that you use to connect ecosystems are actually hard to build. Okay? We've been talking about light client verification across non-Cosmos chains ever since I've been in the industry, frankly, over the last 7 years, right? Those are hard things to build. Zero-knowledge proofs, they're finding a lot of momentum, and I think it's going to be great technology. It's going to power a lot of blockchain stacks, but those are hard things to build. And the problem with a lot of those things is they're not reusable, right? So if you're building a light client or zero-knowledge proof to connect 2 different chains, you got to repeat the same work to connect 2 other chains, okay? Because a lot of those technologies depend on the underlying consensus, technical stacks, and so on and so forth. And so, frankly, the issue scaling those light clients to zero-knowledge proofs was not really technological, but economical, right? You spend a year or two building one of these connections. You plug in A and B, and that's it. And you can't reuse that work, right? You have to spend it over again, 2 years of work, plug it into other chains. And so by having one-to-N connectivity properties through the Axelar stack, you get to amplify your work, right? You build once, maybe you spend 2 years of engineering work, but you get to compose with all the other connections. You get to compose with all the other ecosystems for free. So you amplify all the resources that you have spent. And so you can plug that in. And so the end goal that I think we want to see is this notion of really timeless connectivity, right? Where today we should have protocols that are used very easily to connect different ecosystems. Maybe they're based on RPC methods or some external validation. If light clients, zero knowledge, IBC, anything else is available, you should be able to go and instantiate it, right? There's no reason not to. You can continue building the best in class individual connections to the Axelar network. Once you have many of these connections, you can compose them at the application layer, right? So if you have a very low value transfer, then you can say between Ethereum and Axelar network, well, I'll trust it as long as any of these connections is good, right? As long as any of these connections verifies my packet. But if you want to have strong security and you're transferring hundreds of millions of dollars, you might want to compose them, right? And you say, I want to rely on a transfer of $100 million if ZK and an RPC or ZK and a light client validation layers independently verify this transfer. So you get to compose security at the application layer, continue building your application in a uniform way, and so I think this is really, really powerful. Now, the second product that we're going to announce is something I'm really, really excited about. And so it has this property where you can build once and run everywhere. Right? And so this is called Interchain Maestro. So what is the basic idea? I think, as I told you earlier, a lot of the builders that are now stuck in this multi-chain world, they actually don't build in the multi-chain, okay? They spend 70–80% of their time thinking about how to build multi-chain and managing their contract deployments and managing their upgrade paths and admin commands and governance around it, but they're not actually building, right? I mean, I don't know if many of you know, but there's been a long debate or discussions that just started by Uniswap community, right, about how to do governance with Binance Smart Chain. There's a lot of discussions, there's a lot of debates, and then we try to understand a little bit what is all the fuzz is about. The fuzz is about 20 messages that need to be sent over a year, right? And so people are not actually building in the multi-chain because it's hard. It's hard to deploy, it's hard to orchestrate, it's hard to manage. And so this is what we want to make it easier with the Axelar Maestro. Right? The basic idea is that on the virtual machine that we have, we'll be having a set of template contracts and a set of services around it that you can leverage to manage your application across multiple stacks. Right? So you can set up governance commands, you can set up admin commands, you can upgrade paths, and so on and so forth. So it's really going to help developers simplify their multi-chain deployments and management. And hopefully, they're not going to be spending 70 or 80% of their time on thinking about building Interchain, but actually doing and improving their application logic. So that's the hope here. So if you're familiar with products like Kubernetes, this is really kind of an analogy that I think is kind of closely resonates, where in the Kubernetes you specify your deployment configuration, right, and it will help you deploy across a variety of stacks and software layers. Awesome. And so now let me give you kind of a quick demo of what is the end user experience from a developer's perspective that we want to enable. And this is a very simple demo, but it's going to show you what types of user face or developer facing interfaces we want to allow. So an interchain token is something we've been working on. I think every interoperability protocol by now has this notion. It's like, how do you take a token and make it available on all chains, right? In a very efficient, very consistent way. It's all about tokenization, and this is a critical service. So let me go through this demo, and you'll be able to see it. So what do we have here? We have Avalanche contract. It's an ERC20 contract that's been deployed on the Avalanche chain. And then maybe pause here for a sec. Yeah. And so through the Interchain portal, you actually get to manage this token deployment across multiple other ecosystems. So here you can see that we actually deployed a version of this contract on Binance Smart Chain, on Polygon, and it's been registered on Avalanche. If you want to deploy it on more chains, oops, sorry, go back. Let me play this. Yeah, let's just continue playing. Can we continue playing? All right. Well, it's okay. Yeah, just keep it here. So it's a contract that's deployed, on Avalanche. Like I said, you can deploy it on multiple other chains by effectively using one button. Right? It says deploy on more chains. Can we continue playing? There we go. And you just get to specify what chains you want to deploy it on. Right? So in this case, all the chains have been connected through the Axelar stack you can pick. We're choosing just 2 for the demo, so Phantom and Cello. You specify what they are, you click, you deploy gas, and that's it, and you walk away. Right? So it's literally kind of a front end that you can build that abstracts all the complexity of managing gas fees across different chains, figuring out how do you deploy your contracts, and anything else around it. And so all the services and the stack that we've been building over the years effectively helps you deploy the contract. And this is an interchain token, right? So these tokens can be sent back and forth across chains in a very efficient way. So they're interconnected through the Axelar messaging protocol. They, connected through the Axelar scan and all kinds of other tooling and SDKs that we have built. So this is really the end goal, right? So this is like an example of a token transfer, but the deployment and management of your application across multiple chains should be as simple as that, right? And so that's what we're going to continue working towards. Awesome. So another kind of a workshop that I want to kind of send you to, if you haven't heard about it, there's actually a pretty cool SDK that's been built on top of Axelar by the Cubist friends, and it has a similar goals, right? So the question is, how do I write my contracts in a very easy way, kind of set them up and run them across multiple chain environments, and kind of backed up with the Axelar protocol and different services underneath the hood. So they're helping you automate all of those processes in a very efficient way. So I encourage you guys to go and check it out as well. So what is the impact of all of this on the developers, right? I think, first of all, we'll be able to facilitate many more connections across the stack. You can customize your interoperability, like I said. If you're a fan of zero-knowledge proofs, light clients, or you want to customize your latency, you can do all of those things. And we want to have a minimum work to run your applications across different environments. And so that's really the goal for us. And so today I'm happy to announce to you that in the next kind of phase of the Axelar network, we actually extended the network even further and connected many more amazing partners, right? Stellar, Base by Coinbase, Mobile Coin, Near, Shardium, Starknet, Centrifuge, ZK Sync, and a bunch of other partners been working with Axelar to extend their ecosystems to all of you, all of the developers, to make sure that you can build in this interchain native way. Awesome. So yeah, I'm not going to go through the quotes. You can take screenshots and read it offline. But yeah, super excited for the lineup and working with all of these amazing developer ecosystems. The final thing I want to mention is that we really want to supercharge Interchain, right? And so to do that, I'm happy to announce kind of a separate developer grant program that we're going to be launching to help build on the Axelar virtual machine and instantiate more connections and scale the interchain. The goal here is really not to, this is not a program for kind of dApp builders. We have a lot of those already. There's an ecosystem fund and a lot of things. But if you are a protocol builder, you like cryptography, consensus, you want to understand how to make connections across different ecosystems, you want to help us build this Kubernetes for Web3 using the Axelar virtual machine, this program is for you, so I encourage you to apply, and we're going to be selecting teams and working with them very, very closely to build a lot of these functionalities. So that's all. If you want to know more, there's a link. You can go. There's a QR code. There's a blog post that dives a little bit deeper on what we're building. You can find application to the grants program. And come chat with us throughout the rest of the day and throughout the rest of the week. We are super excited to continue supercharging Interchain with all of you. So thank you all for coming.
All right. Pretty exciting. So, hey, it's lunchtime. We'll be back here at 1 o'clock and on the hacker stage. We'll see you then. Enjoy your lunch. Have fun. Have some good conversations.
All right, ladies and gentlemen, if you would, please take your seats. We're going to start in a couple minutes. If there's anyone outside that you have a connection to, encourage them to come on in. We're going to start in a couple minutes. Thank you. Ladies and gentlemen, please welcome to the stage, James Friel.
Hello, friends. Thank you guys for staying around for the afternoon. We have another great set of speakers coming up here and great conversations. We're going to kick it off with a conversation led by a bunch of the leading VCs in the industry. And I think as we look into this new market, it becomes ever important for them to figure out where actual value is going to accrue. And when we look at the Interchain, that discussion becomes only more complicated. So we're going to hear from Adam Winnick at Finality Capital Partners, Merrick Sandrick from Rockaway X, Travis Scher from North Island Ventures, and Ty Panic from SCB 10X. And Kit Lau from Lau Ventures is going to moderate this conversation for us. Let's give him a round of applause.
James. Thank you, sir. Thanks, you guys. Hey. Alrighty. All right. Thank you, everyone, for being here. We've got an exciting panel here. Investors of different stripes and origins and geography. So it'll be great. Maybe before we get into the investment thesis, would be awesome to kind of start to talk about what does the interchain and multi-chain world look like in the next 5-10 years, right? And how that drives these investors' decisions. So I think with that, let's dive into it. We've got a lot of ground to cover. Maybe we'll start with Travis. What does the interchain world look like in your fund's view, and how does that impact your decision in terms of investments?
I think that the future of the crypto ecosystem is that it's a complex, interoperable network of networks. We're going to have Ethereum, which has the most users, the most security. People are going to build roll-ups on top of that. You're going to have, other monolithic chains like Solana that are more scalable, more optimized for composability. And then you're going to have the Cosmos ecosystem, where people who want to build their own chain, spin up their own validator network so that they can customize more parameters, will do so. And I think all of this will be stitched together by networks like Axelar.
That's awesome. Well, maybe another point of view, Ty, what do you think?
Yeah, I think it's amazing that we keep on seeing more and more L1. I think we already have more than 200 L1s already, but we still keep on seeing more and more. And L2 as well, right? Last week we saw Coinbase coming out with based on optimism. And then, like Travis said, Cosmos also have so many app chains coming out. But I think with all these, we won't have any chain that rule them all, not a single chain. But we're going to have a multi-chain world. And when we have something like this, liquidity is going to be fragmented. And we need to have the interoperability that much more improved than this. And generic messaging protocol like Axelar is going to be the key to actually make the interoperability improve. So.
Yeah, no, that's great. That's great. So let's dig a little bit more. Like historically, the architecture is dApps on L1 chains, right? And that's still true by and large today. Let's go to Adam, because Adam, you and I have talked a little bit about this before this conference, just in terms of, that's the architecture today. Where does the architecture go over time, and what is the almost the right abstraction layer for dApps to build on, right?
Well, look, I mean, to Travis's point, there's a lot of different chains that are going to have different use cases. At the end of the day, the reason people got excited about Bitcoin and Ethereum was it was this new sort of money, this new reserve currency that mattered to people. And at the end of the day, whoever wins the interchain thesis, and it might be one person, it might be just or several people, could be the reserve currency for all the blockchain ecosystem. And from the perspective, we think about it from the perspective of a developer who wants one API to access a bunch of services. There may be app chains from Cosmos. There may be infrastructure projects built on EigenLayer. There may be something built on an Avalanche subnet. There may be individual chains out there. And as an app developer, you don't want to manage all these APIs. Who can abstract that for you? And whoever can extract that for you and build the messaging layer that connects all of that, their currency may become the reserve currency. So, from our perspective, that's how we're looking at it, and that you can dissect that and think of multiple ways for to invest your money along that thesis.
Yeah, that's interesting, because I mean, this dovetails a little bit also into Marek. I'll move to you a bit, because you and I also talked about before, the various architectural shifts in addition to what Adam was talking about in terms of vertical, horizontal scaling, modularity, as far as Rockaway is concerned, right? Like, when you look at all those, like, how does that impact investment thesis for you guys?
So for us, I think there's going to be like multiple ways how to approach it, and there's like different trade-offs for different people, right? So I think it was already mentioned, like we have hundreds of chains, and there's different, let's say, use cases or that are good to deploy on these. There is like some are optimized for finality, throughput, scalability, and others. And so like all of these L1s are getting like also like different roadmaps how they will approach in the future, and that's how they will shape their unique selling propositions towards the teams that are going to be building on them. And I think like like modularity is even just like increasing the complexity, but we definitely need to have some kind of a stitching element that enables the teams that are deploying to abstract this complexity when deploying. Because like from the perspective of the teams, I think Adam has mentioned it, right? So I think like one way how the architecture was like deploying the smart contracts on the L1, but I think then from what we have seen, then there's a lot of copy paste of the projects that were like deploying the same idea without much innovation, just on the different chains, and they were getting funded, they were getting as well, let's say some kind of attraction. However, then I think now, when I'm thinking about it from the user perspective, if you just like flip it around, like users don't typically want to be thinking about different chains. So like also like with the Web3 going into the mass adoption, it's very important to actually have like a unified use case, like whether it's like borrowing, lending, or whatever. And it cannot be borrowing on chain X. It needs to be literally a use case specific for the user. And the blockchain or the infrastructure elements, similarly as we have it in Web2, needs to be abstracted for the user. And so I think like this is something that will happen. I think there's like multiple architecture types that could happen. So like I can imagine that like we will, what I would call move from this like smart contract and layer 1 to, let's say, like a level 2, where we have like multiple smart contracts on different chains, and then they are being just like they're being coordinated by like a communication layer, for example, like Axelar. But also like I can imagine that like here we will see a competition, and like the competition is actually happening. And then I think there's like a layer 3 where we actually have managed to abstract this complexity fully. And in this, I think even the execution itself can be pushed to this messaging layer, or which can be, projects such as Axelar or like any other.
Yeah, that's great. That's an interesting viewpoint. I feel like, heterogeneity, right, and complexity suppression is two of the big themes that I think we've heard today and from you guys as well. So, with that kind of context set, let's get down to the meat of it. Let's start from Ty, going down there. Given all those that you just said, what does your interchain thesis look like? What sectors or subsectors are you guys and your team excited about in the next 6, 12, 24 months?
Yeah, with the interchain world thesis, I think Bridge have been seeing a lot of investment and continue to be very popular. But I think the securities area is the key concern for Bridge. Last year, we already seen 2.5 billion got hacked from Bridge. And Bridge is the area that has seen the most exploit compared to other applications. So what I'm interested in is actually in the security area of Bridge. So I want to see the specialization on security audit. Because like in general, if we look at Web 2, right? Web 2 in different area of application, you see different security auditor. And I think Web 3, we should also have that type of thing. Because normally when you have different applications, there are different considerations when it comes to security. So we need to see that. And we would be looking for this type of investment for the startup that trying to become more specialized security auditor.
I'm betting on folks like Sergey, who, if you heard his last presentation, I'm betting on folks like Sergey to execute well and for them to build these general messaging protocols that are going to make it super interesting for app developers to build not only Interchain, but more useful applications that incorporate all sorts of new middleware services and make it easy for those middleware services to integrate with that API. And so therefore, we're very focused on middleware and things that are going to make blockchains more useful, higher utility, that can plug into messaging layers built by folks like Axelar.
So when we launched our fund about 3-4 years ago, our thesis was that in its end state, crypto is this interoperable network of networks, like the internet, where assets and messages can move seamlessly across chains, across the world. We thought that was going to take a very long time. We met Sergey. He convinced us to invest. The risk at the time, the second half of 2020, was that it was too early to build something like that. Since then, the greater risk has been that there's too much competition. We entered this multi-chain world faster than I think anybody expected. And where we think this ends up is that there are these natively multi-chain applications that aren't tied to a single piece of infrastructure. However, it's very early for that. And so, over the next 6-12 months, what we'll continue to do is investing in infrastructure that enables the creation of those applications. And so, we've made a bunch of investments, particularly in the Cosmos ecosystem. It's where most of, I think, the best infrastructure and best is getting built by the strongest developers who are aligned with this thesis. And I think, maybe in 1-2 years, we'll see more exciting opportunities in the sort of native multi-chain application space.
I would maybe structure it first about application and then infrastructure. On the application side, I think teams building user-focused, let's say cross-chain native applications. So I think those we find exciting. On the infrastructure, I like to think what are still unsolved problems. On one hand, I think scaling is still a problem. I think we will see some rollups that are settling on multiple chains, possibly utilizing ZK technology. I think that's going to be very exciting. I still think privacy is a problem. So I think we are living in the blockchain world where like we have pseudo-anonymity. I don't think on this time horizon of like 5 years is going to be sufficient condition to have pseudo-anonymity. I think anonymity will be a required condition for a mass adoption. And then I think lastly, it's like, let's say, something aligned to a theme of like easy deployment of either apps, rollups, and others.
Yeah, no, that's great. One of the threat and themes I think you guys kind of touch upon is sort of, infrastructure enabling dApps more valuable, more multi-functional dApps, and better user experience to kind of float up, right? And we've seen this in Web 1, Web 2, where Cisco's of the world kind of laid the foundation and enabled the Facebooks of the world and the Googles of the world to kind of enable almost a magical experience, right? Connectivity and the like. So this is more of an open question for any of you guys, right? Do you see that happening in Web 3 anytime soon where, if we look back the last 5-10 years, the base layer protocols have captured a lot of the economic rent, less so on the dApps, with some exceptions. What do you guys make of that moving forward?
Okay, I take that.
Yeah.
So I think you're talking about FAT protocol thesis.
Yes, it's for you guys. Have not heard of the FAT protocol thesis. I think it's USV that came out with it a few years ago. That basically says most of the economic rent capture is going to happen at the base layer protocols, right? And I've always been skeptical, right? That may be true in the short and medium term. Curious what you guys think.
Yeah, no, I think that when he came out with that thesis, it was 2016. So before we have multi-chain world, and I think in his thesis he was thinking that there will be probably a single chain that will be monopolized and dominant, and that's how the FAT protocol thesis coming out, because the thesis was that the protocol, the crypto protocol, will be able to capture more value than the dApps that building on top. And that was because the dApp will have to use the native protocol tokens to power all the interactions. But then now we have multi-chain worlds, and I think we all talk about it, that we don't think that there will be a single chain that rule them all, because there will be a lot of chains. And in my opinion too, that users will also use different chains for different activities based on their needs and their utility that offering by each chain. And so like the monopoly wise, it's not going to be that much. And then on top of that, now we also see some of the dApps that actually have very strong brand equity, like Uniswap, for example, right? Everybody knows Uniswap, how good they are. And let's say today, if Uniswap are going to go to new chain, completely new chain, it will definitely get more traction, much easier than like a Fox, Uniswap app, because like Uniswap already have this brand equity. The user know what they will get, and then also they're going to get like all these liquidity providers that already work with them to probably move with them to the new chain as well. So now we also have dApp that are quite powerful with strong brand equity that, back then Joe Monegro didn't think about it before. So I think that because of this FAT protocol, this is not going away, but the significance of it is going to be much less.
Anyone else chime in?
I mean, I agree with that. I think that the value of an underlying protocol has something to do with the volume of transactions on the protocol and the amount of fees that you're able to charge per transaction, right? At the end of the day, that's how protocol should be valued. In a world of many chains, there's much more competition, and so there's much more pressure on the fee side. I also think in a world where you have something like Axelar as a developer platform, where things get abstracted over the longer term, users should not have to care about what chain their applications are running on or what chain their assets are living on. Something like Axelar could deploy those applications and assets on whatever chain is best suited for the underlying use case. And so, I think for something like Ethereum that has this, what seems to be an extremely sticky user base, there'll still be a lot of value accrual. But for, the rest of the ecosystem, there's going to be a lot of competition, and it's hard to say what the defensible moat will be for some of these other blockchains. And so I think that some of the applications that really do own the end user relationship, and I'm not sure if Uniswap really qualifies there because it's not necessarily an ongoing relationship, but say you have sort of a multi-chain identity system of some sort, where people they start using it to build up a reputation or to control their own data for use cases that occur cross-chain, and they have to keep using it to keep benefiting from it. Those sorts of applications will be defensible and have moats and be really sticky, and have real network effects over the longer term. So that's my best guess right now on how the value accrual plays out.
Adam? I'd like to make a comment, maybe part question for Travis. I mean, when I think about the fat protocol thesis, it initially started talking about these independent chains, but that was before we imagined things like Axelar. So, I mean, could you apply the fat protocol thesis to an Axelar and where it sits and becoming the API messaging layer and that capturing the value over the dApps?
Yeah, I mean, we're not here just to talk up Axelar.
Well, listen, we can talk about CCIP and
no,
in the same breath.
I totally
I just didn't want to
agree
mention
with
their
you.
name, but you forced me to.
It could be Axelar, it could be somebody else. I think it'll be Axelar, but you basically have this protocol that plugs into all these different chains that starts out moving messages and assets across chains. But at the end of the day, if this is where developers go to initially deploy some of their applications, it could serve as sort of this meta layer on top of all these blockchains that have all this branding and all this sort of tribal loyalty today, but over the longer term, people may not care about them if they're not really differentiated. What will accrue value is the infrastructure that ends up being really sticky, and it could be something like Axelar.
Yeah, I mean, the way I saw it. Sorry, America. I'll just finish this thought. Is like, hey, Ethereum could still be like this place that captures most of the value of the L1 layer. Like Intel, AMD was created to help chip buyers feel comfortable with buying chips from Intel. They wanted a second source. So even if every other chain is just a second source overflow for Ethereum, Ethereum can still capture a lot of value. Chainlink and Axelar can fight it out for the messaging layer. And then I think your point is great, is someone's going to own the customer, some identity play, whether it's tied to a wallet or something that abstracts the wallet. And then these three big players are duking it out in some sort of tech dystopian, version of the FANG stocks all over again. I mean, it could play out that way. So,
Mark, what do you think?
Yeah, I mean, so I do think that there is going to be more value coming to the applications itself, but there's multiple trends there. So I think one is also that I think we will see more complex application going live, and that will enable them to actually have much more significant mode. It's either through the go-to-market, distribution, business relationships that they are able to form, and that actually will more grow the pie. So if I'm thinking about the applications being able to extract let's say a small part of the whole value chain, I think it will grow because of the complexity and the value add that they are able to create, right? And so that's one thought. And then second is, okay, in the FET chain, or FET protocol thesis, then there's the remaining value and how it's going to be distributed. I think it's fair to say that the fact that we have multiple chains, I don't think that is actually going against any single chain, because if you have two chains, then you have applications on top of it, and there are the reason why it was the applications were not able to extract as much value is because of their lack of moat. However, I think that's changing, and also I agree that because we have the interoperability, we will actually need to somehow redistribute the messaging layer and the settlement. However, I think we cannot we should not forget that the security that the L1 is actually bringing to have the entire ecosystem is a fundamental value that needs to be there. for the blockchain actually to exist and like secure the assets that are on top of it. So I still think that there's going to be a significant value accrual in multiple settlement layers.
Yeah, I mean, I think, multi-chain is ultimately all about, another layer or another level of decentralization, right? Different use cases, generic, specific. With that, maybe I'll switch a little bit and talk a bit about some of the recent events that's happened, from a regulatory standpoint, right? I'm curious to overlay that view for you guys. Does some of the chatter and actions from the SEC, from regulators in the U.S. specifically, does that impact any of your thesis when you guys look at deals? Anyone?
Look, my view is that the vast majority of tokens in this ecosystem should not be treated as securities. And they certainly shouldn't be subject to securities law that's 80 plus years old. I think the SEC's position currently is the opposite of that the vast majority should be treated as securities and that the old law applies, even though there's no practical way to apply it. I think that there's tremendous regulatory headwinds in the U.S. There's an immense dichotomy between the actual energy and the ecosystem amongst developers, which is amazing. Apparently, there's 25,000 people here this week, and some of the energy in the broader world, which is super negative on crypto. So, for us, I think it does mean that we want to be a little bit more cautious over the next year in terms of our investment pace. I also think. I've always done a lot of investing outside of the U.S. We've done a lot recently. I think that we probably are seeing more new companies building out of the U.S. We've seen entrepreneurs leave the country to start their businesses, and I also think that there's a little bit of a case of maybe the dog that didn't bark, where there's real chilling in the U.S. right now. So there's probably tremendous number of talented people who would be starting businesses in crypto if the regulators in DC weren't so hostile.
I'll just say, kind of building on that point, my view is I want to be very aggressive with investing right now, but I want companies to have a really long runway, because it is so uncertain and you don't know how it's going to play out, and you need to pivot and you need to stay alive and just adapt to whatever this cycle is going to be. But on the regulatory side, it's really hard to predict. And I mean, I look at a lot of things internationally, despite I hear a lot about, Hong Kong opening up. UK regulatory authority is being really aggressive with courting the crypto community. I still see, a lot of really strong U.S. founders. And the ones I know are building here. They're not moving away. But they, have to contend with a lot of uncertainty.
Yeah. And then for our other two panelists, Ty and Mark, and you guys are based in, Asia and Europe respectively. What do you guys think?
Yeah, I think the SEC, the regulators are definitely driving activity outside US, because right now I think it's like regulation by prosecution. Because they try to go after, let's say, Kraken, right, on staking, and then Paxos on stablecoin. And then now I think that DeFi is going to be under scrutiny as well. And the founders who are not anon before probably be thinking maybe they want to be anon as well. Or if they are still based in US, because of all this regulation, they might... the regulation might be coming after DeFi as well, so they might also thinking about moving out of US. We definitely see, exactly like Adam said, that Hong Kong is opening up. They're now being more friendly towards crypto, because I think they try to get the financial hub status back to the country. And so now they're coming out with the proposal that allow retail investors to be able to trade large cap tokens like Ethereum, Bitcoin in the license exchange, and also propose the license regime for virtual asset trading platform things like that. And then Singapore continue to be crypto friendly, but a bit thoughtful, because I think there's a lot of things that happening in Singapore, like Terra was actually based in Singapore when it collapsed, and then FTX was like in Hong Kong, but there's a lot of involvement around Singapore ecosystem as well, and actually like Singapore was like number 5th biggest user for FTX. And so Singapore is a bit more thoughtful, but continue to be friendly. So I think that there will be a lot of activity shift to Asia. And I think recently Cameron Winklevoss also tweeted out that he thinks that the next bull run of crypto will be coming out of the East. I think it might be possible.
Yeah, I mean, like from our perspective, I think like as investors, like we need to stay optimistic, right? So like as an early stage investor, like you always believe in the possible future, and I think always innovators are like like pushing on the boundaries, sometimes even boundaries of the law. From the perspective, from like the European perspective, or let's say like on the reaction of US, I think like crypto was always like global first. So yes, like US regulation is important, but there is like the whole world to actually like capture. So like I think it's very okay, and like I think like it will find its path. And from the European perspective, like what we are seeing, that like the ecosystem is like quite strong. Like one from the developer perspective, I think like London and Switzerland, they have like a very strong like research base or like people like pushing new projects. From the legal standpoint, like Switzerland is like very friendly to set up foundations that are crypto native, and then also like I think Lisbon, even though like we don't see a lot of like number wise, I think like projects, but or incorporating, but actually like people living in Lisbon. So I think it's also like becoming a hub or like has become a hub and sufficiently competing for people to actually come and live. So I think like US turning the negative sides towards crypto, I think just like opening up opportunities for other countries to compete for that.
Yeah, that's great. We are unfortunately down to the last minute. Let's see if we can go through this very quickly. For each panelist, non-obvious prediction you have for the next 12 months. Limited to like 5 seconds. Tai?
Oh, it's very hard. but in my opinion, I think that regulation should be good. There will be a lot of regulation for sure, but in my mind, it will provide clarity, and that will also make institutional investor to feel more comfortable with crypto and come in more.
Adam?
God, that's a hard one. Non-obvious. Okay, that non-obvious prediction is that users are going to get paid for their data within the next
that's a good one.
18 months.
I like that.
And want to get paid for their data.
Oh. Travis?
Yeah, I don't know if I have a non-obvious prediction. I don't like predictions. But I think that, 2022 was a catastrophic, somewhat traumatic year for many people in the industry. I think this year, is not going to be that bad, but there's a ton of headwinds on the macro side, on the regulatory side. User adoption fundamentally is still extremely low. So, I think that the latter half of this year, things could actually just get potentially a little bit more boring. That in that way would be very different than, times in the past. And I think that, as founders or employees at crypto startups, I think psychology is going to be as important as strategy, for maximizing your medium-term, long-term success.
Mark?
It's a difficult one. I think so. We will be surprised with some of the progress that ZK will make during this year. I think we will see like some first real applications, maybe even outside of the blockchain.
I like it. Finally coming. Well, with that, guys, thank you so much. Round of applause for the panelists.
All right.
Thank you, Ike.
Travis mentioned during that 2022 was really about Cosmos jumping onto the scene and all of the strides that it made and the way that it's been leading the conversation around interchain connectivity. So our next panel, we have some of the well-known names I think a lot of you guys know that have helped build this. And the question is, what do the next 12 months look like? So please welcome Sunny Agrawal from Osmosis, Akash Khosla from Evmos, Rebecca Lau from Sega, and Zaki Manian from Somalia. And this will be moderated by Thyborg. Thank you, guys.
Star.
Okay, so I think the speakers today are very well known, at least in the Cosmos ecosystem. So I'll just introduce them very quickly. We have Sunny from Osmosis, we have Akash from Evmos, we have Rebecca from Saga, and Zaki from Inclusion and Sommelier. So everyone is building in the Cosmos ecosystem, so I'm guessing the title of the panel is The Outlook for Cosmos. I'm sure everyone thinks it's very bright. So I'd rather take like the other side of this and see what are the problems and issues we have in the Cosmos ecosystem for this year. So let's start with you, Sunny. You have say you have a young team from Berkeley, randomly, that asks you, should I build in the Cosmos ecosystem? How would you convince them not to build in the Cosmos ecosystem? Send them somewhere else.
I think the biggest reasons to not build on the Cosmos ecosystem is, I think the stack is still definitely much newer than the EVM, right? Like I've always been a EVM long-term skeptic, but like short-term, it has the most developer tooling, the most documentation, and it's just easy to get started with and deploy something very fast. And I think that it's provided a really good platform for bootstrapping and just getting to market as fast as possible. I think Cosmos teams, projects usually take much longer to get to market. I mean, Osmosis, we were able to do it in 6 months, but it's also because we had been working on the stack for 3 years prior to that.
Try this in 3 months, I think.
That's true, yeah, and I do think that it's getting better. I think that I've actually liked that I've seen more projects shift towards writing primarily in CosmWasm rather than in the SDK, and really treating the SDK as kernel level code. And so, I mean, we've been working tirelessly to help improve this. Our team has been building a lot of developer tooling for CosmWasm. We have Beaker, which is hard hat for CosmWasm, or TestTube, which is a testing framework. So it's getting better, but I think that is definitely probably one of the biggest still things we have yet a long way to go to solve.
Right. Zaki, can you give a counter argument to this? Can you take down Sunny?
Well, I mean, I think one of the other generally big challenges for Cosmos, for projects that would consider Cosmos, is that there is definitely a lack of liquidity in the ecosystem, right? In comparison to the EVM ecosystems that are out there, it's the TVLs, accessible value for DeFi, ease of onboarding stablecoins, all of these things are huge pain points for projects that are building in Cosmos. I think that would probably be one of them. And then the other sort of weak point of Cosmos that is we just don't have the wallet install base of Solana or MetaMask, and a large factor in that is the fact that we just don't have anything in sort of the NFT entertainment space that is has product market fit.
Yeah. So I guess for you, Akash, the lethal weapon of the Cosmos ecosystem is IBC, right? Now people are hopeful that IBC is going to go across all the other crypto ecosystem. We see that on Polkadot, we see that on Near. We're getting these connections. Can you make the argument that this is not going to happen? That someone else, maybe Axelar, maybe someone else, is going to take that spot, and IBC is not going to get wide adoption?
Yeah, I think when it comes to having like Axelar versus like IBC versus like trustless bridging like Succinct and all these other options, I don't think that like I do imagine a world where we're going to converge on one standard. I think everyone's kind of like working towards this convergence. That's how I see the competition as like sort of developing. IBC is really just a way of standardizing a solution, right? And I see Axelar in line with this ethos, generally speaking, for example, that it's important to be flexible about what standards you should have. And so I wouldn't say that IBC is going to get like killed by something, or other protocols might get killed by something, but I do think that they're going to evolve and they're going to adapt. And the ones that do evolve and adapt, those are the ones that are going to stick around. And there's ways for these standards to all be compatible with each other in the end, I think.
Rebecca, do you have anything to add to why IBC is going to fail miserably?
I don't think it's going to fail miserably. I do think that if you try to sell IBC as IBC, if you try to sell it as cross-chain communication, you will get an allergic reaction from a lot of other ecosystems, because the feeling for them is it's still a nascent space in which to play. Why is it that Cosmos, yes, it's been working on cross-chain communication for a long time. IBC is probably the most battle-tested and robust of all the protocols out there to handle this sort of functionality. But why is it that they have declared themselves the winner? And I find that in our conversations with other ecosystems, attacking it directly like that is probably not the most effective way to do it. What has been effective, on the other hand, is Cosmos just undebatably has value add to other ecosystems that they just are not going to be able to develop for themselves anytime soon. I think that Cosmos was early to the app chain thesis, to multi-chain, all these buzzwords that we hear so much about now. And other ecosystems are trying to imitate that, whether for scaling purposes or because they know that their applications, once they grow to a certain size, are going to have to get onto their own dedicated block space. Now they're trying to climb that mountain themselves. Cosmos has already scaled so much of that mountain itself. And to be able to provide that kind of infrastructure and knowledge and value add to those ecosystems, the price of the ticket of admission really is IBC. That's how we communicate with infrastructure that has already been built on Cosmos, can be very valuable for other ecosystems, multi-chain ambitions. And again, the way that we can transfer what we know and what we have built to you is through IBC. So no, I don't think it's going to fail miserably.
I have a general question for the panel, which is like, what would you define as IBC? Like, where do you draw the lines on what IBC really is?
Zaki, you want to take this one?
So I think the sort of core thesis. So I'd say there's like two. There's like one is there's the principle of IBC, which is that there should be no central point of failure. So where you think about, like, I differentiate IBC from, let's say, Axelar, is Axelar does have like one blockchain that is a control plane of all the interchain messages, and if that blockchain were to fail, it would bring the whole, that whole network down. Whereas in IBC, we isolate failures. So there's like the principle, and then the other principle is permissionless connectivity. So you don't have to do business development with anyone to connect to the IBC network. You just connect. Then there's like a bunch of, I think, very well designed software abstractions that were built, and those software abstractions allow for like layering protocols and building applications on top of those protocols in a way that's really dynamic. Those are, I think, like the pieces that like make IBC, and probably the one that like has, I think, the least, let's say, sort of enthusiastic adoption by the multi-chain industry is the last piece, like picking up the, like, absorbing the particular set of abstractions that like we chose for IBC.
Sonny, you know, with that understanding of IBC, can you explain, maybe, a little technical here, why specifically Ethereum and other EVM haven't been adopted IBC yet? Like, what needs to be done for that to happen?
So for Ethereum specifically, Like, so the thing with I guess like the difference between like IBC as implemented right now versus like most bridging solutions, including things like Axelar, is they work at the like application at the VM level, at the state machine level, while IBC really works at the consensus level. It uses like actual light client proofs, while something like Axelar, it doesn't actually care what the consensus protocol is. It just, because what they do is they just have Axelar validators running the like full nodes for the chains, right? But which is what makes it permissioned as opposed to like fully permissionless. And so the problem is that like the things like Axelar can scale much faster to many chains because many chains have like an EVM, but like a lot of these EVM chains all have like completely different consensus protocols. Avalanche has a completely different consensus protocol than Ethereum like pre-merge Ethereum did, than Polygon does, and having to write light clients for every single one of these is actually takes quite a bit of work. And so I think that's been one of the main reasons that like one of the main trade-offs there. And so I think that so what was the original question exactly?
I wanted to get a sense of what needs to be done for IBC to be enabled on Ethereum.
So I think like for Ethereum specifically, I think now there are people actually working on it, right? Like I think it wasn't worth the time to do until the merge happened, because we were all under this impression that like, hey, the consensus protocol for Ethereum is actually going to change, and so building a light client solution system and especially like building IBC for like not chains without finality, like proof of work had, was kind of annoying. So now that ETH 2.0 exists and we have like the proof of stake system, there are like more teams than I actually can count, or not can count, but like more teams than I'm aware of that like are actually building IBC implementations for Ethereum. Mm. But once again, the point is that like just because it's built for Ethereum, that doesn't mean it'll automatically work for Avalanche or Polygon.
Yeah, needs to be done one by one.
Yeah.
Yeah. So in terms of like challengers for the Cosmos SDK, I think that's a question for Zaki. You've been checking that out. Is there anything out there that competes with the Cosmos SDK that is an option right now, or maybe an option soon enough?
Well, so like in the beginning, in 2016, 2017, there were only two contenders to building app chains. One was Substrate, and the other one was the Cosmos SDK. And for reasons that I don't really feel like I have a full appreciation for, the Cosmos SDK has been much more successful with builders than Substrate has. But now we have many teams. I've invested in and advise and work with many of them who are all building other app chain building frameworks. So you have the Hyper SDK from the Avalanche team, which was just released. You have the Optimism and the OP stack sort of concept, and then like a lot of different companies that are doing sort of variants and forks and rollups as a service. You have this idea of like EVM Plus from the Arbitrum team. You have, so many of Sovereign Labs with their like zero knowledge oriented one. And it seems like, we are now, like the app chain thesis has become solidified enough in people's minds that like this is actually a target to build towards, rather than really building anything other than just like an EVM was considered pretty heterodox, in the last cycle. And now you have both a lot of different VMs, like the Solana VM, coming to like lots of different ecosystems. So where all this nets out, I think builders have a lot of choices, and the EVM is still the rapid prototyping environment of choice.
So who would you say is the main challenger here?
The main challenger? Probably the OP stack.
That's the one Coinbase just adopted.
Yeah, Optimism stack.
Yeah.
Is the OP stack anything other than just an EVM, though?
It's not anything other than EVM, but like there's no real reason it couldn't be something other than EVM. Like I think somebody has like a Game Boy emulator running on the OP stack right now. So
So Rebecca, I think Saga just signed a partnership with Polygon, right?
We did. Yeah.
Can you tell me like your experience working with Polygon? Like how different has it been from working with within Cosmos?
Well, very different. Polygon, I would say, is well, it's it's a crypto project. I think we're all supposed to say project nowadays when referring to any sort of crypto entity, but really it's a company. And so Polygon is centrally controlled. Everyone is either building on Polygon chain secured by Matic, or they are trying to build on supernets, which is what our partnership was about. So just TLDR is what Saga is doing with Polygon is Polygon has their own app chain solution. It's called supernets. All these app chains, no surprise, are manually stood up. People pick their validators and try to convince those validators to secure their particular chain. And then Polygon will build a bunch of customizations on top of that. Very, very difficult process, long time to market. What Saga is doing is automating all of that for them. And it is using Cosmos technology. So again, what was the price of admission? IBC. Now, in working with the Polygon team, what you find right away is they are very, very, very go-to-market driven. Everything is go-to-market driven. I would say that their technical vision is something that they come up with because they recognize that there's a need in the market, and therefore they need to fill that void with some sort of grand technical narrative. But what they're looking to do is absorb as much demand in business as there is out there for Web3. And so it's different from working with the Cosmos ecosystem. I think in Cosmos, we birth a lot of outstanding technology that is either inspiration for the tech stacks of other ecosystems, or they directly borrow from our code. But Polygon is just, they're out in the market. There isn't a single deal out there that they wouldn't look at.
Okay, so I think that's it for the negative part of Cosmos. We're gonna switch back to the positive part. Akash, so Sunny mentioned that the onboarding cost of building in Go, building in Rust, and that Solidity is much easier. And you co-founded Evmos, so I'm guessing you are kind of a Solidity bull. But I want you to take like the counter argument to Sunny and convince Sunny that actually it's not a problem, and that everyone will end up building on the Cosmos stack or Rust or Cosmos.
Yeah, so I definitely think that the Cosmos SDK method is going to work out. Like, what I anticipate is, we're going to be writing stuff in Go. We're going to be able to write things more flexibly, and eventually, we won't have to spin out a chain for every single application module we write up. Right? It should be easy to just inherit security from another chain using mesh security or replicated security in the early stages to basically make that happen. And so what I would like to see from that side is kind of validation that it actually is useful. So for example, this flexibility that you have when writing Go, is that flexibility, let's say, significantly better than having the confines of an EVM environment or a Cosmos environment, for example. And to me, that's not quite clear yet because, well, we have yet to kind of build out the technology that lets us just, spin out, a module as its own execution thread that exists as part of a consumer chain when it comes to replicated security or mesh security. And so where kind of the EVM typically contrasts with this is, it's a mature stack. I think right now in Cosmos, we're, I would say in the 2016, 2017 phases of seeing hey, what gets built with our stack. I think the EVM stack has been around quite long, and so we are further along in the evolution of the EVM stack. However, I think we need to extend it further to do more things, and that's where something like Evmos comes in. We're trying to build out extensions for the EVM so that you can leverage things that exist in Cosmos. So we have this kind of strong synergy with both the EVM but also with Cosmos tech.
The Evmos SDK is going to be built in Go, right?
Correct, yes. The Evmos SDK is kind of a toolkit that is, I would say, competing with OP Stack more directly because it's it's EVM focused, and so we're enabling people to basically spin out their own EVM chains this way, but also enable them to take advantage of the extensibility of Cosmos while doing so.
Yeah. Sunny. So Zaki mentioned like one of the big problems is liquidity, and of course out osmosis, that's something that you guys probably struggle with. How do you see a path to bring liquidity in Cosmos and fix that issue?
Yeah, I think one is like native USDC. I think will help with like stablecoin liquidity. Native, I would like to get more native other stablecoins, Tether, whatnot. I think then on top of that though, I actually think making the UX easier for people to bridge over assets. I think Axelar has made it quite the UX actually pretty seamless of bridging over assets, especially if you're doing it from the Osmosis website. But I think we can, continue to make that even better. Axelar just 2 or 3 weeks ago rolled out you don't have to deposit wrapped assets anymore. You can deposit native ETH and Matic or AVAX or whatever. And so we're currently working on adding that to the Osmosis front end. I think that will make stuff a lot easier. Making the bridging much faster. So there's this thing that we've been collaborating on the spec of called ForCall, which will make it much faster to send assets between EVM chains and Cosmos chains without having to wait whatever the finality period of the EVM chain is. I think there's a lot of things that will. I personally, I think that the key is to get the UX right, and then the liquidity will follow wherever the best UX is. Our take has always been, at Osmosis, our take has always been build the best user experience, get the average traders coming to use that, and then the liquidity will follow the volumes.
So Zaki, there's a team that has been able to attract a lot of liquidity in Cosmos recently. Do you know who I'm talking about?
The Canto team.
Yes, the friends of Akash. So how do they do that?
I think one of the things that I think is relevant here is blockchains are their own cultures and communities, right? But we're at an Interop event, right? And it's about interoperability between these cultures and communities. And so, in many ways what Evmos has, sort of the difference between Evmos and Canto is the code is largely identical, but the ethos and vibes and are much more, sort of born out of a subculture within Ethereum rather than a subculture within Cosmos. And it's sort of interesting to see ethos impacting liquidity to such a great extent.
So Akash, how do you see bringing that liquidity back into Evmos?
Yeah, that's a good question. So I think there's two approaches to thinking about liquidity. One is the zero-sum approach. You're how do we take liquidity from other places? And the other approach is how do we actually create new opportunities for liquidity? And I think at Evmos we're thinking a lot more about the long term. We're thinking more about less so the zero-sum approach of taking existing liquidity and more so thinking about how do we actually create new opportunities for liquidity, or how do we rather incentivize people to make the new liquidity happen. We're also not really TVL maxis at Evmos. I know that that's kind of a big metric for a lot of chains these days, and I think it is a good KPI to have, but my stance on sort of the interchain world is I think it's going to have more KPIs that are not TVL related, more about activity rather than liquidity being held in a certain place. Because if you look at how replicated security or interchain security, how they're kind of doing things, technically the TVL sits on the parent chain, but the consumer chains are just interacting with it in some way, and so the question then becomes, where is actually the TVL? And so, yeah, my stance on that is we're building for kind of a different world, one that's not necessarily just focused on TVL, but one that's more focused on activity and movement. But also, to answer your question on how we might sort of compete with Canto more directly, I think we actually want to work together. Like that's kind of more of our stance in general on like working with.
It's a very Cosmos stance.
Yeah. Well, I would say it's more of an Ethereum stance. I think Cosmos stance tends to be more factioned, or people tend to battle a bit more. But we kind of want to be more positive sum and try to work together towards something more cooperative.
Yeah. I think the bulk of the liquidity comes from institutions. And so maybe, Rebecca, I think you have experience dealing with institutions. How would you talk to them? How would you convince them to invest in Cosmos, market make in Cosmos, like do their regular Ethereum activities, but in Cosmos?
It's a great question, because I think ever since Bitcoin, honestly, and blockchain in general became a thing, let's say early 2010s, we've been going after this golden calf, if you will, of institutional buy-in, whether that is from large enterprises or from banking institutions. And Saga is my second crypto startup. My first crypto startup, I spent a lot of time selling to these kinds of institutions. And I think the lesson learned there, and what we really embody at Saga, is we want to make it as easy as possible for those institutions to ultimately build on blockchain. And so the stack has to be something that's palatable to them. And Cosmos has a lot to offer there. So if you get your own dedicated space, you can put controls on that space. If you want to, we encourage you not to, because the whole purpose of Web3 is openness and permissionlessness. But hey, if you want to start off sort of walking rather than running, that's an option in Cosmos. The interoperability is also another nice trait. And the access to other ecosystems, the fact that you're not closed off, is also something that's very attractive to these kinds of Web2 adopters, if you will. But the real lesson of the last few years is if you try to go after these sorts of institutions and enterprises head on, you are in for at least an 18-month sales cycle, which is a very long time in crypto. I mean, there'll be an entirely new stack for your ecosystem by then. So what do you want to do instead? You want to focus on winning at home. So you need to sell to a Web3 native audience first. Make your stack flexible enough such that you can sell to institutions, but be prepared to wait a very long time for them to adopt. And incidentally, when those institutions are finally seriously evaluating the options that they have for adoption or for a blockchain to pick, they are looking at overall traction in that particular ecosystem as well. The traction for them is a good signal of whether the technology there is robust, whether people who actually know something about this technology, i.e. people in Web3, trust this particular stack. And so focus on winning at home first. So I think for Cosmos, the technology is there. The technology is there. I think that if you want to make the sale to one of the institutions, you easily can get them to understand it, but to make sure that they are there to sign on the dotted line at the end of 18 months or 2 years, make sure that you win at home first.
Yeah, I think that's a great point. So I'm not obsessed with Canto, but for sure, like they had this initial adoption initially, and then from one day to the next, everyone was asking me about Canto, and I was telling them, check Evmos maybe, but everyone was obsessed about all these institutions. They wanted to talk about Canto, and it seemed like it's the right strategy to start with the community, the natives, and then they come. Sunny. So Zaki mentioned another blocker here is wallets. So how do we deal with that problem?
Make it so Osmosis can support MetaMask. This is something we've been working on. Like I think that when people, this kind of goes into the whole UX thing, right? Like if we want people coming in from Ethereum to start using Osmosis, the fact that you have to download a new wallet is such a big blocker. And making it so hey, how can you just use MetaMask with Osmosis? And then our take on wallets has always been to take this sort of T strategy where it's okay, let's support as many wallets as possible, but then make sure that we have the best integrations with one. So if you want the best possible experience, then you can use the one, best wallet for this use case. But let's support as many things as possible, reduce the overhead to onboarding as well. So as well with how do we get people who aren't even for Osmosis, our number one mission statement right now, I guess you could call it, is by the next bull cycle, we want to make it so that new crypto user onboarders can onboard onto Osmosis directly, not onto Coinbase. And so what are the things that we need to make that possible? You go to any Web2 app, the first thing you're supposed to do is not download a Chrome extension. And so I think we're actually trying to push towards how do we get towards wallet-less world where like, okay, you can start using Web 2 identities. We're working with like Lit protocol, which is this like MPC wallet solution to be able to enable a lot of that, using a lot of the cool Auth-Z tricks and stuff, really making it so like, minimize the onboarding path that users have to take.
Zaki, you have any other ideas for the wallet section?
No, but Saga, for instance, has been paying a lot of attention to the gaming market. I think it would be. I do think it's going to be critical for the success of Cosmos. I don't know if critical is the right word. I think it's an important path that needs to be explored. Is to like explore beyond financial applications.
So what, for instance?
I don't know. Ask Rebecca.
No, I appreciate that, Saki. Thank you. So Saga is, for those of you who don't know, Saga is a chain to launch chains. So we allow developers to automatically get onto their own dedicated chain. Anyone can benefit from this sort of infrastructure, but the reason why we decided to start with gaming and entertainment is this is where it is urgently needed. In gaming and entertainment, it is not about the financial return, it's about having fun. So you need a very high performance, controllable environment in which to deploy your game or your NFT project. And so to date, Saga has 130 projects building on us. We average about 55 projects per quarter. By the time we launch mainnet, Q3, Q4 of this year, we're looking at 300 new projects. And this is one of the major contributions that we hope to make to the Cosmos ecosystem, is that we bring all of this gaming and the NFT projects from other ecosystems, as well as birth new projects. Because you're right, Zaki, that when it comes to the daily active users who are using those wallets, holding assets in those wallets, really a huge part of it is that cultural piece in the NFTs and in the daily usage of those applications. So that's why we've decided to focus on these sectors.
Okay, I think we're good.
Sweet, thanks.
We just leave.
We got some seats here in the front for people. I see some people that lead BD teams in the front row here. So for everyone in the back that needs a job, you guys can join up here in the front. That would be nice. But I think this next conversation is a particularly interesting one coming after the Cosmos. And I think Akash from Evmos did a nice lead-in when he said he's not a TVL maxi. So if we think about how the first generation of blockchains were measured on success, it was largely market cap. And now we're all familiar with TVL being the main metric for us to measure a DeFi application. But when we think about the interchain and we talk about general message passing, what's going to be the metric that's going to lead this next generation? And we have the right people here to talk about it. We have leaders from Dave Balter at Flipside Crypto, Eric Ashdown from Covalent, and Mariana Angelou from Metrica, and Will Foxley from CoinDesk TV is going to lead this conversation. Let's give them a round of applause.
Awesome. Well, thanks for joining today. We might be talking about the most boring thing, data, but that's not real because data is tied to money. So really, you should be paying attention today because we got 3 guests up here who are going to tell you a lot about data and money and how it works and where this is all going in the next 2 years. TVL, that's everyone was talking about that in 2020. Total volume locked for DeFi applications. I remember in early 2020 when Compound and a few other DeFi protocols broke past 1 billion in total volume locked. That was a big deal for the DeFi community. Now, 3 years later, no one really cares about TVL that much. Why? Well, because there's a lot of broken metrics in crypto, including market cap, active addresses, TVL, the list goes on. So that's what our topic today is going to be about. First, we're going to start off talking about Interchain, though, and that's where everything in crypto is going. So we have to understand Interchain first before we can talk about metrics. We're going to start off talking about Interchain as a definition, however, because that itself is a little problematic. Mariana, we're going to start with you. Talk about Interchain and how you guys define it.
Yeah. So to my mind, interchain data is simply the manifestation of cross-chain communications, communication across different blockchains. So we've heard about this very popular use case today a bunch of times. You have token X and you want to move it from chain A to chain B. Now, how and where this data manifests itself depends on where you're standing on the interoperability stack. And so if you're on the application layer, this means exchange of messages, right? Whereas, we at Metrica, we have, historically at least, we have been more focused on the lower layers of the stack, which is, and I'll borrow a couple of terms that from Sergey's latest blog, we are mostly focused on the trust layer, the validation layer, and the transport layer. And so when I think about interchain data, I think about things such as validation of cross-chain events, routing, what else? The types of things that typically the application layer is unaware of, which means then exchange of messages. It's a bit of a bottom-up definition, I would say. I don't know if everyone agrees, and maybe a little bit skewed from because of my familiarity with Axelar, but yeah, this is kind of my take.
No, that's why we're defining things, right? Because everyone comes from a different position, and that informs how you do your metrics, and that informs the people who are using your protocol or your product itself. Eric, same question over to you. Let's define interchain before we toss over to Dave with the hotball question about what the hell is after TVL. Eric, first, interchain?
Yeah, interchain is, so I guess first we had multi-chain, which is, launch on chain A, move assets to chain B, et cetera, et cetera. And it seemed like everybody was fighting for attention, but now, as we discussed in the previous panel, there's application chains. What you're seeing is interchain is more launch here, move assets, everything is correlated, and everything it works with each other. Everything is interoperable on each other. A lot of the tools, a lot of the infrastructure. So when I think of interchain, I think it's more instead of looking at individual blockchains, it's looking at the whole ecosystem and seeing how all of these assets will play together across different protocols and different pieces of infrastructure.
Okay, love it. Dave, let's go to the question at hand. What's after TVL? What should everyone in this crowd, if you're trying to tell them what's next, what are we looking for a metric?
No pressure. Okay.
No pressure at all.
Well, let's first talk about the failure of TVL. We all got bought into this metric that was easy to game, and one that didn't teach us much about whether anything was actually healthy or behaving effectively within the ecosystem. So as people bought into it, they realized it didn't help us understand what we could do with a specific blockchain or protocol. Where we've sort of heading towards is what is a much more traditional worldview, which is what matters to most ecosystems, whether it's blockchain or whether it's Web 2 or anything else, are things like acquisition. So how many customers are joining a specific blockchain, retention, how long do they stick around, what do they do when they're there, and then traditional sort of behaviors of buying metrics. How many transactions are they running, how frequently are those transactions happening. So you're going to see, I think, two next phases. You are going to see some very blockchain-specific metrics that do matter. They're probably a little more niche, so MEV or P&L for liquidity providers. They're very sophisticated just for those things. But then you're going to see many more people start to focus on traditional metrics that have made many industries grow over the years. So think acquisition, retention, frequency of purchase. Those are the things that you're going to start seeing.
The 3 R's, reach, retention.
3 R's.
Reach, retention, revenue, yeah. I agree 100%.
Eric, let's keep going with you, because before we had this conversation on stage, we were sitting right over there talking about some charts that you put together, talking about TVL and going through TVL is not necessarily dead. We just need to think about it a little bit differently. We were talking about active addresses, which crypto, that obviously went through a very similar story arc, right? Where it was like active addresses with everything, and now it's absolutely nothing, and we don't want to talk about it, but everything has a little nuance in it, right? There's an asterisk on everything. So tell me about your perspective for this whole conversation.
I think TVL has always been a bad metric. I was looking at a bunch of blockchains. So we have a database. Covalent is a database. We have, I think, 75 plus blockchains now. And I broke them down. And there is one blockchain, which we'll name nameless, but has a market cap of almost $200 million and has less than 500 monthly active users. And by monthly active users, I mean have signed into their wallet and have sent something. So I did the math, and I'm like, let's break this down. So this means if you break down the market cap by each user, it means each user who is active on that chain is worth $165,000. Because they logged in once and did one activity, which was not receive, it was send something. And I'm like, this is a great metric in the fact that it proves how inefficient the market is. But it's just like we've gone a long way to go to find different metrics that we can compare. And I think this compares to on a protocol by protocol basis, right? Some blockchains have more interesting metrics than others. Like as another example, I looked at Moonbeam and I looked at Ronin. So like Moonbeam has almost 500,000. Moonbeam's, if you don't know, it's a Polkadot EVM. Has almost 500,000 monthly active users, but only 130,000 transactions over the course of the last 30 days. But then I looked at Ronin, has 130,000 active users and almost 500,000 transactions. So I'm like, what is the best metric? I think it depends. If you're looking at Ronin, Ronin is a game. Axie is pretty much the main thing on that chain. You would probably say monthly active users and probably amount of people who've signed their wallets or have done an activity, earned an NFT or something. If you're looking at Moonbeam, it's a multi-purpose blockchain, so who knows what it is, right? I think it's up to the dApps themselves and the blockchains to define what those metrics are, opposed to us as a community just looking and saying, well, TVL is the best one, because I think TVL is just a bad metric, as we've already seen with one chain where each person is $165,000 is not the real world. Doesn't mean any sign of adoption.
Marianne, I want to go to you in a second, but I want to ask a little more to get some more clarification here. I almost thought of Bitcoin when you were talking about a chain there that had no active users but had a high market cap, right? Because there's not necessarily a lot going on there in terms of people sending transactions back and forth, but it still has a high market cap.
Yep.
And you still have active addresses that you'd say have value. So when you're breaking things down a little bit more granularly, maybe it's with like some of these networks that obviously are kind of ghost towns, but maybe not. Maybe they do have some value and there's not a lot of people using it at this point. So how do you think about it when you get into more like nuanced conversation?
I think that's where you have to sit down, because I can share this chart. It was really interesting. We all looked at it. And ETH isn't even in the ballpark. Each active ETH address, I can't remember what it was. Like I don't have it in front of me, but it was something like $18,000 if you look at the TVL versus the amount of person who sent it. So that to me also seems outrageous, but we look at ETH very differently than we look at a lot of other things. So I don't have a good answer. I think it's subjective to the chain. And if a chain would look at this and say, you know, we only have 500 people, but we value each one of those 500 people, and we believe they're worth $200,000, and then that's a good metric for them. They would just have to justify that to everybody else, I think, is the realistic thing to do. Like there's a PR agency, and they said this. They said they had a client where the person wanted to be featured in a news journal that only had 50 readers monthly. And that's all they cared about. They're like, the one client just wanted to be featured in that one thing. And I think there's nothing wrong with that if you know what you want. That's what you're looking for.
Love that. It's a good story.
I just want to push on this a tiny bit, if I could. Any chain that has 500 users with a $200 million market cap
is inefficient. I'm not disagreeing.
Not inefficient. It's why Gensler is around.
Yeah.
Okay. That is not good for our industry. Like, we have to stop propping these things up. Focus on places where people are having real transactions, et cetera. Like that. Like, it's just not good.
Yeah.
Like, there are lots of reasons that's happening. They're not the reasons we're all here building. I hope that's not the reason.
Any thought on that, Mariana?
Not on the particular comment. I'm coming in from a slightly different angle, I think. TVL and market caps have never been, historically at least, a core metric of ours, and not just out of ignorance or arrogance, by no means, but just because I don't think they tell the whole story, right? So this is about interchain communications, right? And so if nothing else, what they do is they add one more dimension to the mix. And so can you use TVL to capture the nuances of the underlying protocols like Axelar or its competitors and the risks that this entail, right? So to me, I think there's not going to be one metric that will rule them all in the interchain age, but it will likely be a variety of metrics under the umbrella of seamless continuity of critical services. Again, my angle is operations here, right? So I think about things such as have the cross-chain transfers been successful? Have all the steps been taken in the process? Have there been any vulnerabilities? These are the types of things that I'm thinking about when we talk about interchain data. So maybe to give you a real-life example, if you go onto our platform or if you go onto Axelar Scan, and I'll go back to maybe the trust layer that we talked about before this morning. So you'll see their metrics in Axelar, but just to give a bit of context for those of you that might not be familiar with how it works. There's, you have the validators are running battle-tested delegated proof of stake, and they participate in this advanced multi-party cryptography protocols, right? And so, in this context, we track a variety of metrics to capture the success of the validation layer. And so, with that in mind, I don't think it's going to be one metric by no means, and I think it's more important to focus on reliability and quality of service in this new era rather than TVL and market caps. Yeah,
so I want to come back to you because the main thing at hand here, I think, is that like DeFi Pulse really captured people's imaginations with TVL, right? Like that's where everyone was checking in 2020, 2021. Is comp going up? Is the TVL going up, right? So that really captured, I don't want to say retail, but sort of retail's imagination. And I think the fear is the next cycle, similar thing happens, right? But it's a different metric that's just as misleading and just as abused by every project out there. Mm-hmm. So I kind of want to get like what you guys think it's going to be, and maybe like what you guys want it to be, if you for like fall on my tread there. Eric, it looks like
3 R's. 3 R's.
Reach, yeah, it's the 3 R's. It's reach, retention, revenue is what everybody should be looking at. Like those are the three fundamentals of business, and I think they'll play out in network dynamics as well. You're going to want to see people building real products that have real utility with real usage, driving real adoption, not things that are hacked together that have a shelf life because based on whatever APY is given out. Like I saw a DeFi protocol that, like with Ohm, what was Ohm's APY? What was it? It was something absolutely insane. Like the TVL they got because it was like 2,000% APY interest. I don't remember what it was. It was so ridiculous, but I was like, this is a bad metric, and this is not doomed. This is not going to end well at all for anybody. I think it's going to be up to each team who's building something, and it's got to be looking at it from a more Web 2 lens of fundamentals, adoption, and getting people to actually care and use your product, use your service, or fall in love with what you're doing. I think that's really it. Like I pulled this stat recently where there are actually more NFTs that have been minted than there are websites on the internet. That's a fact. This is a hard fact. There are more NFTs that exist than websites. Think about that. And so when I thought about that, I was like, how many graveyards? How many people, got into a mint and like thought everything was going to be the future and all these celebrity endorsements. And I'm like, they're all fly-by-night things that just battle test the technology but don't prove any of the long-term fundamentals that anything is viable. It's just quick ins and outs. So I think anybody that figures out anything that's long-term and viable is what we're really looking for, not for any of these metrics that can be gamed really quickly. Because like TVL can be gamed, Discord users can be gamed. Anything that can easily be gamed, it shouldn't be looked at as a good metric.
So maybe I know what you're pushing for here, so we'll do an attempt.
Thank you.
So take like Squid, which just launched. Squid maybe in here somewhere. Since Squid launched in January, 2,000 users, 1.2 million in transactions. Very factual and understanding of how many people are joining, what they're doing. Now you're going to want to watch how many of those users stick around. One metric you might drive is revenue per user, and see how that. That's a pretty obvious metric we probably all use in our businesses every day. So you watch how that variable changes. Can you get more revenue per user? Can you grow the user base faster? All those things will indicate whether that's going to be a viable project for the long term.
Any follow-up thoughts, Mariana?
I would say maybe success ratio of transactions, end-to-end finality. How long does it take for my transaction to go through? If we're talking about interchain solutions, what sort of chain coverage do you support? If I'm a developer, I want to be able to tap into the various chains and the various assets. This is kind of the...
No, that's great because that spurs a whole other point. And I'm just going to pass it right back to you. When we think of the interchain land, we're thinking of multiple different blockchains speaking to one another. And within those blockchains, there's bridges. Those bridges are vulnerabilities. There's lots of problems there, right? And then every chain has its different
consensus mechanism, has its different purpose, different engines, there's different developers working on it, there's different tokens. You guys have the thankless job of making all this data make sense to people, right? Whether users, investors, or in between, whoever's using your website to understand this data. How do you guys piece that together? How do you piece all these blockchains that are now speaking to each other into metrics that are useful? So for example, if I'm talking about Bitcoin trading between two different Bitcoin wallets, not a lot of velocity there. But if I put Bitcoin into Ethereum, a lot higher velocity, right? Because I'm probably aping a few things, moving around more. The average user's maybe not going to understand that. But how do you guys as data providers do that in a responsible way and show that off from a website front, from a product front, or maybe even from a metric front? Any takers on that? Eric, I'll throw it to you first.
I think it's contextual with how we build our stack. So when we look at a blockchain, we take all data. So every wallet, every state transition, every transaction, every NFT, and we put it in a database and we normalize the data. Our job or our goal is just to make it easy for people to access and extract that data and make useful whatever they want to do. So we're not in the business of building, we don't build UIs, we don't build anything, we're a read-only API. How we see this is how can we just, every time we hear of a crazy new use case, how do we optimize our APIs or our database to be able to solve for this use case? And that's really how we're looking at it. I think we've passed the point of it'll be one or two blockchains. I think it's I think that it'll be an omni-chain future. I think interoperability is obviously key, and it's going to happen. So it's like making sure that once the data's in there, it's normalized, standardized endpoints, and make it easy and accessible for people to do whatever they want with it.
I think I understand the question. I'll give you what I think is the answer. I think most developers, people who are trying to build using data, want specialized tables of some sort. So gold tables, making all the data consistent that they can use easily. I think the second most important thing is for those tables to be updated at the pace that chains evolve.
Yep.
And so the consistency is probably less about getting it right the first time and more about as the chains and the protocols adapt, being able to keep up with those. The last, probably the thing that's we're all is going to help all of us do what we do, is you're starting to see the marrying of cloud and blockchain data. So what's made some of what blockchain data very complex is piping it out and ETLing it, and maintaining it is very complex, costly, time-consuming, AWS, all that sort of stuff. All of our data is kept in Snowflake. We just made that publicly available so people can access it through Snowflake because of that capability to access that data at a pace and a quantity that allows people to do a lot more things with it. So I think you're going to see this cloud matching start to create the consistency people need.
Yeah. I'll add on to that. I would 100% agree. You're starting to see some of the larger players who have these sophisticated, they have processes, they have ways they need to get the data, they have places they need to manipulate and use the data, and you're starting to see a lot of these people start to creep into the space slowly. And they have data standards, and they have things that they need, and they have pipeline standards, they have uptime, they have SLAs. And so when you see them trying to figure out how to take all this Web3 data that exists and put it into these infrastructure pieces, I think that's sort of, exactly where it's going. Totally agree.
Yeah, I have a slightly different thought that's about correlation. So recently we have seen an increasing amount of high-quality data coming out of our space, and very sophisticated tools, analytical tools, right? So how do you make sense of the data? So a lot of what we think at Metrica, at least, is how do we correlate them to make it, useful to users, to investors, etc. So even in the early days of our platform, what we were thinking about is, so if I tell you a KPI that only sort of describes your infrastructure, right, your own individual setup, what does that mean? Unless you correlate that to what happens in the network, that's not useful, right? So if I'm not performing well, what does it mean? I need to compare myself to the network. So correlation matters. And so then the next level of that is correlating off-chain and on-chain data, right? An example of, there are all sorts of permutations of, off-chain and on-chain data combinations, but an example, again, from our platform is when we sort of leverage system-level metrics and correlate that to on-chain data. And then the next level after that is applying machine learning, intelligent tools to leverage your historical data to make predictions, to spot anomalies and patterns in your data.
Love it. Yeah, most data is off-chain, right? It's happening on Binance's order book. So let's go to the last question. We have about 6 minutes left. Dave, I'm going to start with you on this one, then we'll work our way back and give Mariana the last word for the session. Are data providers getting smarter, or are they following the herd? Because we have seen market cap, active addresses, TVL, and we often see data providers provide that, right? Because that's where the SEO juice is. You want people to use your platform. Doesn't necessarily mean that like these data providers are bringing like the best metrics to the table. So it's a little bit of a chicken and egg question, but I'll throw it over to you. Where are we at with that?
Yeah. I don't know if smarter is the right question. Like the fundamental issue with getting to blockchain data has been, in essence, pulling it off the chain, cleaning it, curating it, and making it available. All of that part of the sort of history is now sort of behind us. Almost any data provider worth their salt is capable of working with nodes, getting what they need, putting it to market. The smarter is actually in the hands of people who use that data. What do you use that to do? And so you have folks who might need an API to build products, and you have individuals in the community who need to understand the protocols that they're working with, and so they need insights built in real time. So it's more about, is the market able to ingest this information more cleanly? I think you're seeing data providers who sort of weren't able to exist in cleaning data from nodes sort of fall away, and the ones that sort of have figured out how to access what I would consider a relative commodity at this point and do something well with it for the market, they're just helping the market succeed more efficiently.
Eric?
Oh, that's such a good explanation. I'll see if I add on to that. Yeah, I think for us, I can speak for us specifically, for Covalent, it's more about you want to always catch narrative, because catching a bit of narrative will get you users, but at the same time, you have integrity with what narratives you capture, right? You don't want to be chasing things that you just don't believe in or things that don't add value, and sometimes it's more, when you're thinking of catching narrative, what are the things that are interesting and what can we actually expose? Right? More about speaking factually than taking opinions and just saying, here's the charts, this is factually what it is, make up your mind with what you want to do with this data. And that's how we look at it. But for the most part, it really is just empowering developers and empowering analysts and empowering people who need the data to build whatever they want, and then come back to us and say, hey, this is what I've got, this is what I've done with your data. And we say, that's cool.
Love it. Mariana?
Yeah, I think I really agree with your description. Yeah, it's how do you make your insights actionable, depending on the audience that you have. Yeah, and definitely our tools and our solutions are getting smarter and smarter. Yeah.
Awesome. Well, we actually have about 2 minutes left, so bonus question for me. Dave, it's coming to you because you smiled. Let's talk about off-chain data a little bit more. Mariana, you brought that up a second ago. Most data is off-chain, right? So how, as an on-chain data provider, someone who's looking mostly at on-chain data, do you make that available to people? And how do you synthesize that or correlate it, as Mariana put it?
Yeah. So, the first question is, what do you need your off-chain data to do with your on-chain data? So let's start at sort of the fundamentals. People need to understand what they're looking for. Taking something like snapshot data and integrating it into other on-chain data sets gives people an idea of what's happening with votes next to actual transactions. That's the type of stuff that that helps people do things. We don't do a lot with off-chain, but depends on what your use case is. Yeah.
I'm always more curious to see what people do when they take our on-chain data, because I've seen people try to write algorithms where they say, here's the on-chain data. If this happens, then this, then it will feed into an off-chain data pipeline or product that'll just say, okay, now we need to rewrite the smart contract. And I think that's where it's going. Because then you could see the on-chain events, and then you could recycle them to off-chain activities, which translate to more on-chain events. So we don't play that much in that world because it's just not our business. But it's interesting to see what happens when you sort of take our data products and then Oracle, and I've seen a lot of awesome hackathon projects that just this is what ends up coming out is a hybrid of both, where both are used.
Any final thoughts on that?
Yeah, I mean, I'll just reiterate, like, say you have a network incident, right? But you have actual real-time data from a bunch of your nodes that say that their memory usage spiked. Now you have something it's your solution, basically, right? It's the solution to the problem in real time. So I think that's very powerful, a very powerful tool, this correlation.
Love it. TVL is dead. Something else is coming along. We'll find out next bull market. Eric, Dave, Mariana, thank you so much.
Thank you. Thank you, guys.
All right, we have a 15-minute break, and then we will have Avery Ching, co-founder from Aptos, talking about what's on the roadmap for them in 2023. So everyone be back here at 3:15. Thanks. Sorry.
All right, ladies and gentlemen, if you would, please come on in, get your seats again. We're going to start in just a couple of minutes. Thank you very much. Ladies and gentlemen, please welcome back to the stage, James Friel.
Appreciate it. Please stop. So in 2022, I think we would all agree that one of the largest blockchain launches of the years was Aptos. And now as we look into 2023, I know that a lot of people in our community that we're talking to are interested to know what's next after launch. And we are lucky enough to have Avery Ching, co-founder and CTO from Aptos, presenting their roadmap for the next year. So let's give them a warm round of applause.
Thanks for that. Thanks, Avery. Thanks. Hi, I'm Avery. I'm co-founder and CTO at Aptos. These lights are extremely bright, so don't mind me if I start looking all around the place. It's great to meet all you folks here at ethdenver and Interop specifically. And I'm definitely excited about the multi-chain future here, and also what we've been doing at Aptos to help bring that about. So just a bit of background on us. My history is that I was a PhD in high-performance computing. I worked at places like Sandia and Los Alamos on some of the world's largest supercomputers, on solving problems like protein folding and matrix factorization, including things like safe nuclear simulation as well. I made my way to Meta in 2011 and worked there for 10 years in data infrastructure. And in 2018, there's a pretty ambitious initiative started off, an initiative called Libra. The idea was, how do you kind of build decentralized access to financial assets around the world? And kudos to Meta for actually jumpstarting that project and bring together a whole bunch of different experts across different disciplines: systems, high-performance computing, programming languages, cryptography, and many others, and then helping us to basically see what we thought was the next set of generation of ideas in this space. So when we started with this thesis in 2018, we thought about, what are the problems we want to solve? How do we get billions of people to use infrastructure such as blockchain and Web3? And we came kind of down to these 3 different areas that we felt were the most important to focus on. First off is that your developer experience should be intuitive. It should be easy, as easy as coding in, say, Java or Python or Rust, but with the safety and security that you would expect from a high assurance asset like a smart contract. We thought about instant would be important. We've seen how latency and user experiences can play a big part in terms of the adoption, in terms of people wanting to use it on a daily basis. And of course, things have to be very expensive. People are already used to very low-cost cloud computing infrastructure that exists in the world today, with services such as AWS, GCP, and Azure. So with these things in mind in 2018, we thought through a set of core design decisions that we thought would help us on our way. First off, we designed everything from scratch, which is the typical Facebook way of doing things. There was a new programming language being built. There was new blockchain infrastructure being built. And many of those lessons from DM, in that case, were brought into Aptos. It was something we forked off of in the past. Upgradability and configurability were super important to us. And the reason is because this space is so nascent and so early. Even all the blockchains put together today can't do what a single MySQL server can do in terms of throughput and latency. And it takes hundreds of thousands, if not millions, of those servers to power applications such as Facebook or Gmail or Search across the world. And so as an industry, we have so far to go in terms of before we kind of reach the full potential of our technology. And so we wanted to make sure that upgradability was first up in mind. Alongside my background in high-performance computing, another thought is, how do you take advantage of all the resources available to you for doing transaction processing? And that can include multiple CPUs, more memory, more disk space to you, and also in cluster-based technology. And so taking a new design approach in terms of something that would be pipeline and modular in order to exploit all the resources of the machines, as well as networking components and others, was something that we thought was really important. Along the way, we thought about learning lessons from what previous databases have done. Decentralized databases, another fancy word for blockchains. The key difference is that the first word is decentralized. Yet there are still some important things we can learn from those technologies. Things like optimistic concurrency control, which is a key important feature for how we think about things like block TSTM and parallel execution without having to impede the developer experience. And finally, as I mentioned, we have a long way to go in terms of the infrastructure scalability of our software stack. And so we're thinking about different ways in terms of we scale, both horizontally and vertically. So starting off with an intuitive experience. Some simple things here are like, how do you decouple public keys from addresses? That's a simple idea, but now allows you to do things like key rotation. So in case you don't have a situation where you think your key might be compromised, you can actually just rotate whenever you feel like that's an issue. We provide things like crypto agility, where we support EDDSA signature schemes. We also support BLS, multisig, and a whole host of other things that are very flexible and customizable to the user experience. And finally, we support also smart contract based recovery. So if you can imagine a world where you've lost access to your key, you could have a smart contract which, for instance, delegates the responsibility of key rotation to a custodian that you trust, whether it's a bank, whether it's a well-trusted internet provider. And you can have interesting models where things are like, I haven't transacted on chain for 6 months, and now I'm allowing that entity to actually do a key rotation on my behalf if I can prove my identity to them. But while I keep transacting periodically, they don't have the access to do that. And so it kind of provides these interesting semi-custodial hybrid models, which are not available in all networks today. The second thing we think that's really important is about how do we produce human-readable transaction outcomes. So in Aptos, whenever you're about to execute a transaction, the first thing that happens is that you will send that transaction typically from your wallet to a full node, and it happens automatically. By doing this, you can simulate the results of that transaction. And I have an example here in the coin and buying a broad bear, in terms of what the fees will be, the payloads, the write sets, the events that are going to be produced. All these things provide you very clear, strong clarity in terms of what the transaction is doing prior to signing it, not afterwards. Another area thing we think about is transaction viability. So once you sign a transaction, how long is it good for? How can you prove that transaction is not going to be used in the future or hold you hostage over what you've done in the past? And so things like sequence numbers as well as expiration times that can be set by the transaction allow the kind of guarantee that if I haven't seen the transaction committed to the chain before the sequence number has been passed or before the expiration time has been hit, I can guarantee that transaction will never be committed. And that's something that's really nice and makes you feel warm and fuzzy as a user. The final thing is many chains do offer like-kind proofs. We do too as well. One difference is that with a high-performance clock in the Aptos blockchain, we think that provides a very nice way to provide strong auditability of things that happen on the network. So you can know with sub-second granularity with respect to the commit times of different transactions and when they're executed. And this is we think is very helpful for users. Move is obviously something that we're really excited about. It was designed from scratch back at Meta as a smart contracts language. It's got all the things you would expect. It's deterministic. It's metered. And it also provides things around data being stored under user accounts, which is very nice. So thinking about the way some blockchains will keep that data in contracts makes it very hard for users to be able to access that data in different contracts going forward. And by keeping that within a contract, within the user account itself, it's easier for contracts to operate with that data in a much more seamless way. The other thing that's great about Move is it provides support for things like resource conservation and safety by having different kinds of attributes around what is allowed to be duplicated, what's allowed to be copied, what's allowed to be dropped, and when those operations can occur. That provides just a simpler way you can't shoot yourself in the foot so easily. When you think about operating with things like coins, you don't want to treat them as integers, for instance. You don't want to actually multiply them or divide them or do things that just are not natural for how you think about money and currency in that sense. And Move is still a new language. It's been around for 4 years, which is great. But we think that there's a huge amount of necessity for improving and evolving this language going forward. And so in 2023, we're taking this to the next dimension in terms of adding new features like higher or lower inline functions. We have this concept of resource groups, which is really exciting. The idea is that you have structures, and as a programmer, you can go ahead and figure out how do you want to organize these structures into storage space to optimize gas costs as well as execution times for your benefit for the application. And then our last thing we're working on that will come out this half is around Move objects. How do you kind of compose these different structures in a way where you can create kind of safe references between different things and create things like composable NFTs and dynamic NFTs in a very natural and scalable way. And I think I talked to this a little bit more, but upgradability is something that's really, really core to us. And we are very excited to say that our 1.2 release actually is just kind of gone live this month. In February, it comes with a whole host of new features, including new Move types, new 256. It comes with new crypto primitives and many, many more things. This is just 4 months after our launch back in October. We also were, to demonstrate this thesis of upgradability inside the kind of previous mainnets we had within Diem. And we can do this in a way which leverages on-chain governance, which is really neat. So a lot of blockchains will use kind of block heights or certain times in which they make the upgrades go live, which is kind of tried and true practice. But it's very hard to predict when you set these times in advance. If you're too early, you have to make sure the network has already upgraded past that point, because or else you're going to be in probably a fork. If you're too late, it's going to just take too long for the upgrade to happen. And so by leveraging on-chain governance, token holders can vote in terms of whether they want those upgrades to go live, and they can kind of come live instantly as soon as thresholds are hit, which is really cool. A key part of our design is really about this pipeline modularity, and I want to spend a little bit of time on this. We've broken the processing stages into 5 different unique stages. Each of them can be operated independently. Each of them is parallelizable. The first phase we call continuous transaction dissemination. Each validator will send blocks of transactions to other validators and produce what's called a proof of availability. This proof kind of ensures that these transactions will not be lost to the system. It's a stateful process. Second phase that happens is what we call block metadata ordering. So validators will agree on an ordering of these blocks of transactions, but you do not just set the transactions with them, nor do you do execution. And by decoupling consensus essentially from these two operations, both the dissemination and the execution, consensus is not a bottleneck. And it's extremely fast, basically sub-second. Just 2 round trips and things are committed. Next phase is what we call parallel execution. So once you kind of have this list of kind of committed blocks to your storage, you can execute those transactions. And then the interesting thing here is that the order of transactions that came in can be reordered as long as it's done deterministically. This allows us to optimize for as much parallelism as possible, as well as take advantage of other properties where you can, for instance, maybe even thwart some of the different MEV attempts out there in practice. And this is where block STM comes into the picture. The fourth stage is around batch storage. As you know, writing like 1 byte at a time to storage is extremely inefficient and very slow. If you write hundreds of bytes at the same shot, you get much better throughput, fewer seeks, all those fun things. And so we take advantage of that in our pipeline system as well. So as blocks are being executed, the results are being stored in memory and then synced to disk in one large operation. The final phase is what we call state-proof certification. And this is very decoupled from the process of execution, where nodes will eventually agree on the output of the execution results, and these can be used for like-client proofs in the future. But the great thing about this is that all these stages operate independently, and they're not blocked by each other. This allows us to get full utilization of the resources in every machine, or even clusters of machine if we want to scale out that way. Talking about block DSM a little bit, it's one of the key technologies to our system. So parallelism and how we express parallelism has been always an interesting construct in the blockchain world. Also, very interesting in the HPC world, we had things like MPI, and then we went to things like Hadoop and bulk synchronous processing models. That paradigm became very simplified and accessible for developers, but maybe had more constraints in terms of controls and what people could do with them. And so, in this case, we've taken the approach of we want to make easy things easy and hard things possible. Block STM allows developers to kind of program as naturally as they would with sequential models. But whenever there's parallelism, they get automatically extracted on behalf of the programmer. And this is very valuable because it's simpler to program. But the other thing is that sometimes when your programs are there, you can't know a priori exactly what the dependencies will be. And so in those cases, you have to kind of split transactions up into smaller sub-transactions, which makes for difficult recovery, very hard composability, and just a nightmare from a developer and user perspective. Block STM allows you to kind of maintain that parallelism, even in those cases, because it will extract it automatically on your behalf. And in terms of pessimistic parallelism, we can also support that as well. If you wanted to specify for some transactions, those dependencies up front, those can be annotated. Those will be annotated in the future and supported alongside this model. And they're very complementary, which is very nice. The great thing about this technique is it scales really well with respect to the amount of contention and resources available in the system. And that's kind of what our experimental results show. I would love to talk about the Aptos ecosystem a bit. We've been live since October, essentially, and we were very pleased to see that so many projects have started to build alongside Aptos with us over time. And so, within those first 4 months, we've seen more than 100 projects launch, 200 plus building in this place, thousands of NFT creators and collections. We were very excited about the fact that the Aptos repo and the Move repo has hundreds of developers and contributors to it already. And that's something that we don't take for granted. We think it's a very important part of how decentralization works. Having an open source community, having lots of developers contributing towards this and helping guide it in different directions. That makes sense. And we're also excited about many of the mainstream partners that are partnering alongside us because one of the things that we need in Web3 is this adoption of applications and usage, right? We haven't had that case yet where there's a killer app where you have a Facebook or you have a Snapchat or TikTok where you have daily hundreds of millions of daily active users, and we're waiting for that. And so, as we see these partners in the list, we're very excited about 4 different areas. One is going to be gaming, another is social, finance, and then kind of media, entertainment, and sports. And so each of these kind of groups is represented well, I think, from the set of parties here. And we're here to talk about timelines, so let's definitely get to that. So in 2022, there are a lot of things that happened for us. We formed the company officially kind of in January-ish, or December, I guess, of the previous year officially. We kind of announced the formation of the company in February, and 1 month later, we had launched our first DevNet. Our thesis was to understand exactly what people thought about Move and thought about the Aptos blockchain. And we're really delighted to see that people started to develop things and build smart contracts, as well as to onboard full nodes to the system. I think within a couple of weeks, we had more than 18,000 nodes connected to the blockchain, which would make it one of the largest networks available at that time. And then after that, we saw in May, we started to launch our first incentivized testnet. We wanted to get started with how we prepare for mainnet launch. That was with more than 100 nodes. In July, we started a second incentivized testnet. That was with staking properties, 200 plus nodes. And then August, we started our final incentivized testnet. And that was to support, again, our key features of governance and updates going forward. And then finally, in October, we made our launch, and we were very excited about that. Some of us, during that time, had thought about, whether we should, wait a little longer, go faster. And it was really our developer community that kind of inspired us to move as quickly as possible here, because we'd seen them building alongside with us, and we were really excited by the momentum. We wanted them to be able to launch their products. So within 1 week of launch, over 30 products had launched on the Aptos blockchain, and over, I guess, again, 100 plus today. So in February, we haven't been, this year we haven't been bored or idle. We've launched our first major upgrade of the network. That's 1.2. It's going live. It's been live basically already since late February. And we have a host of number of things coming up for the rest of the year. So the first thing I'd say is that on the developer side, we're super excited about things like move objects, as well as resource groups coming live very soon. They'll come in the first half of the year. We also put out a blog post very recently about our path to lowering gas fees. And there's a number of different efforts we have in that space. First of all, we have building different gas-efficient data structures that work well with our model. The second thing we're doing is separating out how storage and execution costs work together. So the idea is that execution costs are very transient, storage costs are kind of long-lived and more permanent. And how do we make sure that when the network is not heavily utilized and there's definitely sufficient capacity that the execution cost is basically free until the point at which you hit the kind of throughput limits, which are very high. We also are bringing in terms of new features, which is storage refunds and billing accounts. This will allow the ability for developers to take advantage of these new features in ways that can provide users with a better experience. So for instance, if you're building a DEX or you're building an empty marketplace, you can have things like gasless transaction fees because there'll be another party paying it on your behalf. And also if you're building a DEX and you're putting out limit orders or things like that are temporal in nature, once those orders are done, you can kind of clean those up and kind of recoup the storage fees, especially if they've been only there for short periods of time. We think that that's going to be really, really interesting, and we're excited to see what our partners are going to do with that feature. We also have a quorum store coming out in the first half of the year. Quorum store is interesting technology which takes full advantage of the data dissemination techniques I mentioned earlier and the proof availability. What we've seen in practice is that for situations where bandwidth becomes constrained, especially, there can be anywhere from 2 to 5x gains in terms of transaction throughput, and even better latency as well. You should also expect to see more advanced cryptography, developer tooling, and also we'll put out prototypes around sharding developments going forward in the future. The other thing I want to note is that we feel in this industry we'd love to see more openness and transparency around performance evaluation and benchmarks. Our plan is to start to publish benchmarks that are going to be some simple things in the beginning, account creation, how you think about NFT generation, P2P transfers, things that are very repeatable though, and things that other chains can also do. We will intend to launch these experiments in a way that supports people to understand how the network will perform for your different use cases, and also in repeatable experiments. Something you can set up yourself on a cluster and also run the same things and verify independently. We're just running out of time, so I just want to run through this really quickly. We would love to have the community participate in what we call Aptos improvement protocols. Those are basically analogs to what Ethereum does. And we've already seen several community proposals that we're really excited about, including things like delegation and also other improvements to the object protocol from many others in the space, and we're excited. You can also add yourself to the list of ecosystem projects if you're building in the space, or also check out what's going on in Aptos. And there's a whole bunch of just handles for Twitter and developers and all that fun stuff. And with that, I think I'm almost perfectly on time. So I just want to thank you very much for taking the time to listen to me. And we're really excited about what's going on with Interop here and how we can be a part of the multi-chain future. So thank you.
Everybody can check out the Aptos team is actually going to be running a workshop following Avery's conversation. So if you're interested in learning how to actually build on Move, go check out the hacker stage. Keep an eye on the schedule. Avery's team will be leading a great workshop. Get you started. For our next conversation, we're going to have Sergey, who you guys are all familiar with, and Circle, their VP of product, Joao Reginato, talking about composable USDC. I'm sure a good deal of people, if you guys know Axelar, are pretty familiar with composable USDC. CCTP, the cross-chain transfer protocol that Circle released and announced back at their Converge conference. A lot is going to be able to be built when it comes to interchain connectivity as a result of this. So this should be a great conversation. So let's give them a big round of applause.
Awesome. So thank you, everybody, for joining us on the panel. Joao, great to have you as well. Do you want to give a quick intro? Maybe tell folks what you guys do and what's your main role at Circle?
Sure. Joao Reginato. I work on the product team. I've been with Circle for almost 8 years this year. And I have been working on the topic of stablecoins since its inception. For those who don't know, Circle is the issuer of USDC, the largest dollar stablecoin on the Ethereum blockchain. I led the build out of USDC back in 2017 and 18, and today I lead what we call the stablecoins product team, which is the largest team we have in the company right now, because circa 2019 or 20, when we started to observe what was happening with USDC, Circle really pivoted the entire company into dollar and stablecoins, and more broadly stablecoins as a way to achieve the vision that we have had. And it's been super exciting working on that flavor since then.
Makes sense. So I guess I'm kind of curious, just to begin, how do you see the role of USDC in a multi-chain ecosystem, right? You know, we have lots of different chains. You guys are available on some, maybe not on others. Tell us a little bit more. How do you see the role of USDC, and like how do you see the expanding ecosystem?
Yeah, sure. I think we zoom out, and this has happened, many years ago, and it is what actually led Circle to build USDC back in 2017. We are one of we are from the generation of companies in crypto that believes that this technology is just objectively better than the prior infrastructure for financial services that we have had available to us, and so we are vested into making this this entire ecosystem the next substrate for financial services, right? But we started building a lot of products, particularly in Circle's initial incarnation, a lot of retail products, and then we built stuff on top of Bitcoin. We actually looked into Ethereum and building settlement tokens and that kind of strategy, and eventually we realized internally that actually what we needed was this idea that the dollar as a currency, and obviously you can then propagate this concept over to other currencies, but primarily the dollar, right, the reserve currency of the world, so important in crypto even back in 2017. The dollar as a currency should run on blockchain, right? That's a belief that we have, and I think a lot of people share that belief. But not only that, then because of all the benefits of blockchain as a new substrate for financial services, and the programmability and composability of it, everything can look and feel a little bit more like a protocol, right? That's available for developers to build so much innovation on top of that. We have come up with this refinement of our mission then, which was to build a protocol for dollars on the internet, and that is the role that we think when we think about USDC. I think just as back in the day, people eventually figured that Bitcoin, you had to talk about Bitcoin with a capital B and Bitcoin with a lowercase b, because these currencies they have this dual role of being a bearer asset that people can hold and transact, but they actually behave as a protocol, right? That's how we see USDC as well. USDC is a bearer asset that some segment of entities, of users will actually hold and transact, and then they will know what they're holding. But it behaves like a protocol. So it behaves for any developer who is building financial services applications or any type of application that touches the dollar as a capability, that USDC could be this layer that they build on top of, and then maybe at a user experience layer, people don't even know that that's what they're touching, right?
Right. So how many chains is USDC on today?
Yeah, so we started this journey back in 2019 when we issued USDC on the second chain. So we started by launching USDC on Ethereum. Back then, it was the obvious choice, and it's still Ethereum represents over 90% of the activity and the volume and the traction that we see for USDC. But we have then issued USDC starting on Algorand in 2019. So we have had this kind of multi-chain perspective or chain agnosticism perspective since then. We have now issued USDC on 8 blockchains up until now. So aside from Ethereum, USDC is present on, let me make sure that I don't miss any, Solana, Avalanche, Stellar, Algorand, Flow, and Hedera. And we will continue to do that because, as I said, it's part of the belief that we have. Obviously, we are big believers of the EVM and all the traction that it has
and all the innovation that it has created. But we also think there are always interesting things happening in all these ecosystems. We have announced back in Q3 or end of Q3, beginning of Q4 last year that we're also bringing USDC to 5 more chains that we're actively working on. Those being Optimism and Arbitrum, Near, Statement on Polkadot, and we're bringing USDC to Cosmos as well. So that should be coming out in the next couple of months.
Nice. And so I guess a question for the audience. Most of you have used USDC, right? Raise your hands. How many people have used a USDC or B USDC or any wrapped version of USDC? Okay, so some folks. And you guys are doing something to help people deal with all these wrapped versions of USDC, and you're trying to create a sort of more canonical representation, right, that can be traveled around through this protocol CCTP. So could you tell us a little bit more about it, and what's the objective there?
Yeah, we're super excited about this. It's also something that we have been working on for a good number of months, and hopefully we're close to bringing it to market now. When folks like you guys, Axelar, but this entire sector, right, started to become more prominent, I think, at some point at the end of 2021, right? And we started seeing all these, what we call internally, we call them synthetic versions of USDC versus, the native versions of USDC, the versions that we actually mint and burn directly on chain. We started seeing the proliferation of bridging as a sector, as I said, and then on the back of that, all the creation of all these synthetic versions of USDC. And we started monitoring that a lot and started to ask ourselves, right, how should we think about this? How should we approach this? I think in general we were very happy that was happening, right? Because I joke around with our team, we're going to be the slowest entity ever to bring USDC to a chain, right? Because of the baggage that USDC carries with the management of the reserves, the auditing that happens, almost on a weekly basis, and so bringing USDC to a brand new blockchain, it's a big deal. It's a big undertaking for us. So we always joke that we are slow, and then if we see synthetic versions of USDC running ahead and proving certain ecosystems, it actually makes our life easier, right, in terms of paying attention to ecosystem A versus B. But then at the same time, we started seeing what you mentioned, right? We started seeing AUSDC and BUSDC and XUSDC, all these variations of USDC, and those are all, in general, they're all path dependent, right? So depending on where you're coming from to bridge USDC from chain A to chain B, you're going to end up with a synthetic version of USDC that's not going to be compatible with another one that comes from a different path. I know you guys work a lot on this topic. And then we got, I think, to situations where on USDC on Solana, for example, there was one particular app that was listing 11 versions of USDC on a dropdown. And I remember that day because at that point we said, hey, this is getting a bit ridiculous. Come on, we want this to be a good experience for users, for developers. But if you have 11 versions of this thing on an ecosystem, it's going to be something else, but it's definitely not going to be easy, right? And then we thought about the role that we could play, and the trust model for an asset like USDC that has exogenous and centralized collateral is already one where people fundamentally have to trust Circle, right? And some people, granted, they might like that more or less than others, but it is the model, right? And it's a model that we believe that has good trade-offs and good compromises. And if you are trusting this external entity, which in this case is Circle, to kind of hold the reserves for the asset, then maybe bridging USDC could actually work a little bit different than the majority of crypto assets, right? Because we, as an entity, we actually have the power, if we wanted to destroy USDC on a source chain and recreate it on the destination chain, and really kind of bypass some of the challenges that are involved in this space. You know better than me the challenges. So we started working on I think the concept of CCTP, which stands for Cross-Chain Transfer Protocol, in Q1 of 2022. And we started conceptualizing how that could look like. And eventually we got to a design that we got all of our teams comfortable internally. To be honest, we were concerned at the time, that we didn't see ourselves competing in the space. That wasn't going to be our intention. And we were concerned, when we were going to reach out to folks like Axelar and others, how they were going to react to that. But I have to say the reaction has been super positive. I think people understand how this is going to be a good thing for the ecosystem to allow for a digital dollar with exogenous collateral to be moved more efficiently across chains. And so the idea of CCTP is that it is this kind of very base layer component that only Circle can build, because we are the only ones who can mint and burn USDC. And then on top of that, we can continue to have the user experiences that you guys have built and others.
That makes sense. So I got to ask this question. So, in the Axelar white paper, the cross-chain protocol is called CTP. You guys came up with CCTP. What happened there?
I can assure you that was mentioned internally, and the alternative was between CTP, CCTP, and CCP, which doesn't sound well. Somebody Googled and said there was something else already labeled like that. So yeah, honestly, it was fun to come up with the name. As I said, we don't envision this being a retail product, right? So there's no CCP is not going to have, just to be clear, it doesn't have a front end, right? It's not supposed for people like you and me to go on a website and kind of bridge USDC in that way. It is a protocol, so it has smart contracts on chain, it has APIs, but it's geared towards folks like yourselves and developers in general accessing it. So the name, CCTP is not a great brand, but it also doesn't matter. It's more of a developer product anyway.
Makes sense. And so, we're collaborating with you guys on this kind of notion of composable USDC, right? And kind of helping augment the CCTP stack with the rest of Axelar infrastructure to really make the developer experience easier, right? Building in this multi-chain and cross-chain. Yeah, can you talk a little bit about that and what are some of the use cases you're excited about when we combine kind of a general message passing, relay all the infrastructure that Axelar brings in with a protocol like CCTP in one?
Yeah, we're super excited about that. I think also what led us into this space was the fact that I think Circle and USDC, we sit around a lot of tables and we feel the responsibility for the role that we play. For example, right, you guys might have seen last year, we had a ton of, some people call it Web 2, but I just call it more traditional financial services players, right? So we had Stripe, for example, integrating USDC and doing mass payouts for their marketplace products based on USDC. We have MoneyGram utilizing USDC as part of their infrastructure for remittances. So we feel the responsibility of achieving, I think, what we all want, which is, as I said, eventually blockchain and crypto in general becomes the substrate for a lot of financial services applications. And what we started noticing then on the back of this evolution of USDC across many chains, fragmentation of liquidity, is that people would come to us and they would ask, and usually it was like technical development teams when they were asking the question, which chain should we use? Which version of USDC should we use on this or that chain? And how should we think about things from a programming capability point of view if we wanted to change our decision later in the future, or if we wanted to migrate these things from one ecosystem to another. And we started realizing that there was a big gap for more traditional development teams coming from these types of companies. And so when we started building CCTP, we actually had as an intention, right, as I mentioned, this has to be a developer-centered product. And the idea is that developers should not worry too much. Obviously picking a chain for the application that they're developing is a super important decision, but we wanted to make sure that it was just as any other technical decision, right, that you make, and it is like a double door kind of decision. If you want to undo it, if you want to go back and change it, it's not a big deal. And so we are particularly excited, I think, with the collaboration that we do with you guys, because you guys have what I would probably risk saying the best developer kind of suite, in that sector of thinking about omni-chain or multi-chain. And so we are super excited as Axelar considers kind of reusing or utilizing CCTP as part of your construct, because I think for developer teams, particularly for these more traditional developer teams that we have been entertaining, I think for them, then the answer is going to be much more robust. We're going to say, well, here's how USDC can be bridged. Here's a company like Axelar with their suite of products. You just go for it. You have everything you need in there. I think the pitch will be super robust after that.
Yeah, no, that makes sense. And I think the one thing that I'm excited about is that a lot of developers, so today they use like the wrapped version of Axelar USDC, right, like to actually build their applications. And so as it becomes available, you can instantiate, with no changes to your application, effectively utilize CCTP and have just more economically friendlier and better outcomes for your users, right? So the example application like Squid we talked about earlier, today throughout the day, it kind of does like, it uses USDC as a routing asset, right, to compose DEXs across chains, but it has an extra swap, whereas always Axelar USDC is sort of swapped for the native USDC and then swapped for the native asset. And so that leads to some type of slippage for the users, right? And so as this protocol becomes more available, developers don't have to make any changes. They can just automatically start leveraging kind of more capital efficient and better, better liquidity properties for the users. So I'm super excited about it.
Exactly. Yeah, that's how we want people to. I think everybody would agree, right? That's how we want developers to start thinking about things, right? At the end of the day, as I said, if you're building a financial service equivalent in DeFi, right, there's no reason why you shouldn't try to benefit from multiple ecosystems today. There's EVM compatibility. There's a lot of options with different trade-offs. So for people to have the dollar running on all this infrastructure and being able to super easily not have to worry about that complexity and just focus on the complexity that pertains to their use cases, I think that's hopefully the vision that we have is that once this is out there in the market, and it's going to take a while, we are going to come to market first with a connection between USDC on Ethereum and USDC on Avalanche, and then we have to literally deploy these smart contracts on all the blockchains where we support USDC. So this will take a little bit of time in terms of a rolling kind of deployment, but at that stage, USDC will be really the best option for developers if they need $1 on their applications.
Yeah, no, that makes sense. And not sure how much you can kind of comment on this, but there's been increased regulatory activity right around stable coins. Anybody here from SEC or government? Raise your hands. No. But yeah, kind of curious, right? And I think you guys had kind of a technology stack that's been the most sort of compliant, at least from my perspective, right? That actually try to do things maybe slower in some cases, but the right way. Curious, what's your in general kind of a position, right? What's your hopes as regulators come in, as people talk about, Stablecoin Transparency Act and things like that? Do you think it's helpful, not helpful? Kind of, what's your general view on it?
No, I think it is helpful and it is extremely necessary, right? I think particularly in the U.S., I think there's been progress. Actually, last year was so complicated that it was hard to separate all the noise from a few good signals that we have seen. But I think actually you begin to see good shoots of progress coming from a regulatory perspective in actually other jurisdictions, right? I think Europe has MiCA, which has some interesting things in how it thinks about stablecoins. Singapore is doing good work. The UK, I think it's going to come up with legislation, but it's also the model in that they are discussing seems extremely positive. And then it feels like unfortunately, we walked a little bit backwards in the U.S., right? There was all this conversation around potentially a stablecoin bill coming out, and I think we were close to that. And then I think we, as an ecosystem, even though most of us didn't have responsibility for that, but we kind of screwed up, right? Because there was, I think Nick Carter spoke about this when I was talking to him once. He said, we have to stop pretending we're doing software engineering when we're actually doing financial engineering. And financial engineering, deserves like a particular place. Let's innovate on the software on the technical side, but there's not a lot of opportunity for innovation on the financial side. And I think unfortunately that happened, and that happened with certain stablecoins that we all know I don't need to name, and that set us back. But I think we're still optimistic that in the U.S., which is such an important legislator and regulator in the collective of all the three-letter agencies that it has, I'm still optimistic that we will see actual legislation in this space, and people will say, here's what a stablecoin is, here are the the trade-offs if you want to build one, here are the types of companies that should think about operating in that space. We need that clarity, and we're still optimistic that it will come.
Awesome, that makes sense. I know we only have 20 seconds, but what are you most excited about for 2023?
For 2023, I think we have been talking about this vision that fiat currencies like the dollar, especially, which is the biggest focus that we have. The concept that we have had, I think, over the last decade, right? That you have substrates, you have blockchains, layer 1s, layer 2s, perhaps layer 3s, right? And then you have obviously all the native assets, but you have fiat currencies that are beginning to kind of run on them, like USDC as an example. I think we will see the collapsing of those two concepts a little bit more, and people will just, as I said, will just realize that the dollar runs on this infrastructure, and it's not. I don't think it's going to happen only to the dollar, obviously. So a few of the things that I think we are super excited is about. Honestly, I think the advancement in scaling, with Ethereum and with the EVM in general, I think that will be like a good coalition in 2023. And then I think the number of these regional currencies that we see being issued now around the world, I think we will see also like a new kind of evolution in that space. And as I said, we are expecting a lot of liquidity to come into these fiat currencies running on these blockchains. I think interoperability across all of them is going to be easier. Things like CCP will help, and hopefully we'll be in a position in the next 18 months where developers really they can build financial services which are much better with a much better infrastructure based on this technology. That's kind of the hope and the work that we're doing as well to get to them.
Awesome. Well, super excited, and well, thank you for joining us today.
Thanks for having me.
Thanks, everyone.
I think there are a couple of key things that we need to develop in order to get that next stage. Reliable, properly collateralized stablecoins is certainly one of them. Another one is privacy. I think transparency and privacy were two of the tenets of what blockchain was supposed to deliver. We've certainly delivered on the transparency part. Privacy, not quite yet. But development in this space has been incredible over the last couple years. So now it's a question of when is that actually going to be executed and deployed and widely adopted? When and how is that going to take place? And we have some founders from some of those leading projects that are leading the way to come talk about it. So we have Zuko Wilcox coming from Zcash and Electric Coin Co. We have Howard Wu, the CTO from Aleo, Elena Nadolinsky, CEO from Ironfish, and Guy Ziskin, the CEO from Secret Labs. This session will be moderated by Red Sheehan from Masari. Let's give him a warm welcome.
Yeah.
Thank you.
Thank you. Hey, how's it going? All right. Oh, there's a lot of lights. Thank you.
All right, welcome everybody. We're going to jump right into this with Guy, and we're going to ask, what is the difference between pseudonymous and anonymous? How is that relevant in crypto?
Oh, pseudonymous is like, I guess, being half pregnant or something. So pseudonymous means that there's some ID, like a hash or like your public address, but there's still linkability, right? So like if you have a crypto wallet and you're sending a bunch of transactions, then everyone can see the trace, right? That's like how Bitcoin, Ethereum, most wallets operate, and it's fairly well understood at this point that pseudonymity does not really give you like proper privacy.
Gotcha. And following that, Howard, is opt-in privacy enough, or do we need privacy by default since everything is not, built in, it's not anonymous off the bat?
I think there needs to be universes where both exist, but I think what's missing in the ecosystem today is this private by default concept. When you look at how technologies tend to evolve, they tend to start with public by default because it's the easier solution, but people quickly come to realize the shortcomings of that. And I think that in crypto especially, where financial transactions can easily be kind of tracked in ways that may be nefarious or in ways that you may not want to, in order to protect your privacy, I think having the option of private by default it's paramount, or it's critical. I'll also say it's much easier to go from private to public than from public to private. You can't really take back what you say once you've put it out there. And so I do think there's a universe for this. I think that they're very complementary in the space especially.
Yeah, I hear you. And considering we have public transactions, private transactions, and all of these aspects interacting with each other in the same environment. What does that look like when they mesh? Zuko?
That's a good question. So privacy and transparency are both necessary features for different use cases, right? Like, so I've been working in privacy all along with Zcash and also before that. So I think about privacy all the time. But transparency is really, really useful for a lot of things. For example, if some organization or application is custodying other people's funds, it would be ideal if they had to give real-time, fine-grained visibility into exactly what they're doing with it to the public at all times. And fortunately enough, that's what transparent blockchains are great at, right? So the same person for two different use cases is going to want privacy for some of it and transparency for some of it. And you ask something like, how do they interact? There's a there's a widespread simplified notion, like if you take a private thing and you use it along with something that's disclosing your information, then what do you get? And the natural assumption is you get a not private thing out of that, right? And that makes sense, but it depends on the specifics. So I have a bunch of Zcash on my phone, right? And anybody who comes up to me afterwards, I'll put Zcash on your phone. And it's in the Zcash shielded pool. And if I were to send 10 of these coins like through a bridge to a transparent blockchain, so I get like an ERC20 token that is redeemable for shielded Zcash, then my 10 shielded Zcash have exited the private world and they've entered the transparent world, right? And then if I do something with it on this transparent blockchain, like buy an NFT or whatever people do on Ethereum nowadays, now what information is visible to whom from that? So everyone can tell that 10 Zcash came out of the shielded world and bought an NFT. But there's no information on the blockchain that links that back to my identity, my phone, my other assets, my other transactions, my net worth, or anything else, right? So that's a case where you have a transparent thing and you combine it with a public thing and you still retain privacy over all that information. Well, what's public is the fact that this NFT sold for exactly 10 ZEC at that moment. So anyway, it's nuanced, and I think as people experiment with it more and like as services that show you all the public information get more and more commodified and presented to end users, then people will start developing better intuitions about the interplay between privacy and transparency.
Yeah, I think that shows that pseudonymous is enough in some situations.
I don't know if I call it pseudonymous. I don't know. I mean, that was a good answer, but
yeah, debate over whether the transactions are linked together, but they're not linked to anyone.
Yeah. So in that scenario, I bought this NFT. So now everyone in the world can tell that this NFT got bought for 10 Zcash at that moment, right? But there's zero. The zero and zero knowledge proofs is for how much extra information gets leaked. So there's zero extra information, such as there's no. I'll show you this in person after this if you want. if you look at it on the Block Explorer, there's no address. There's no from address, right?
Yeah.
So it's not like I have a Bitcoin style address that I'm hoping to keep unlinked with other information. There's actually no address there. There's zero information there about the source of the funds. Does that make sense?
Yeah. Okay, I hear that. That does separate the difference a bit. So we do have other ecosystem participants other than people buying NFTs. So Elena, I want to know, what does it look like to you in terms of who is choosing to participate in private ecosystems, whether that be node operators, users of any other type?
Yeah, so our goal at Ironfish was to make it really easy to run a full node. We kind of take the stance that privacy really matters, and people should be able to run full nodes very easily. So for Ironfish, you can run a full node right now with npm install -ironfish. So we made it really easy. And we're just ended our testnet 3, and we had 60,000 nodes online, which was pretty awesome. And again, like the reason why we had that amount is because we made it really easy for people to actually download and run the node. And what we've seen is, if you make it so accessible, then anyone can be a node operator. And we've seen people literally around the world, mostly non-US, actually run a node in mine. But going back to Zuko's point, because I think it's really interesting, because we've been thinking about this a lot at Ironfish, like where privacy matters, and how do we make something that's both practical and pragmatic and useful, but still like private. And so the way we thought about it, which I don't know, is kind of parallel to what you said, is the base layer is private always, not even by default. There's no optionality. And if we do computation in the future, the computation will be public. So again, for things like buying NFT, it's actually useful to know that information. In fact, people want to know, NFT price discovery or who owns what or what the actual history was. But people obviously don't want that to be linked to their identity. When we talked to other people in the ecosystem, they kind of had the same answer of, I want to buy an NFT, but I don't want to go to a conference and everyone know that I have like millions and millions of dollars worth of NFTs in my publicly accessible wallet that's potentially linked to my Twitter account. So there's kind of a difference between like what should be private and what should be public. And our stance is that the base layer should always be private, computation layer not necessarily so.
Awesome, I hear that. With the ecosystem growing in those directions, Howard, where do you think it's going to go next as we make privacy a little bit more available for some other things? And that could be healthcare or other industries that aren't yet in crypto, or that could be extending what we already have.
I think specialization is definitely one of the key next steps, but I think in order to even get to specialization, like one area that we're really missing on is the accessibility of the technology, and that's both in software and in hardware. I think that right now we're kind of just at this cusp where a lot of new like elliptic curves are being standardized or being used. Certainly a lot of new proof systems, a lot of new cryptographic techniques, a lot of new hardware approaches are also being taken, and these things have yet to kind of really transcend. But I think that as they do transcend, people are going to specialize that type of software or hardware into specific areas. I think in terms of DeFi, that's an area that's already slowly starting to manifest. I think certainly within the gaming space, people are starting to see the value. With roll-ups now, people are also taking this and using it in general purpose manners as well, and you're seeing the rise of kind of the ZK EVM approaches that are taken. I think that these end up creating different categories for, existing applications on the web as well as new ones. And to give you kind of more concretely, like today, for example, I think one of the big elephants in the room is that very few people use crypto on a day-to-day basis to spend. And the challenge with that is that they fail to see the privacy implications of cryptocurrencies because of that. Like, if say Venmo had the option to be like completely like open in the sense that like once I've sent money to you once, that I can just see your account for the rest of the time, the same way that say your Ethereum wallet would work, I think people would be less hesitant, or would be more hesitant to use that because they would say, "Oh, I sent you money once. Now I see when you go to the grocery store and buy stuff. Now I see how much money you make. Now I see how much balance you have." And I think that these privacy technologies need to kind of take a step further in terms of just actually getting their way into day-to-day use. Because the minute you do that, I think is the minute that the consumer starts to appreciate it. And I just don't think we're there yet. And a huge part of that is that the software and hardware hasn't kind of manifested into the hands of the average Joe yet. We're getting there, but I think it takes time.
Yeah, Zuko, do you think the average user knows the degree that their information is public, and do you think they're educated about kind of the pitfalls of everything being out there? And if not, what could we do to push it towards that?
People definitely don't understand the nuances. Like, what people don't understand is how computers can put two and two together, and they like have radar vision, and they can see you in fine detail just by picking up a whole bunch of different data sets, which to a human would look just like baffling, but to a computer that's like X-ray vision into your whole life. So people don't understand yet how computers have that superpower from different sources of information, but they do already very much, I think, have a concern about being exploited or what's the word, like monitored, which I think is accurate for them to have that concern. A few years ago, there's this widespread meme that people don't care about privacy. And I believed it at the time. There were all these newspaper articles and these reputable newspapers and whatever, and scientific studies that were funded by Google and Facebook that proved that people didn't care about privacy. And I believed it. I was like, damn, this sucks. People don't care about privacy. And then later I realized, no, wait a minute. They just pulled one over on me. Real people actually do care about that.
Yeah, so we know it's not really a niche interest. Elena, how do you think we drive the adoption then? If it's not a niche interest, if people want it, what are the first ways we're going to give it to them?
Yeah, I mean, I think that's a pretty good segue to everything else that people have said. You know, if we are going to say, okay, crypto is going to be the next payment layer, having it be so transparent is just like a non-starter. Like, how do you get financial institutions to actually adopt crypto when their entire like budget sheet and like order books are private? Again, like you are at high risk of being phished or scammed or just targeted if all of your information is public. But it's kind of a dystopian world if everything's public and, you know, kind of like what Howard was saying, like an attacker potentially know like exactly which coffee shop you're going to, exactly when you're out of town, and so on. So I think privacy is actually the end result of crypto. Like, we're not going to see crypto actually get to mainstream adoption without privacy, just because of like very, very pragmatic reasons. And what Zuko was saying as well, like people do care about privacy. Maybe like they say they don't, and then you kind of pry a little bit further, and it's like, well, you know, do you want your ex to see all the things they're doing? Like, okay, I don't want that. And then you kind of pry a little bit further, and you're like, okay, actually, everyone cares about privacy. It's just, I think privacy kind of has this connotation that people take now that's kind of incorrect. But all these arguments that I kind of mentioned are also like one of the arguments that we're using with regulators as well, right? Like consumer protection goes hand in hand with privacy. And right now, crypto is inherently unsafe for people to use without privacy preserving technologies.
Yeah, it's
Howard, do you want to jump in on that?
Yeah, if I could just add one thing. I think everyone in this room actually intrinsically understands privacy, but I think the problem when we're thinking about it from digital privacy is that we're thinking about it from the wrong frame of context. We're thinking about it like defense as opposed to offense. It's more about protection than it is about a feature. And to give you an example, it's like when you walk into a restaurant, the restaurant doesn't sell you on the fact that they have booths and that when you go into the bathroom there's toilet stalls. Like it's almost assumed you're going to have some space next to the guy sitting next to you or next to the person on the next stall, right? Like it's assumed that those things are there because you wouldn't go to that restaurant if they weren't there. And like the problem is that when you're on the web, you take for granted today, especially in Web 2, that the server is doing that job of protecting you. But the problem is in Web 3, you don't have this server protecting you anymore. You're just left with like just openness now, and like everyone can see everything. And I think that for some applications you do need that. Like sometimes it's important to be out in the open about some things, but as every one of us knows, I feel like we also recognize that some things need some level of granularity and privacy, and some things need to be fully private. And to kind of take the word privacy out of the picture altogether, like when you think about playing a game of like Battleship online with someone else, it's like it's assumed you're not going to see their board, and that like privacy is not like it's, you know, Battleship isn't selling themselves on, oh, we have privacy, like you know, here's you can't see your opponent's ship. It's like it's an intrinsic part of the game. And I think one of the problems is that we think about privacy as this defensive thing that's like data protection, ownership, which is important, don't get me wrong, but I think that what we aren't thinking about is what can I do with it, because of the fact that you can create these new experiences where you can actually give people a really tailored shopping experience just for you, because only you have that information, that model that represents you, and you can deliver a taste to them that's for you, and no one else sees it. But like, you know, these types of conversations, I feel like just we haven't reached a level where everyone can kind of take for granted that this is a thing, and we've gotten really used to the Web 2 paradigm where that server that learns everything about you actually kind of protects you by creating this illusion of a wall for you. I think in Web 3 we're getting there now.
Yeah, we are absolutely taking a lot for granted there.
Guy, I was going to ask, we know ZKPs are one of our solutions for this. What else do we have in the space that can help us get there? But if you had anything to add on to Howard's there, jump in there first.
Yeah, so actually I want to add on his last point. That's exactly it. Look, we all agree here that privacy is a basic human right. It's important. I could not agree more with Zuko and the privacy is normal narrative. Like we should be on the offensive, not the defensive. But I also agree with Howard's point is that privacy, to me, privacy equals functionality. There's literally so many applications that you just cannot do, especially in Web3 today, because you don't have privacy. Battleships is an example. Poker is another example. If I see your hand, your cards, there is no game. Pretty much any game where there is some kind of like hidden state falls into that. We launched a movie fully on chain with Kevin Smith, for example, as an NFT, and each NFT had this like personalized content and the actual movie, or at least the key to the movie, which was like in IPFS, right? The only way this worked, the only way this gave you kind of like the experience of this like a decentralized Netflix or a mini version of it, if you will, that is completely decentralized, was because no one could see that content unless they actually minted the NFT, got the key to unlock it. So it's really more of a functionality thing. Another thing that we're seeing is around security, right? Imagine that you have a smart contract that can keep a private state. I mean, that's literally what Secret does. Like, it gives you smart contracts, and you can hide, like, private data in it. So imagine you can hide, like, a private key in it, right? So suddenly you can start thinking about things like almost like non-custodian solutions where you authenticate to the smart contract, and then that smart contract is signing on your behalf. Or maybe that contract has like half of the key, and you have like your own hardware wallet, and that smart contract has like a policy saying, you cannot spend more than like 1 ETH a day, because if you do, then likely, someone hacked like your wallet or something like that. So it's an even added security layer. And I think that the whole discussion about how privacy is important, but people need to realize that there is so much more to privacy than just like, protecting our data in the most simple sense.
Yeah, I hear that. So we know where we need to get. I do want to ask a question if anything is going to stop us in getting there. So Zuko, Alex Pertsev is still in jail after his work on Tornado Cash. Are regulations something that is on the top of the mind when building privacy protocols?
I don't think we yet know why Alex Pertsev is in jail. They've not yet revealed any charges. And apparently the Dutch legal system is terrible that you can keep someone in jail for, 110 days or something at this point without charging them. So far, my lesson is don't live in the Netherlands. The other Tornado Cash developers, one of whom was in the United States, aren't in jail. I mean, I don't have an opinion on it until, aside from that it's a terrible legal, that you should have a right to a speedy trial. Aside from that, I don't know yet what, if anything, he's charged with. Okay. I don't know if that's the answer you were looking for. No, that's all I know.
Moving past Tornado Cash and looking at regulation in general, is that something that is heavily on the mind with, we're seeing exchanges and other entities we think we can trust going down, and that might bring more regulation on the space in general, everywhere across the board?
For sure,
privacy is
stablecoins and centralized exchanges, I guess, are the biggest focuses of regulators for good reason currently.
And staking, apparently. For some reason, staking is bad.
All right, so I'm going to bring it back to you, Guy, and back to the question we had before about, we know what we're trying to solve in privacy right now. We know we're taking things for granted, and we need to actually realize these things that people are expecting. How do we get there? What technologies can we use other than zero-knowledge proofs? What do we have at our disposal?
So yeah, zero-knowledge proofs are amazing, just to be clear. I use them a lot, and I love them. But just like in blockchains, right, with digital signatures, hash functions, proof of work, then proof of stake, consensus algorithms. With privacy too, you have a stack, you have a tool chain. And I feel that right now the discussion is somewhere like around like blockchain 2015, where like blockchain can do everything. It can make me coffee in the morning. It can do my laundry. It's all that. And like if you want to get past to like a more productive space of a discussion, then we need to realize that privacy technologies are a range. And there's obviously zero knowledge proofs, which are great definitely for scalability, definitely for a lot of things that you can kind of, let's say if you have your own data and you want to prove something on it and you can run the computation yourself, zero knowledge proofs are probably amazing. But I think the problem usually gets more complicated when you have multiple users, which is in many cases the case with blockchains, and you have multiple sources of data that you need to bring together and do something with them. That's usually called the secure computation or MPC problem, if people are aware. But the gist of it is that you gotta now combine data from different people. So you can't just have like each person like prove a statement on their data separately. You gotta do it together. A great example is a sealed bid auction. If you wanna have a sealed bid auction contract where the bids stay private even after the execution ended and you only reveal the top bid, then you need some other tool. And those tools, there's really only 3 tools. There's a trusted execution environment, which is most of what Secret uses today. This is basically assisted hardware, where it's basically, let's say, it's very similar to your ledger device or like your Trezor, like a hardware wallet. So it's more expensive, it's more general than that. On every processor, you have this like region in the processor, in memory, where even if you own the machine, even if you have root access, you can't really probe into what's going on there. And you can kind of simulate and like running computations over encrypted data, and then you can have users from different sources kind of bring the data to that place and run the computation. It has its like fair of challenges, side channel attacks and all that. Then there's multi-party computation, which is a form of cryptography. And then there's FHE, which is actually what I'm mostly excited about today. That's, for those who don't know, that's fully homomorphic encryption. And that's really kind of like the holy grail. It's this idea where you can just encrypt the data, and you can send it to some server, and then that server can just obliviously run all computations over that encrypted data without ever seeing anything. It's like magic.
Yeah.
Yeah.
Guy, if we're using some of these strategies that you just mentioned here, Elena, I want to ask, what are the difficulties in implementing some of those? I mean, what are the struggles with ZKPs and other privacy strategies in processing these transactions?
Yeah, so I want to kind of bring it back to like the space as a whole of like why I got here. Firstly, like crypto is probably one of the most welcoming spaces in the industry like ever, and then privacy within that has been like a really great community as well. And I really do truly believe that the fact that we have so many projects working on privacy in different ways is such a good thing. And like obviously we have a great representation in this panel today of different projects attacking in different ways. And it's kind of like Darwinism in a way, but it's also like really great because we have so many like minds attacking the problem, and and we have like allies again to make these arguments of why privacy is good. And so, you know, obviously we have Zcash, who, you know, has been kind of a leader in new like cryptography tools and ZKPs that everyone in the field has actually benefited greatly from. There's us, we're trying to be more of a privacy layer and like interact with other chains. I think Aleo is great because again, like they're doing private computations for the web, and there's other projects too, like Aztec and Espresso systems and whatnot. And again, every single project actually attacks privacy in such a totally different way. That again, it kind of depends on the use case that a person is looking for. And as we like develop in the industry, I think like people are going to gravitate towards one or the other. But in terms of use, like one example that I use quite a bit is Tornado Cash. Like before it was sanctioned, it was the #1 used privacy protocol like that we have seen, at least for Ethereum. In terms of TVL, in terms of usage, it actually had the metrics, despite the fact that it wasn't perfect, it was flawed, maybe the privacy wasn't quite there, But one thing it has done really well was just ease of use. Like you go on the website, there's like one button to like withdraw, one button to deposit, and that worked really well. And so I think that should be a lesson to all of us that usability trumps almost everything. If you don't build your product accessible, then people don't use it, regardless of like your kind of philosophy about what's the best privacy mechanism or what the future should hold.
Yeah, thank you. Howard, question for you. What does the state of hardware acceleration look like with all these computationally intensive solutions we're trying to implement?
It is mad, to be completely upfront. People are going at ZK hardware like crazily right now. I've heard and seen, and also even on our network, recently it's been at like 100 billion proofs per second on our network, and there's across something like 50,000 provers, and so and that's just people who are doing proving, like not node operators, not client nodes, not developers. And at least we surveyed some of the top 50 of those provers, and they're all running pretty industrialized operations at this point. Mostly GPUs, FPGAs, starting to contemplate ASICs now. I think that right now there's a mass realization that this technology can achieve a lot if we have the dedicated hardware to speed things up. And so I anticipate at least over the next year or two, there's going to be quite a bit of ramp up on that front. I think this is going to benefit not just a network like Axelar, but frankly every L1 and L2 out there. Everything from the roll-up discussions over to the interop discussions to use it to prove it in ZK. I think also in terms of off-chain scaling, there's also a lot of opportunities, off-chain privacy as well. And so these are things that I kind of see at the forefront. We're right at that tipping point, and it's a very exciting thing to watch.
Yeah, we'll have to see how that hardware evolves. And Zuko, I'd like to ask, do you think there is any chance of this environmental factor coming back into play with hardware? That is this going to be like ETH proof of work mining or something like that when it picks up and when we see this adoption?
What's the question? I don't get it.
With ZK hardware being used more for different networks, do we think this is going to have some detrimental environmental aspect of we're running all this hardware, we're doing all this extensive computation, and it's using a lot of electricity?
I don't know. I had never thought of that before. I imagine ZK hardware as being like, I buy a new iPhone and it comes with a ZK circuit built into the CPU so that everything works fast. And I guess that would also be efficient. So it would be the opposite of wasting.
Yeah, we'd definitely love to have it at the point of something closer to a light client there. Now, earlier, Elena, you mentioned something of a dystopia. I want to ask if some of these tools aren't built, do you think it's going to be CBDCs for everything, and do you think that is going to hurt the crypto space?
Yeah, I mean, I had a conversation with a friend of mine of like, what is the Dark Mirror episode of like China wins, we have CBDCs, and they surveil everything. Because that's kind of like the world we're heading towards, which is pretty unfortunate. And that's for two reasons. One, there's like a resistance to privacy. And two, the U.S. government is actively pushing companies to go offshore, which is pretty unfortunate in terms of launching, in terms of developing even, and there's like actual stats to back that. So all of that is like the dark future of what happens if we don't fight for privacy, because that's actually the path we're headed on.
Yeah, we want to keep it in-house and keep building. Thank you all for coming and speaking on this panel, and thank you all in the crowd for coming and listening to us. That's all we have for this talk.
Cool.
All right. We now have an Interchain speedrunning competition where the winner gets one of these sick jackets. I heard that. Yep. I like these jackets too. So let's give them a second to set up. But I believe they're setting up beer and wine in the other room. We encourage you to grab a beer, enjoy this, watch people who have actually built on Axelar race against each other in a competition. This should be very fun. It's going to be led by Stephen Fluen, our head of developer relations. Let's give them a quick round of applause as they come up here.
Ladies and gentlemen, there is also beer in the back of the room here that you are in.
Sorry about that.
You don't even have to go to the other room.
I was wrong.
Thanks, man. Appreciate you doing this. Are you going to join us at Meow Wolf on tomorrow night? Meow. Got a closing party for Interop. Come. I'll be there tonight. Looks pretty cool. Really? Yeah, tonight. Not at Meow Wolf, but dinner. Oh, you're coming? Excellent. All right. I'll see you there. Yeah. Let's chat. Axelar updates. James. I don't think we actually really got the red. Yeah. I'll see you there. Yeah, man. Dude, it's not kid right? Pretty. Dude, I knew that. I walked by you real quick. I was like, exactly the same thing. And I hit up, like, I looked at my kid, and I hit up such a talk with Joel. Are you in this space? Yeah.
We're about to do something a little bit crazy. Can everybody handle this? I know it's been a long day, lots of fantastic content, but I want to bring out the esports in everyone here. Sports go sports. We're doing something that I call developer speedrunning. So this is a very, very unique format. This is a very, very different type of content than you're going to be used to. And so I'm going to appreciate all of your support of this fun activity. Yeah. All right, yeah. Come, feel free, take seats, come relax. This is really supposed to be fun. So you've been watching a lot of content over the last day or so that's very prepared. Speakers have been practicing. Speakers have been preparing. This is not practiced. This is intentionally an impromptu challenge. So my name is Stephen Flynn. I'm head of developer relations at Axelar. And one of my big missions is this concept of developer speedrunning. And essentially at the heart of it, developer speedrunning tries to take this concept that you have in video games, where a lot of people play video games, right? How many people play video games? Couple people. How many people watch people play video games online? Let's plays, all sorts of speedrunning, all those sorts of things. So this is a thing that keeps getting bigger and bigger. There's events like Summer Games Done Quick or Awesome Games Done Quick, where they're raising millions of dollars for charity just by playing video games in a competitive way. And one of the things that they do as part of speedrunning is they're trying to complete a task, a game, as quickly as possible. And so there's these exhibitions where they actually put people head-to-head against each other. And so we're taking that from the gaming world and we're bringing it into the software engineering world, which sounds a little bit weird. So the reason we do this, I want to bring the excitement and semi-competition of like esports to developers. But at the same time, this is fundamentally a learning environment, right? I want everyone here to benefit and learn. And by watching these two folks actually try to build something, have a challenge, think on the fly, they're going to be given a challenge. And they're going to say, I don't know how to do that. Let me think it through. And we're going to be able to learn and collaborate together. And so hopefully here, this is actually a learning environment for everyone here. And hopefully we're inspiring you to be able to do these sorts of things yourself. All right, let's talk about the format. So each contestant has smart contract development tools of their own choice. That might be Hardhat, that might be Remix, that might be public GitHub repositories. Whatever tools they have, that's how they normally develop smart contracts. And we're going to let them use all those tools now. In a moment, I'm going to reveal a challenge that they've never seen before. And effectively, the first one to complete wins. And if we don't actually have time, if we only get halfway through, if no one ever completes the challenge, we'll judge them based on who got further, who made, I don't know, the more impressive proof of concept, whatever. So I'll be commentating, and in a second, we'll actually be putting up their screens so you can see them developing live. But this definitely has an uncertain outcome. We don't actually know. And so we'll see if we get through one challenge, we'll see if we get through 2 challenges, and we'll go from there. Has anyone tried typing in front of someone else, like at the office? Like someone peeking over your shoulder? That's hard, right? So these 2 gentlemen have a whole room of people peeking over their shoulder, watching them every typo. And so just know, we are all humans. They are going to make mistakes. This is intentionally designed as a challenge they've never seen before. This is not rehearsed. This is not in practice. This is impromptu. And I want everyone to be supportive. So let's start off with a giant round of applause for our 2 participants. All right, that was conference talk applause. I want to hear like sports stadium applause. Let's think your favorite sports team. There we go. That is the energy that we are looking for today. All right, so I'm actually going to dive in now to the challenges. So I'll reveal the challenge, and then we'll see if we can get this beautiful split screen setup that we've Medusa'd together here with multiple capture cards, laptops connected, and we'll go from there. All right, we're diving into the challenge. This is actually challenge number 1, I think. No, I've messed it up already. All right, challenge number 1. You ready? Actually, before we do this, let's give the participants a chance to introduce themselves. So on my right here, we have Gerd.
Hey, my name is Gerd. I'm part of the Squid team, and I'm co-founding Squid, and I'm also Solidity engineer from Sydney, Australia.
All right, let's give it up for Gerd. And on my left, we've got Johnson. Do you want to introduce yourself?
Yeah, I'm Johnson, and I'm a contributor to open source projects and a random builder.
So the idea was we brought together 2 community members. These are people that are part of the Interop community to show off, to explore, to learn, to fail live in front of you. And so we need all of your support. All right, so we're going to go into challenge number 1. So I call this challenge breeding NFTs. So if you've ever heard of CryptoKitties, think CryptoKitties. But your challenge is you need to deploy an NFT to at least 2 chains. And then anytime you have 2 NFTs that exist on different chains, they're able to mate with each other and create a brand new NFT. So I'll repeat that one more time. So we're creating these breeding NFTs where an NFT, when combined with another on a different chain, you can think of this as maybe 2 genders coming together to make a baby. Those NFTs can then produce a new NFT.
Interesting.
Does the challenge make sense? So theoretically, you're going to have to deploy a couple NFTs. They're going to need to be able to communicate. And whenever they get a message that says, hey, I'm from this other chain, let's make a baby. Questions?
So do you have to have like 2 NFTs minted? Like you have to have like 2 inputs for the hybrids.
So you need at least 2 NFTs on different chains.
Well, that's understood. But I mean, when you do like a marry-up, so you can send a message from one contract to the other, but how do you like, what's the requirement of like merging those 2?
You can merge them however you want. You can combine the names. You can do nothing. It's totally up to you. The idea is just 2 NFTs coming together to create a new NFT.
Okay, cool.
All right. Any questions?
I'll probably ask some questions later.
Yeah. As we said, they're going to fail, and we're all going to help them, right? One more round of applause.
Yeah, I definitely fail. Yeah. So.
All right. So let's go. So what I'm going to do here now is we have this fantastic dual screen setup. Can you see their screens? All right. So let's do a test for the audience here. Whose screen is this? All right. And whose screen is this? Perfect. All right, so let's take a look at what they've got here already. So it looks like Johnson has started pulling out the ERC 721. He's got an example contract here where he's pulling out what does it actually look like to have an ERC 721. And Gerd has already started on the Axelar executable side. So he's combined he's created a contract NFT ERC 721 of Axelar executable.
Like that.
So again, this is just like real development. You can pull code from the internet. You're going to use libraries. You're going to use interfaces, all these sorts of different things. And so right now, Gerd is trying to construct an ERC 721. One of the things that I think any developer who's ever done anything with Interchain knows is there's like 17 gotchas every time before you get something to work. And so we're going to kind of watch them live, and we'll learn from this experience. All right, let's jump back to Johnson here.
Wait, what? Okay. Yeah.
If you can't see the screen, if it's too small for you, Johnson has resorted to ChatGPT or OpenAI ChatGPT, asking how to build an Interchain NFT.
Means wait. Okay.
Let's go back to the split screen here. And again, like some NFTs are entire classes where you can mint as many NFTs as you want. You can do that, but really here, we just need at least 2 NFTs. So one on chain A, one on chain B, and those can be any chains. And we can even talk about whether or not that's local or testnet. It doesn't really matter. We're just showcasing the skill set and the challenge here. What are you thinking about, Gerd?
Well, I'm just trying to work out how to hybrid them.
How to what?
How to combine them, or at least in terms of like metadata.
Okay, how to combine the ERC 721 with the Axelar executable?
No, that's not the challenge. I mean.
Okay.
Deploy.
So both of these contestants, as you implement a new NFT, those NFTs will need to know about the Axelar gateway in order to send a message, assuming they choose to use Axelar, of course.
First, try to ask this, and then try to.
All right, and so Johnson has up the Axelar local dev environment. So if you've never used the Axelar local dev environment, basically what it does is it spins up a local version of 5 different blockchains, all using Ganache from a command line. So you check out the repo, you run npm run start, and then it spins up 5 different blockchains for you, each with their own Ganache, and then it gives you all of the kind of middleware necessary to simulate Axelar transfers across all these different blockchains. So if we take a look at what Johnson is doing here, he's using those EVM examples in the Axelar examples repo, and he's trying out the NFT linker. I think the NFT linker might be more complicated than you need.
Okay, I try to adjust this code.
Okay, you want to use it as a starting point? Absolutely.
Yeah, starting point, I guess.
NFT linking is fundamentally kind of a more complicated concept that has maybe some features that we don't need, like being able to mint cross-chain and burn on one chain. We don't need to burn either of the parents just to make children. This is not like praying mantis contracts.
Also, okay, I see.
So, in essence, maybe start with shipping an NFT.
Okay.
That then you can add in the Axelar executable to, so they can send and receive messages.
Yes,
would be one option.
Oh. Okay.
Let's check over at the questionable choice that Gerd has made, which is GitHub with light mode on.
Ah, come on, that's a new profile. I just want to hide my my real profile.
All right, so Gerd's got the Axelar examples up, same as Johnson. Has anyone seen an example of like this concept of breedable NFTs? Is that out there? Has that been done before?
Yes.
And in an interchain mechanism?
Probably not.
Probably not. Okay, so this is a first here. We're building a brand new, never before seen type of NFT. All right. Gerd is deep into the ERC 721 safe mint, which I believe is coming from the Open Zeppelin interface.
Yeah, I'm just trying to.
So if you've never used the Open Zeppelin contracts, they are absolutely amazing. You can basically import ERC 721, ERC 20, and in very, very few lines of code, you can ship an NFT, you can ship an ERC 20 token. All you have to do is basically extend their constructor. I'm very curious. On Gerd's screen, it says 3 authors have created this contract, which is kind of amazing that he does the work of 3 developers all by himself.
I don't know. Yes, template contract.
So I will recommend, you don't need to take the name and the symbol as constructors. You can just hard code those.
Well, but then I don't know how the name, so.
Yeah, there's lots of things that in examples like these you can just hard code and you don't need to take as constructors. Obviously, more rigorous coding, more production ready coding will take in all these things as parameters, but that's not actually a requirement.
Wait, how do you?
Name?
Is there any way to read the NFT deployed on the other chain, read the information about it? Because I think like it need to be shared information, right?
So the question was, is there any way to read information about an NFT on another chain? And there's not really any way to have that information. All of the interchain communication that I'm aware of, including Axelar, is push. And so what you would have to do is maybe one of the NFTs is able to initiate a breeding. And so it just says, hey, contract ABC, I'm going to call your breed method, and I'm going to pass my payload to you that just says, here's my name. And then the receiving one, NFT is able to just say, okay, I've received a payload, I'm going to mint a new NFT based on that.
So you mint the NFT, but I guess like basically there are 2 NFTs, right? We need to check the owner of these 2. I'm just thinking aloud, right?
I wouldn't even worry about the owner if you don't want to, because theoretically, if you have 2 dogs, you have 2 pets, they can breed even if they're not owned by the same owner. It happens.
So even if you are not owner of these 2 NFTs, you can still mate them?
Yep. If anyone calls,
I see.
Like I would build an NFT that if anyone calls the breed function or the mate function, just mint a new NFT.
Mint a new NFT on a chain that is specified.
Yep. So the way that my mental model works about breedable NFTs, and curious about the audience's ideas as well, is that you have an NFT. It's able to. It has a breed method that takes in some destination NFT. It passes that message cross chain and calls the breed method on the destination chain, and then it mints a new one if it has a payload.
I see. So you do need to be the owner of one of the NFT.
I do not worry about ownership for this example.
Okay.
Theoretically, if you wanted crazy bonus points that aren't really relevant here, you could make it so that you had to own the NFT on both chains, kind of like a NFT birth control, but that is not part of our requirements here.
I see.
All right, let's jump back to Gerd. So Gerd's got a constructor that's taking the gateway, or the gateway, as the case might be, and the gas service.
Yeah. So why is it complaining? So it says
mint.
It only takes 1 XP. Okay.
Destination address method of sender and don't check.
There's lots of different tools that they can be using right now. They can be using Open Zeppelin contracts like this ERC 721 standard, where, as you can see in his constructor, he basically just calls ERC 721, and he passes in the name of the NFT and a symbol. And then he's also passing in this Axelar executable, so he's calling both constructors on both of the inherited contracts or interfaces.
Yeah, I think that's
Adding a name parameter here, so that you can, when you construct it, you can actually give it your NFT a name, which is not a hard requirement, but welcome. And it's very interesting how each of them kind of chose their starting points. They both got up the call contract code, so they have an example of how one smart contract can call another. They both have up the ERC 721 sample code. So they're both seeing how to combine both of these contracts. Gerd is already making his code more flexible by throwing in some parameters into the constructor.
No, I just want to make sure I can deploy 2 contracts. Token identity. Okay, now this one.
Encode the gateway call contract. And call
Gerd has a mint method that actually takes in a token ID. This is absolutely one way you can do it. We can just hard code and specify that token ID ahead of time. Another option, if folks haven't seen it, is that OpenZeppelin actually has a contract wizard, where if you ask it for an ERC 721 contract, you can check the box that says auto increment, and then it will give you the code that creates a counter and auto increments the token ID of every NFT that you mint. So both of these are just fine ways of doing things.
What should be the
What's failing?
Oh, it's string.
Unexpected.
And Gerd's getting a very weird module error that token.sol can't find token.json. I have no idea what that is.
Good question. There's probably some clutter somewhere. No, this one maybe.
So this is a very standard part of the development loop. Is you write your smart contract code and you hit execute and you see what happens. And then you do it again and again and again until you get what you're expecting.
So
all right, let's go ahead and check back in on Johnson over here. How's it going, Johnson?
Not very good. I mean, it's like, I'm just thinking, right? It's like, okay, I first get some string over, get some string as the first step. So yeah, finish the string, and then that string would control that'll control like, I guess, yeah. What do I need on the destination chain to verify? Or
for the purpose of this exercise, you don't need to verify anything.
I just need to mint.
Just mint a new. I mean, theoretically, the only contracts that are going to exist that are going to try and trigger breeding of these NFTs is your contract. And so for now, don't worry about verification. If you receive a message, if you receive instructions from the source chain to breed, go ahead and go do it.
Okay, and then need some randomness.
And so, for example, you just wrote decode to get which two tokens to merge. Don't even worry about that. Just keep it simple.
Okay.
If someone calls execute, if you get that interchain execution, assume that it's a valid breeding event, and just go ahead and mint a new chain, mint a new NFT
weird
then.
shit's going on here.
Okay.
Gerd, how's it going?
There's some.
You got some hard hat shenanigans going on?
Yes.
Token ID.
This one.
You in.
There's some validation going on in some of the tasks. Okay, now we go.
All right. So by commenting out all of his code, it compiled perfectly.
Yeah, no, I'm just all the test scripts. Okay, now we go. Okay, so
I don't know. I mean,
now we can say function.
Wait, how do I decode? Wait, what's the way to decode? Actually, yeah, I'm thinking. What's the way to decode?
All right. It looks like Johnson's back at ChatGPT.
Ah, damn shit. Yeah. Hold on. Decode. Guys.
I'm curious to see if ChatGPT is better at teaching method signatures than just Googling. This looks pretty amazing. How many people have used ChatGPT to build something? Okay. We've got a lot of AI folks over there. I mean, he's done it. He's got an ABI decode method in his execute that takes in 2 integers. But I will say, don't worry about the actual payload. I would say just get an NFT that's capable of minting.
Okay.
Based on because one of the nice things is when you implement that execute method, that's not actually the method that's being called by the Axelar gateway. What's actually happening behind the scenes in a Axelar executable is the gateway is calling an execute method and passing in all of the signatures from the validators. And so what your execute method is doing that you're actually inheriting from the Axelar gateway or the Axelar executable is a verification of those signatures that then if those signatures are valid, it passes and executes the internal function called _execute. And so by the time you've gotten to the _execute, you can actually know for truth that the network has achieved consensus and pass that consensus and execute it on the destination blockchain.
Okay.
Yeah, this is not an easy challenge.
Okay.
And I don't want to stress our friendly participants out, but I believe we have about 10 minutes left.
Well, no, don't worry. That's just
So the clock is ticking, and again, if we don't finish, that's totally fine. That's wonderful. We'll judge them. We'll probably use a round of applause, and we'll see who got further based on the round of applause. So Gerd's got a declaration error. Identifier not found or untrue.
Probably misspelling this one, yeah.
And I'll give you the same advice, Gerd, that don't worry too much about the formality of ensuring that the contracts are owned by the right people.
No, I'm not.
Or that the methods are being executed. Right? If you have an execute method that is an internal method, that will be enough. So Gerd's got a mint method called from within his execute, and so if a internal or a Axelar network payload is delivered, he'll actually get the source chain and the source address, and then he's going to mint it to that source address. And he's casting the string source address into an address, so you can use it in the mint method.
Still complaining because it's call data. Okay.
See, and now you're getting into some of the worst parts of Solidity, which is what on earth is call data? Call data doesn't allocate any new memory. It uses the memory that was previously allocated for a function call. And so he's having trouble converting from that call data.
Well, here we go. GPT chat.
Are you using Copilot?
Yeah, it's Copilot.
So if we look at our two participants here, Johnson's using ChatGPT AI to code, and Gerd is using Copilot.
This is different. Like
clearly, AI is the future, and all of our jobs are totally at risk.
That's probably not correct.
All right, let's jump back to the side by side.
Let's jump back to the example.
What does this mean?
Sorry, are you stuck on the signature of mint and how to get from a string call data address?
I'm just trying that.
Gerd, would it make it simpler if I said that you can be the owner of all of the newly bred NFTs? You can be the NFT pound, where all of the stray NFTs end up.
Yeah, in fact, it's the same message that's going to send to the contract, to the gateway, which is not.
Yeah, it would be better to mint it as owned to the source address, but if it saves you time or energy, we can just hard code a specified owner of all the NFTs.
This is.
All right, Johnson, how's it going over here?
This test framework I'm not familiar, and I guess like
gonna do this something.
I'll just try to test like how.
Are you still in the NFT linker source code as the sample?
Yes, but I'm using the testing framework from the call contract.
Okay.
I'm not sure like this thing like what does it work? What it does like source.
So you're in the JavaScript right now. So you're looking at the JavaScript code that deploys the NFT linker code sample. So it's not just a testing framework. It's also the thing that deploys the contract to the blockchain, to the local blockchain or to the testnet blockchain.
So can I just?
So if you call the method breed from the JavaScript, then you are the thing that is breeding, not an interchain call. But obviously that's a step forward, and then that would let you then figure out, hey, if I can get it to work, this breed method, then I can get that breed method to be executed by an execute method. In an interchain execution.
Destination address, but I need to first deploy it to get address, right? Or where does this address come from? Destination contract address message.
That contract.address, I believe, comes from the contract deployment that happens earlier in the deploy method.
Okay, so if I try.
All right, it looks like Gerd is at the stage where he's now figuring out how do I pay for an interchain call. So when you're using Axelar to send messages across multiple blockchains, there's this really helpful service called iAxelar Gas Service. The Axelar Gas Service is basically a way for you to pay native tokens, and then those native tokens will be used and converted as necessary to pay for the Axelar consensus, so paying for gas on the Axelar network, and paying for gas on the destination chain. All right, Gerd has a merge NFT option that's encoding the payload.
So this one, and then I can basically do the.
It looks like that merge option is actually what he's going to use to initiate the call out to the second blockchain. And then in his execute method, he's decoding that in order to get back out all the parameters that he passed in.
Linker.
So Johnson's making really good use of the Axelar examples repo, where basically you have this ganache setup of all the different blockchains, and you've got this hard hat setup of these index.js scripts that are responsible for deploying, testing, and executing all of these different options.
Options, not the.
So what Johnson's running into here is the JavaScript for deploying and executing has a lot of functions that we may or may not need in terms of like being able to take extra arguments. So for example, if you're trying out the call contract example in the Axelar examples repo, what you're going to see is that it allows you to actually pass in any message you want, any source chain, any destination, and it will use those to deploy your example code to the right chains. You can see how this would be very valuable as a smart contract developer because, hey, we can't just assume that we're always going from Polygon to Avalanche, right? We want to think through all of the chains that we support and make them dynamic so you could actually pass that on to a more dynamic testing framework.
Option is not defined.
All right, Gerd has the gas. There's a typo in your gas service. I don't know if that's a problem. It's gas service.
No, I was just copy pasting it, or maybe that's just.
It's the not the interface, the name of your variable. Serve.
Sorry.
Yeah. All right, we've got 4 minutes left on the clock. We're going to start a very official timer on my phone that will beep as soon as the time runs out. And the moment that the time runs out, no matter where we are, no matter how close we are, we're going to all stand up and give both of these participants a huge round of applause, but not till the timer goes off.
Destination dot is not defined.
Okay, so they stay.
Johnson continues to fight with JavaScript. One of my friends in blockchain, Patrick Collins, hates JavaScript. And so he would say that the reason for most of the failures is just pure JavaScript. Like Solidity is this pure golden language, and JavaScript is the problem. But he also doesn't use semicolons in his JavaScript, and so I get very confused. All right, looks like Gerd is getting very, very close. He's got a merge NFT function that takes the token ID, the destination chain. He's got a bunch of parameters. He's encoding a payload. He's calling contract. One thing I think he might be missing is the paying the gas receiver, but that could go right before a contract call. And he could probably just copy and paste that code from the example here, which is exactly what he's doing.
So it's not compiling. There's some.
All right, we've got a hard hat compilation error.
Gas receiver. Okay, well, let me.
So you're trying to instantiate Axelar gas service with an address that doesn't exist at that place.
No. It says address source relevant for modifier.
Wait, how do I actually
that's probably the line break.
All right, we got 2 minutes left. We're coming down the wire here. We're going to see how far we get. So again, the challenge was to create a pair of breedable NFTs that live on multiple blockchains, are able to communicate, and when one initiates a breeding event with the other one, we mint a new NFT. You can see how this would be universally applicable to every Interchain dApp out there, right?
Okay, what's going on?
What does this even mean?
It's not pay, but
all right, so Johnson's actually got automatic token minting implemented. So this is part of that magic of that index.js file, where it actually handles a lot of the execution and setup. So you've got a deploy method, and you've got an execute method. And so what he's got is he's automatically deploying and minting as part of his setup process all the way from index.js. I don't actually know how Gerd is doing the initial mint of the NFTs that he's got here. We've got the old debugging technique of comment everything out until it works, which is a tried and true technique.
So this one, the contract.
All right, we are down to the last minute here, folks. I think this is going to come down to an audience judgment. And so in about 55 seconds, I'm going to tell my phone is going to beep. We're going to tell the participants to stop. We're all going to stand up, give them a round of applause, and then we're going to help pick the winners. So think about what they've accomplished here in terms of what tools they've used, how far they've gotten towards the challenge. Think about style points for like how they're using the tools that they've got, how readable their code is, how talented they were at using AI. All these sorts of different things are going to come into the final judgment, but it's up to you. We're just going to do it by round of applause.
Wait, quick question. Like, actually, I forgot like how this chain, like, destination chain, like actually constructed.
How is the designate? How are you constructing the NFT on the designated chain? That is a question for another day. 3, 2, 1. Beep, 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 beep. Let's stand up, stand up.
Okay.
Fantastic job to both of our participants here. All right, so we're going to do applause to figure out who won. All right, let's hear it for, but first, big applause for everyone. So, Johnson, everybody, applause. Gerd, applause. All right, and now to see who won. Who thinks Johnson won? Okay, yeah. And who thinks Gerd won?
Didn't work.
All right, so by audience consensus, decentralized consensus, thank you. Gerd has won the challenge. Thank you so much for being part of this Interchain Interop speedrunning, developer speedrunning, this esports that I'm trying to make a thing. And have a fantastic night. I don't actually know. Galen, are you coming back up? See, this is what happens when you, it's called nerd sniping. They're both going to sit here trying to fix this for the next half hour. I'm going to have to cut them off and drag them off stage.
There's a happy hour across the street at Lester Pearl. I don't know if anybody told you all, but I guess we won't be seeing you.
When you give intelligent people a challenge, they're like, oh, now I have to solve this challenge. But we've got to kick everybody off the stage here. Thank you guys again.
All right. Big round of applause. One more big round of applause for speedrunning. That was awesome. That was a lot of fun. So, yes, a few numbers that you need to know. 6:30 is the time until which happy hour is open at Lester Pearl across 26th Street. What else? Oh, 8:30. That's the time in the morning tomorrow when the Biddle Breakfast kicks off right here at Green Spaces. That is investors, ecosystem funds here looking to deploy capital, looking to meet startups. If you are raising capital for your startup, for your project, come through. We'll have some breakfast. What else? Oh, what's the elevation of the city of Denver? Does anybody know? Is it 5,000? It's 5,000 feet? Well, that's another number you need to know, right? For all you flat earthers, okay? Elevation is real, okay? Altitude is real, so don't drink too much tonight. Every beer, drink a glass of water. All right? Everybody have fun, and we'll see you again here tomorrow.